Welcome. This is your Captain Shreyas, and what a beautiful Sunday morning. After the midnight session till 2 3 o'clock, for all the students of JEE 2026, we are back with subject marathons. And thank you for all the love that you guys have shown. And it's time for the sure short topics. These topics we have not randomly picked, or it's not because I feel they are important. I don't even feel that they might be important. It is based on facts, because these 31 topics have repeated again and again and again. And remember, your JEE physics paper will only have 25 questions. That means I'm giving you more than 25 topics, which make sure that 100% guys, these topics will be repeated in some or the other way in those 25 questions. So that will give you a big boost in your marks, and it will also tell you what you need to study properly and how much you need to practice more. Okay, so let's get started. With me, your Captain Shreyas, your physics master teacher on the Vedantu JEE English channel, the #1 JEE English channel in the country. And nice to see you all on this lovely Sunday morning. Hi Tanishwari, King Cobra, Sai, welcome. Darshan, justice for whom? Om, welcome. Notes will be provided later on. Hi Saiti, hi Manjula, good morning. Yes sir, smash that like button right away, right now. Come on. Hi Rama, nice to see you back. All our regular warriors are also here. Yes, smash that like button. Let's make it 100 at least. Yeah? Join in. Come on. Why only 60 people? Come on. Call your friends. Send the message. Share the status. Shreyas Sir is live. Yes, right away, right now. Okay? Come on. Good morning. Good morning. Oh, Shreyas Srinivas is also here. My duplicate name. Yeah. Hi, Satya. Suma. Nitish, welcome. Ibbu, nice to see you after a long time. Sigma Warrior is also present. Cool. Let's go. Let's start. This is my small introduction. I already know most of you out here, and I guess we'll get to know each other if you keep visiting. Okay, by the way, the PYQ book, I have just got it. I'm going to make a video of the unpacking. I have already shot one part of it. I've got my PYQ books just yesterday. Okay, so get yours right now, because this has 143 shift questions, and these books are very big, and it has solutions. It has literally segregation of the topics and chapters and arranged in a very beautiful manner. And I will show it to you also. The link for buying this particular book is down there in the description box, as you can see. Just click on that particular link and it will open up, that particular page. Enter your address, phone number, details, so that you will get maximum price benefit when you're buying from the channel during Diwali. Yes, this is at 30% off, so that's why you are getting this particular price. Okay, so my dear warriors, it has literally everything. Use this, because you cannot sit and study from coaching modules right now. Okay, so the first topic, I had given you the PDF yesterday. I have told you all the topics, so you already are aware of the topics. So we'll start with 11th standard topics first sequentially. We'll take a break and then we'll go to the 12th standard topics. That is the flow, minimum 3-hour class. So let's start. Dimensional analysis. Okay. And what is the use of dimensional analysis? Now, if I talk about dimensions of a body are nothing but the powers to which dimensions of a physical quantity, dimensions of any physical quantity is nothing but the powers to which the fundamental quantities should be raised. Fundamental quantities should be raised. And which are the fundamental quantities? Which are those fundamental quantities? One is mass, whose dimensional formula is given by m, or symbol is given by m. Then you have length. Remember, mass, length, symbol for length is L. Then you also have time, which is T. Charge is not a fundamental quantity. Current is a fundamental quantity. Common mistake which many kids do. So ampere, A. Then you also have temperature, 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 and the symbol for that is K. Remember that. Then which other is your fundamental quantity? Your luminous intensity. Luminous, luminous intensity. That symbol is CD. And lastly, you have amount of a substance, amount of a substance, and that is nothing but mole. That is nothing but mole, MOL. You also have two auxiliary units. One is angle, which does not have any dimensions, and then you also have solid angle, and then you have the three-dimensional angle, which is solid angle, which is also dimensionless quantity. Keep this in mind. Yeah. So when you express any physical quantity in these terms, then you get the dimensions of that quantity. Just to give you an example of it, imagine I tell you what is the dimension of volume. Volume, if you remember, is nothing but length into breadth into height. Usually length, breadth and height are all fundamentally lengths only, so it is basically length cube. Similarly, another example, if I tell you what is the dimensional formula of density, then you will just say density is nothing but mass by volume. Mass is nothing but m, as you can see, and volume we just figured out dimensionally is L cube, so it is m raised to 1 L raised to minus 3. That's the dimensional formula for density. So that is how you figure out the dimensional formulas. If you know the normal formula of any physical quantity, you give me the formula, I can get the dimensional formula as well in terms of the fundamental. Another example, let's say charge. If I ask you what is the dimensional formula for charge, charge is nothing but current multiplied by the time for which it flows. Current is nothing but ampere and time is nothing but t. So a raised to 1, t raised to 1. That is the formula. Now, when do you use dimensional analysis? Multiple reasons, like you can see over here, to check the correctness of the equations, derive relationships, converging units, and also, for non-dimensional numbers, you can see, you can basically, it is the second one only, derive relationships. You can make non-dimensional numbers like Reynolds number, etc., which is used in fluid mechanics. Okay, we'll understand each one of them separately. See, whenever you have an equation, it has to be dimensionally correct, meaning whatever dimensions are there on the left hand side should be equal to the dimensions on the right hand side. So the dimensions on the left hand side should be equal to the dimensions on the right hand side. Only then it is said to be dimensionally consistent or dimensionally correct. Also, whenever you have a quantity and you add it to another quantity or you subtract it from another quantity, all their dimensions should be the same. Only then you can add and subtract them. Okay, so this is allowed, this is allowed. The dimensions on LHS and RHS should be equal, and whenever you add and subtract, the dimension should be same. Meaning, I can add a length with a length and subtract it with a length, but I can never add a length with a mass, or subtract it with time. This is incorrect. Only this is allowed. Kind of makes sense. Yeah, everybody with me? Also remember, whenever you have to multiply and divide, there is no such rule. You can multiply any two quantities like mass into time. I can multiply mass by volume is density. I can divide, multiply. There is no restriction on that. Only restriction is when you put equal to symbol, plus and minus. Only these three symbols, the dimensions have to be same. That is the first basically application of dimensional analysis. Then let's go to the third one, conversion of units. Conversion of units. Say for example, I tell you, there is a dimensional formula of a quantity. I want to convert it from SI units to CGS units. The logic is always the same. For a physical quantity, the magnitude and the units multiplication is always the same. So N1 U1 is N2 U2. What is N? What is U? N is nothing but magnitude. Say for example, I tell 2. U is, let's say, unit, say meters, then in centimeters, that will become 200. So the magnitude will change, but so will the unit. So this is what the dimensional analysis is used for converting from one unit to the other unit in case if it is needed. And remember, magnitude into unit, the product is always going to be a constant. You can also write it, extend it like this, say N3U3, and maybe I can say I want to write it in millimeters. The third unit is millimeters. So 200 centimeters means it will be 2000 millimeters. So the value will change, and the reason for that is the unit. Everybody clear about this? Okay. So say for example, I have been given, say for example, I have been given there is some kind of physical quantity, there is some kind of physical quantity whose dimensional formula, whose dimensional formula is mass square length raised to -1 t raised to 3. Okay, Chumma I have taken this. I want to find out how much is 1 SI unit, how much is 1 SI unit in CGS unit, in CGS unit. 1 SI unit is how many CGS unit? N1 U1 is equal to N2 U2. I want to find what is N2. How do we do such a problem? Observe this carefully now. Observe this. So I will just go on to the next slide. Okay. So in order to solve this particular problem, first of all, I know in order to solve this particular problem, I know that my physical quantity dimension is already mentioned as m raised to 2, L raised to -1, T raised to 2, T raised to 2, sorry, T raised to 3, my bad, T raised to 3. Figure out the conversion for every single one of them, like mass separate, length separate, and time separate. Okay, like for example, 1 kg, this is SI unit, mass in CGS will be 10 to the power 3 gram. Then for length, 1 meter SI unit is nothing but 100 or basically 10 to the power 2 centimeter. In SI unit, 1 second, CGS unit also, it is 1 second only. So everything on this side is nothing but SI unit, everything on this side is nothing but CGS unit. I'll just keep it in mind or keep it on the sidelines. Now what you do, just mention how much is exactly 1 SI unit of the physical quantity, of that particular physical quantity. It is nothing but, this is mass square, that means it is 1 kg whole square, length raised to -1, that means 1 meter raised to -1, time cube, time is 1 second, and whole cube. Now you just substitute what 1 kg, 1 meter and 1 second is. 1 kg is 10 to the power 3 grams. So square. 1 meter is nothing but 10 to the power 2 centimeter, but raised to -1. 1 second is 1 second only, whole cube. So what will this exactly become? 10 raised to 3 raised to 2 is 10 to the power 6 and into gram square, into 10 raised to 2 raised to -1 is 10 raised to -2 centimeter raised to -2, and this is nothing but second cube. 1 cube is 1, so second cube. So 10 raised to 6 and 10 raised to -2 will become 10 raised to 4. This will become gram square centimeter, sorry, not -2, -1, centimeter raised to -1 and second cube. Is that right? So this is nothing but the CGS unit. So this is 10 raised to 4 CGS unit. So we have found the conversion factor, guys. So this question mark is nothing but 10 raised to 4. So the moment you know the dimensional formula, easily you can figure out the conversion factor. Is that absolutely clear? Yes, Pranesh, I changed it to -1 centimeter raised to -1. Perfect. Amazing. All right. So, King Cobra, maybe I can answer your doubt later on. So, like for me, 2 days, say I have maths full revision in India. You can put it up in the comments. I will answer it because now I'm in the flow. Okay. So, let's do some more questions, guys, now on your screen. But before that, the third application where you want to figure out the dimensional formula or find a dimensionless ratio and stuff like that. Imagine I tell you, there is a number, there is a number. So this is a third application to find, in order to find the dimension, in order to find the formula, in order to find the formula. Okay. So this is just an example. There is a dimensionless, dimensionless number which depends on, which depends on density, mass, or let's say force, density, or let's say momentum, density, momentum, and let's say time, density, momentum, and time. Okay. Question is find the relationship. Find that relationship. Find that relationship. This is basically using dimensional analysis to find any formula. Look at this. It depends on density, momentum, and time. And we want to figure out what kind of relationship it might hold. So let's assume that dimensionless number is, let's say, x, and that x is dependent on this density, or we can take n actually over here. Let the dimensionless number be n. So it is density raised to x, momentum raised to y, and time raised to z. Just assume that the number depends on density, momentum, and time with this following relationship, where x, y, and z are some random variables which I have to figure out, because that's the question. So what I will do now, I will say, therefore, the dimension of n, which is on the left hand side, will be the dimension of density raised to x, the dimension of momentum raised to y, and the dimension of time, whole thing raised to z. But this is a dimensionless number. That is what the question says. So this is dimensionless absolutely. Dimension of density, it's mass by volume. So mass by volume, that means length cube with a negative power, whole thing raised to x. Momentum is mass into velocity. Mass is m. Velocity is meters per second. So length per unit time, whole thing raised to y. Time is time only. So t raised to z. That's it. So if you rewrite it in a slightly better way, collecting all the mass terms, mass is raised to the power x here. It is raised to the power y here. There is no mass on the other side. Length is raised to minus 3x and also y over here. Time is raised to minus y and z over here. That's it. So we have got the final simplification where mass, length, and time are combined together with their powers. Now compare it on the left hand side. If you see, it is a dimensionless number, means what? The mass power is 0, length power is 0, times power is also 0. So just compare and you will get the answer. For example, for mass, 0 is the power here. So right hand side also, by dimensional consistency, it should be equal. So therefore, y is equal to minus x. Therefore, y is basically equal to minus x. Similarly, over here, if you notice, length power is 0. Length power is 0. So here also this should be minus 3x plus y. But wait a minute, y is minus 3x. Sorry, y is minus x. So therefore, y is minus x. That is equal to 0, as you can see, right? So therefore, what do you get? Therefore, what do you get, guys? 4x. Therefore, you will get 4x is basically 0. Therefore, you will get basically 4 times of x, because y was nothing but minus x. So you just substitute it over here. So 4x is nothing but 0. Therefore, x is 0. If x is 0, that means y is also 0. Y is also 0. And then last thing over here, this number times power is 0. Times power is 0. Here also minus y plus z is equal to 0. But y itself was 0. So therefore, z is 0. So if I'm getting all the powers as 0, 0, 0, that means this number is density raised to 0, momentum raised to 0, time raised to 0, which means that no such relationship is possible. Yes, no such relationship is possible using this number. Such answers can also come in the JEE exam. Fourth option will be there. Then D option, none of these. So this means that none of the above. None of the above. And the reason for that, since it is not possible, as simple as that. It is not possible using these to get a relationship. And there is also a reason for it, because density had the dimension of length. The length dimension could not be cancelled for some reason with the any other things over here. Okay, so that is the problem. Got it? Okay. Fine, guys. Shall we go ahead? Okay. Right. Let's do this particular question. Let's see if you can get it. The expression given below shows the velocity with time. V is AT square plus BT by C plus T, the dimension of ABC. This was asked in JEE 2025. Come on. Hi, Vasanta Lakshmi, welcome aboard. Super Jasham, very good. What is the correct answer for dimension of ABC? Now, if you notice over here, V, AT square and this, all of them should have the same dimension. So because they are being added and one is LHS, one is RHS. So dimension of velocity should be same as dimension of AT square, which should also be the same as the dimension of BT by C plus T, of course. Okay. So over here, if you just consider these two, velocity is dimensionally length per unit time. Length per unit time. Dimension of A I do not know. T square means T raised to 2. So therefore, dimension of A will be how much, guys? T square goes on this side. So length raised to 1, T raised to minus 3. Is that right? T square will go over here. Minus 1 minus 2 is minus 3. So A part is done. Let's think about B and C. Now, if you are adding C with T, it kind of makes sense that if you are adding C with T, the dimension of C should be equal to the dimension of T, which means it should be nothing but T raised to 1. So the denominator over here, I already know what it should be. Okay, last thing. Okay, last thing, which is, let's say over here, velocity dimension should also be equal to this. So dimension of velocity should be the dimension of B into the dimension of T upon whatever is below, that is also the dimension of T. Is that right? T plus C means T and C have the same dimension, so they are also T. T will get cancelled. So what do I get then? The dimension of velocity is the dimension of B, which means B has the dimension of length raised to 1, T raised to minus 1. Okay. Now comes the final part where you have to figure out A into B into C's dimension. A into B into C. That is what the question is. A is nothing but L raised to 1, T raised to minus 3. B is nothing but L raised to 1, T raised to minus 1. C is nothing but, I think we figured it out, it was just T raised to 1. So how much is it coming out to be? L1 will make it L2. Minus 3 minus 1 is minus 4. Minus 4 plus 1 is again minus 3. So L2 T raised to minus 3. L2 T raised to minus 3. Is it there somewhere? Yes, option number 1. Got it? Yes, the first option. Very good, Srikar. Yes, Rama, very good. Amazing, King Cobra. Very good, Vasanta Lakshmi Ibu. Very nice. Sai, it is not fourth, it is the first option. Yep. Awesome, awesome, awesome. Many of you gave the right answer. So this kind of questions will come. I hope you have geared up some confidence now. Can we go ahead, guys? Yeah, can we go ahead? All right, great. So this is one question which came from electromagnetic waves. I'm pretty sure you will be able to solve this if you remember that formula. Else, it's okay. I will show it to you. Sometimes they will combine 2-3 chapters together. Look at it. Flux is combined with dimensional formula. How do we solve it? Electric flux, magnetic flux has the dimension of blah, 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 where the value of Q and R are how much? Now, what is the question? Ratio of electric flux and magnetic flux. Ratio. So, electric flux by magnetic flux. Electric flux is electric field into area. Magnetic flux is magnetic field into area. So, it will be E by B. But do not waste your time finding electric and magnetic fields dimension. This is a standard ratio. This is nothing but speed of light. Speed of light. E by B, electromagnetic waves. How many of you remember this? 1 by root mu naught epsilon naught is speed of light, which is E by B. Yeah, standard formula. So, if at all you want to figure out the dimension of electric flux by the dimension of magnetic flux, just find the dimension of speed of light, which is L raised to 1 T raised to minus 1. So, if you write it in this form, it will look like this. M's power is 0, L's power is 1, times power is minus 1, ampere's power is 0. So we have figured out our answer. There was Q and R, Q and R, Q and R. This is Q, L's power, times power is R. So 1 and minus 1, which means the fourth option is the right answer. Got it? So multiple chapters can be combined. Flux chapter is there. Also electromagnetic waves chapter is there, and dimensional formula. Very good. Excellent. Let's go to the next one. The units and dimensions chapter has maximum weightage, guys. You will see every single paper has this particular question. Okay, at least one question, sometimes two questions were there in the same 25 question sets. Okay, errors in measurements, types of errors, systematic errors which are based on a system, means they get repeated again and again because of the manner in which you are performing the experiment. Like an instrument itself can have some zero error. The instrument itself has some kind of mistake in it, because of which you are consistently getting that same error. And you are going to see that if you change the instrument or change the method, the systematic errors can be minimized or can be becoming more also. Random errors, you cannot predict them. Maybe temperature change somewhere, so some length change, so because of it something happened to the experiment. So it is unpredictable. That is why they are called completely random errors. But yes, you can reduce the randomness by conducting the experiment at different times of the day, by different people, at different places. So if there is some variation, that slowly gets minimized on an average. Now, what are the different ways in which you can find the errors? One is the actual absolute error, meaning the most expected value, that is the true value, and whatever you are getting, the difference of that is called absolute error. Let's say the actual length is 5.2 meters, but you measure it to be maybe 5.14 meters. So what is the difference then? What is the difference then? It is nothing but 0.06. So that is nothing but the absolute error. Is that clear, everyone? Yeah. So that is nothing but absolute error. So the difference between the actual value versus what you are measuring, or what you are expecting the value to be, minus the measured value that you are getting, the mod value. Relative error, whatever is the absolute error by the most expected value. Maybe you got some measurement like this. Let's say the mass is 10 kilos plus or minus 0.2 kg. So this then becomes your absolute error. One second, guys. Yeah. So this is nothing but your absolute error. So relative error will be nothing. Relative error will be nothing but 0.2 divided by 10. So this is like a fraction, right? But if you multiply it by 100, 0.2 divided by 10 multiplied by 100, you will get percentage error. So 10 into 0.2 will be 2. So 2% error is there. So percentage error is when you take the relative error and multiply it by 100. So how much fraction you have into 100? That is the percentage of variations that might be there in that measurement. You are not so sure about it. That's the uncertainty percentage. I tell 1% uncertainty is there, meaning of the 100 things that I measured, 1% I'm not really sure about. So that is acceptable. But 5%, 6%, 10%, becomes slightly unacceptable. Okay, and if it is less than 1%, 2%, you generally say it's fine. Okay, great. So let's move ahead. How do I calculate errors of two or more quantities, whether they are added, subtracted, multiplied, divided? When they are added, you just take the absolute errors and add them, even when they are subtracted rather. So for addition and subtraction, just add the absolute errors. So for example, I have 3 plus minus 0.6, 5 plus minus 0.2, okay, and then let's say 7 plus minus 0.1, and this is 3 plus minus 0.4, okay, and here I want to subtract them, here I want to add them. So the final answer, guys, when you're adding them, just add these numbers 3 and 5, that will give me 8. Add this also, 0.6 and 0.2 will give you 0.8 in this case, so plus minus. So the absolute errors will always add, irrespective of whether you are adding them or subtracting them. Same way here, 7 plus minus 0.1, 3 plus minus 0.4, when you subtract them, 7 minus 3 is 4, but here don't subtract it, it will still be addition. So 0.1 and 0.4 will give me 0.5. So this is the catch. A lot of students make a mistake, they subtract these two also. So whenever two quantities themselves having some margin of error being added or being removed, subtracted, their total final quantity is to be found by this method. The next one, when you are having multiplication, etc., then what do you do? So if you have a physical quantity which is some constant into one physical quantity raised to x, another physical quantity raised to y, another physical quantity raised to z, and all of that, then the relative error in this quantity, forget the constant, is relative error in the first quantity, relative error in the second quantity, relative error in the third quantity, and you take the powers mod value, and just add them. Take the powers mod value and just you have to add them. I'll tell you with an example, then only you will understand. Say I tell you, there is some quantity like time, which is root of 2h by g, which is as good as saying root of 2 into h raised to half into g raised to minus half. So this is physical quantity, this is the constant, this is the first quantity raised to power, this is the second quantity raised to some power. There could have been more variables also. Then the relative error in time is, forget the constant, relative error in h, relative error in g. Now take the powers mod value, means half, and this is half again, and just add them. So if somebody tells you the error in h, example, is 2%, and the error in g is, let's say, 0.4%, chumma, I have told some random values, then what is the error in the measurement of time? So put 2% over here, 2% divided by 2 plus half into 0.4%, which is 1%, plus 0.2%, which is 1.2%. So the time will have an error or uncertainty of 1.2%. So that is how you use this particular formula. Yeah, right? Yeah, we'll come to vernier also. Don't worry. Okay, let's see if you can solve this. Resistance is given by this and this. The percentage error in the measurement is how much? Come on, my dear warriors. What is the percentage error in the measurement? That is the question. Very, very common model of question. Every single paper you will see this. So as you can see, R is nothing but V by I, means V raised to 1 into current raised to minus 1. Therefore, delta R by R is 1 multiplied by relative error in voltage plus, take the mod value which is 1 only, relative error in the current. As you can see, the voltage has an error of 5, absolutely, and most certain value might be 200, plus the error in current is zero point 0.2 and most probable value is 20. So that is what I'm going to substitute over here. 5 by 200, guys, that is nothing but 1 by 40, I believe, plus 0.2 by 20, it is nothing but 1 by 100. Okay, so if you take the LCM, I think it will be again 200. So this will become 5 times and this will become 2 times. So this will be 7 by 200. But that is not what I have to leave the answer to. See, if you just use this particular relationship, then resistance is voltage by current. Voltage is 200 most likely. Current is 20. That means it is nothing but 10 ohms. So in this particular relationship, delta R I have to find. Oh, I don't have to find delta R, my bad. I just have to find percentage error in the measurement of R. So sorry, guys. This was not needed also. Anyways, just forget it, whatever I just did. So we have to find just percentage error in resistance. It will be delta R by R multiplied by 100. This step was not needed. Okay, my bad. I thought we had to find delta R. So this value is nothing but 7 by, how much is it? 200. 7 by 200 multiplied by 100. So that's it. 0, 0 cancels. So 7 by 2, which means 3.5%. So 3.5% will be the answer, which is right over here. Option number 1. Yeah, very good. If delta R was asked, then you would substitute it over here. If delta R was asked, then you will substitute this R, which is 10 over here. Then taking 10 on this side, 0, 0 will cancel. 7 by 20 will be delta R. Okay, if it was asked. Now it is not asked. So just leave it over there. All right. Let's go, guys, to the next question coming up on your screen. And here it is. Let's see if you guys can figure this out. The percentage error in measurement of length and the diameter is given. It's 0.1% each. Then the error percentage of resistance of the wire. Now, resistance of a wire, if you remember from current electricity chapter, is nothing but rho L divided by area. And rho is resistivity, length is length, area is nothing but pi r square. But radius is diameter by 2. So I can also write pi d square by 2 square, which is 4. So it will become rho 4 with pi over here, length raised to 2 and diameter raised to -2. Take diameter on the top, length on the top, always keep the variables on the numerator, never in the denominator. Now we can figure out what is the relative errors. So relative error in the resistance is, this is a constant, so forget it. Relative error in length, but the power is 2, so multiply 2 times. Relative error in diameter, but the power is -2, take the mod value, which is again 2. Okay, now how much is the percentage in length and diameter error wise? It is 0.1%. So 0.1% error is there here. Diameter also has 0.1% error over here. So 0.2 plus 0.2 will make it 0.4%. So 0.4% is the error in the resistance of the wire. 0.4% is the error in the resistance of the wire. Yes, very good, Syed. Yeah. How I square? Where I square, man? You mean here? This is length square, not I. This is length. This is length. Why did length square come? Oh, sorry, guys. My bad. Something silly mistake I have done. Some silly mistake I did. I'm so sorry. By mistake, I put length square. Yeah. Thank you for pointing it out. So sorry. Length was there. Area is nothing but pi r square. So by mistake, I did it. So pi, and this is d square by 4. So this will become 4 rho by pi. Length is there. D square will go on the top, will make it d raised to -2. So now if I write relative error in R, it will be, this is a constant, so forget it. Length's power is 1, so delta L by L 1 time, plus diameter's power is nothing but 2. So 2 into delta D divided by D. Is that fine? So percentage wise, how much is the error in length? It is 0.1%. Percentage wise, how much is the error in diameter? That is also 0.1%. So 0.1 plus 0.2 will make it 0.3%. So this should be the answer. This should be the answer. Okay? My bad. By mistake, I had put L raised to power 2. That is wrong. It was L raised to 1. Yes. First option. Yeah. 11th portion and then 12th portion, not full portion. We are just doing most repeated chapters, or sorry, most repeated subtopics. But in units and dimensions, these 3-4 subtopics, it almost becomes like the full chapter. Almost. Okay. So I'm doing the most repeated things in every grade, guys, 11th and 12th. And there are some chapters which do not get repeated at all. You will see now. And some chapters which get repeated again and again. And in that many topics come. Sometimes one topic will come. So why do you want to waste time? Whole thing. If you focus on the main subtopics, your 60% of the weightage of the paper is done. So out of 100 marks, easily you can get 60 marks. And after that, for the 40 marks, you will take your next 1 or 2 months. That is a smart move. Okay. Vernier caliper. Let's recollect all the formulas. What are the formulas for vernier caliper? So you will be always given that some main scale division coincides with some main scale division coincides with the vernier scale, with the vernier scale. Like for example, it will be told to you there are, let's say, 11 divisions of the vernier scale that coincide with 10 divisions of main scale, and one main scale is 1 millimeter each, or let's say it is a very special vernier caliper. Let's say it is 0.5 millimeter. It can be any kind of vernier caliper, guys, a special vernier caliper, a standard vernier caliper, whatever. So usually this is given to you. From this, always try to figure out what is one division of vernier scale. One division of vernier scale is nothing but got by the following. So one division of vernier scale. See, 11 divisions coincides with 10 divisions of main scale, meaning 11 divisions of vernier scale is 10 divisions of main scale. Each main scale is 0.5 millimeters. So it is nothing but 5 millimeters in length. 11 divisions of main scale in length is 5 millimeters, because each main scale is 0.5, 0.5, 0.5 each. So 10 such 0.5 will make it 5 millimeters. So what will be one division of vernier scale? It will be nothing but 5 millimeters divided by 11. That is what one vernier scale division is. Lastly, what you should do is finding the least count. The least count. The least count is always the mod of one vernier scale division minus one main scale division. One vernier scale minus one main scale division will always give the least count. So in this particular example, the least count will be one vernier scale division is nothing but 5 by 11. One main scale is nothing but just 0.5. So this is nothing but 5 by 11 minus 5 by 10. So what is it going to be, guys? Yes, 5 is common. Just forget it outside. So mod of 1 by 10 minus 1 by 11 will be better, because 1 by 11 is smaller. 1 by 11 will be smaller. So if you want to get rid of the mod, put 1 by 10 first minus 1 by 11. So this you can just take the LCM. It will be 10 multiplied by 11 and it will be 11 minus 10. So how much will it be? 11 minus 10 is 1. 5 by 10 is 2. So it will be 1 by 22 of a millimeter. So this is the least count. This is the least count of it. I hope this is absolutely clear. Absolutely, absolutely clear. This is how you can find the least count. Once you get the least count, you can easily get whatever is the reading. If you want to find out the reading, if you want to find the reading, so remember the reading formula. The reading is always whatever is the main scale reading plus least count into division which coincides. Division which coincides. Say for example, there is a question which is given, the least count is 0.1 millimeters and the main scale reading is fifth division, and the division of vernier caliper that coincides on some main scale is 4, then my reading is as follows. Main scale reading is 5, so put 5 millimeters as it is, plus least count is 0.1. Okay, the division which coincides is 4 already given, so hence it will be 5 and this is 0.4, so 5.4 millimeter. That's how you can find the reading of a vernier caliper. Main scale reading plus least count into the vernier scale division which coincides. Okay, so these two things are very, very important. Very, very important. If you want detailed classes of this also, they are available on our channel itself. If you go over here, right? If you go to, where is this? Class 11. Okay, this beautiful playlist is there. I have already taught it, right? So this was the basics, units and dimensions, significant figures, vernier, micrometer. I have taken it for 2 hours. So if you want detailed classes also, that is also available, right? Okay. So let's do a question based on this, which was asked in JEE 2025. This will clarify your doubts even better. One main scale division is equal to m units. If nth division of the main scale coincides with nth plus 1th division of the vernier scale, the least count of the vernier caliper is how much? Yeah, that's what. Rama, we are taking up one more example so that you will understand it. Let's understand. Here, one main scale division is nothing but m units. Is nothing but m units. Okay, is equal one main scale division of a vernier caliper is m units. If nth division, so this is your main scale, each is m millimeters, m millimeters, m millimeters, whatever it is. This is your main scale. It is given to me the nth division of the main scale. Nth division means maybe this is nth division. Let's say this is 1, 2, 3, so on and so forth. This is the nth division of the main scale. Coincides with, if you take the total length upon number of divisions. How much is the total length? M into n. Number of divisions, n plus 1. Everyone fine? One division vernier caliper we have found. Now let's figure out, is there a lag? Just check it now. Refresh, refresh, refresh. Hello? Is it fine? It's fine, it's fine. Okay, great. Now, least count. The formula was 1 division of main scale, 1 division of vernier scale. You just have to subtract it. So, what is 1 main scale division? It's already mentioned. It is equal to m units. So, put m over here. What is 1 vernier scale division? What is 1 vernier scale division? It was mn divided by n plus 1. It's obvious this is bigger in denominator. So this number is smaller than this number. So no need of putting mod. So I'll just take m common and I'll put 1 minus n by n plus 1 because I know this number will be smaller than 1. So this will be m multiplied by n plus 1 minus n after taking the LCM as n plus 1. So this will be m into N and N will cancel, and I'll be left with 1 divided by N plus 1. That's it over here. So it is as good as saying M divided by N plus 1. M divided by N plus 1 is the second option. Is this absolutely clear, my dear students? Yeah, the second option. Now, are you getting? How many of you got that confidence? Yes, sir. Now I will be able to do it. How many of you got that confidence now? Yes? No? Perfect? Awesome. 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 So sometimes you might be given a diagram based question also. Something like this maybe. This could be your main scale. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then they can give you the vernier scale maybe like this. This could be the vernier scale. This could be 0. Something like this. And they might tell you that the least count is 0.1 millimeter. Can you figure out what is the reading shown over here? What is the reading shown over here? This is your regular vernier caliper. Okay. So first of all, let's understand in such a question. This is your main scale, and this one, the yellow one, is your vernier scale. Always look at what is MSR, vernier scale reading, least count. Only then you can find out what is the final answer. So my reading is nothing but main scale reading plus least count multiplied by vernier scale which coincides. Vernier scale which coincides. What is main scale reading? Main scale reading is always that number which is crossed by the vernier caliper. So if you see, this is the main scale, 1 division, 2nd division, 3rd division, 4th division, 5th division, like that. The vernier scale has to cross it. So if you notice and observe carefully, this is that division which has been crossed by the 0. This has not yet been crossed. So this is 1 millimeter, 2 millimeter, 3 millimeter. So this is your main scale reading, which is 3 millimeter. Is that absolutely clear? That is the number, that marking which has to be basically crossed on the main scale. Next, which is that marking which is coinciding with something on the main scale. If you observe, this is not coinciding, this is not, this is not, this is. So there is a coincidence over here, as you can see. One main scale is coinciding with a vernier caliper. Don't measure main scale, measure this. 1, 2, 3, 4. This is 4th division which is coinciding. 4th division which is basically coinciding. Once this is done, you can easily solve the problem. Main scale reading is 3 millimeters. Least count is 0.1 millimeters. The vernier scale division which coincides is 4. So this will be 3 plus 0.4, which is 3.4 millimeters. Is that clear, everyone? Everyone? Yeah. So this is how you can solve those picture or diagram based questions, which are also very common in the examination. Right. So with this, let's go to the next topic of uniform accelerated motion. Acceleration, when it is constant, that is called uniform accelerated motion. So you will see that velocity time graph will be a straight line. If you draw a graph of velocity versus time, that particular graph will be a straight line, and the slope the slope will be A. That is what the speciality of uniform accelerated motion is. Also, the velocity will keep on changing uniformly. The velocity will obviously not be a constant, but acceleration is constant. That is the meaning of acceleration will be a constant. That is the meaning of uniformly accelerated motion. Many examples are there. A car hitting the accelerator and changing its speed at a constant rate, or you dropping a ball from the top of a hill, it accelerates due to gravity, which is constant, or you take something and throw it up, it accelerates due to gravity. So many such examples are there of acceleration. Or you take a block and push it on a rough surface, it will retard because of friction, so that retardation or deceleration is also constant. So that is again uniform retarded motion or accelerated motion. Okay. So, my dear warriors, whenever you have such constant acceleration, you are allowed to use kinematic equations, where if you want to find the velocity at some time t, acceleration is known. If you know initial velocity, use v is u plus at. If you want to figure out the displacement, not distance, displacement, use ut plus half at square. If you want to find velocity and displacement relationship, use v square is u square plus 2as. And if you need, you can also use displacement is average velocity multiplied by time also. These equations are only valid when acceleration is constant. Otherwise, none of these things are valid. Always keep that in mind. So let's take up some examples coming up on your screen. A BMW car, a BMW car accelerates at 6 meters per second square and brakes at 3 meters per second square after reaching top speed. If total time from start to stop is 10 seconds, find the top speed. That is the question. Question is figure out the top speed in such a scenario. Whenever kinematic equation question comes, as you can see, acceleration is constant. Try to always draw the diagram. Don't just blindly use the equation. These equations are sign sensitive. So if you miss a sign, everything will go wrong. So it's always better to draw diagram. Also think which is positive, which direction is negative, or else you will make a mess in the signs. Okay. So let's draw the diagrams. As we can see, there is a road. This particular car starts from rest. It accelerates at 6 meters per second square. It reaches its top speed, which I do not know what it is. After reaching that, it begins to decelerate at 3 meters per second square before again coming to a stop. I do not know how much time is this, how much time is this. So I will just assume this time taken is t1, this time taken is t2, but I know one thing, the total time taken is 10 seconds. The total time taken is 10 seconds. That is what is given. This is not distance, this is time. T1 is from acceleration, T2 is from deceleration or retardation. Okay, this much is given to me. So what can I do? I can see velocity, acceleration and time. There is no question of displacement. So I better stick to the first kinematic equation, which does not have S. The second and the third one definitely has. So, what do we do over here? For the acceleration part, my final velocity is initial velocity plus acceleration into time. My final velocity is v. Initial velocity is 0. Acceleration is 6. Time taken is t1. So therefore, from this, t1 will be v by 6. For retardation, final velocity is initial velocity plus acceleration into time. My final velocity is 0. Initial velocity is v now. and acceleration is negative because I'm retarding, and the time taken is t2. So therefore, t2 will be v divided by 3 again, because 3 t2 will be v. So t2 will be v by 3. Why did I find t1 and t2? Because I know at the back of my head, if I add them, I will get 10 seconds. So if I add t1 and t2, I should get 10, which is the total time. Okay, so t1 is nothing but v by 6, t2 is nothing but v by 3. So that is basically 10 as per the given question. So v is common, and you can just do 1 by 6 plus 1 by 3, LCM is 6. So 1 plus 2 is equal to 10. So what do we get? 1 plus 2 is 3. So v multiplied by 3 by 6 is equal to 10. So therefore, this is 1 by 2. So v will be nothing but 10 multiplied by 2. So therefore, velocity will be 20 meters per second. So you'll get 20 meters per second as the answer. Okay. Yeah, there is nth second formula also. I think that was missed over here. I'll just put it over here. Uh, Actually, that is the fourth equation. This is not supposed to be the fourth equation. This is just an auxiliary equation. The actual fourth equation is the displacement in the nth second formula, which is u plus a by 2 into 2n minus 1. That is what it is. Like for example, say it is given to me that the displacement in the fifth second is 11 meters. The displacement in the fifth second is 11 meters. Okay. And initial velocity is 3 meters per second. Find the acceleration. Find the acceleration. That is what is given to me. So this is based again on the fourth kinematic equation, or displacement in the nth second formula. We know displacement in any nth second is u plus acceleration by 2 into 2n minus 1. This fifth second displacement is already given to be 11 meters. Initial velocity is given to be 3. Acceleration, I do not know. The value of n over here is 5. Got it? Nth second displacement. So n over here is 5 minus 1. So 11 minus 3 is basically 8, is equal to a by 2 multiplied by 2 5s are 10, 10 minus 1 is 9. So this will become 9a is equal to 16, or rather a will be 16 by 9 meters per second square. That is the answer. Now the meaning of the word displacement in the nth second is, as you are moving, at some point the time will be 5. Take 1 second before, that means t is equal to 4. How much ever you move in that time interval, that is displacement in the fifth second. That is S fifth, which is given to be 11 meters. So if it is 15th second, that means from 14 to 15. If it is 20th second, meaning take 1 second before, which is 19. So 19 to 20, how much ever you moved in that previous 1 second exactly, that is the nth second displacement. Okay, clear? Perfect. Let's go to our next question coming up on your screen, and here it is. Let's see. The velocity graph is shown, and the question is, what is the distance covered between 0 to 4 seconds? One option is to use kinematics, but when pure graph questions come, keep in mind, whenever such graphical questions come, either their slope or their areas will give something. Like in the case of velocity graph, the area under it will give me the displacement. Yes, the area under it will always give me the displacement. So just go back over here. As you can see, velocity is always positive number. So in this case, my distance is also equal to the displacement, which is also the area under velocity time graph. If the graph went down up, then distance and displacement won't be equal, Because if the velocity became negative, that means I have turned back. And the moment I turned back, then my distance, which is the shortest, distance, which is the total path length, will not be the same as displacement, which is just a line joining final and initial point. So you need to be careful about it. Luckily, everything is positive. So area under the graph between 0 and 4, that is nothing but this area and this area. This area is half. It's a triangle, right? Base into height, which is 10, which is exactly 10. And this area, this is a rectangle. So base is 2, height is 10. So this is 20. So total area will be 10 plus 20, which is nothing but 30. So option number 1 is the right answer. This has come this year. Yeah, very good. Excellent. Perfecto. Amazing, guys. Let's move to the next question on your screen. Two cars are traveling towards each other at some speed. They are 300 meters apart and both of them apply brakes and at some rate. What is the distance when they come to rest? Always draw diagrams, things will become easier. This is the road and the distance between the car is 300 meters. Both of them see each other. This car already moving at 20 meters per second and stops over here. The braking is also given to me. Braking is 2 meters per second square. Same thing is done by this particular guy going like this and stops. Question is, what is the distance between them? What is that distance between them when they finally stop? Okay, assuming most likely the accident does not happen. So first let's find braking distance. So for that, for a car, assume x is the braking distance. So if I use v square is u square plus 2as. Why? Final speed I know, initial speed I know, retardation I know, displacement I want. Time has no relation over here. So final speed is 0, initial speed is 20, acceleration is negative because you are braking, and displacement is x. So therefore bring it over here. So it will become 4x. 4x is 20 square, which is 400. Therefore x is nothing but 100 meters. So this is 100, this is 100. How much is that question mark? So that question mark will be 300 minus 100 from this side and minus 100 from this side. So it will just be 100 meters. So the third option is the right answer. Is that okay, everyone? Perfect. Shall we go ahead? Very good. And I hope you are liking the session. You are enjoying the session. I hope you are loving the questions. I hope you are revising the concepts. And if you do not know any concept, never worry. We are already revising the theory. It should help. But if you want to go from the scratch, please use this playlist, or you can use this playlist, Pathfinder or Nurture. Nurture is for 11th, Pathfinder is for 12th, but these are separate classes. If that is not what you need, then you can go to one shot also. If no, sir, I don't want one shot, I want a marathon, then go for roar. Guys, I'm serving a buffet here. I want to eat cucumber, I want to eat banana, I want to eat chocolate cake, I want to eat dosa, I want to eat chicken biryani, I want to eat rasam rice, I want to eat masala dosa, whatever you want. Masala dosa, vada pav, poha, chai you want, coffee you want, chocolate you want, all right, fruits you want, salad you want, everything is there over here. Okay? Yeah, great. You can also use relative velocity. Yes, you can do that. Okay, but not needed. It was very simple. See, for simple questions, I will not solve it by very good methods. I will keep my Brahmastra for very good problems. No, why will I nuke a country for killing one person, one terrorist? If I want to bomb one terrorist, I will maybe send one agent over there and I will be like, took. I can also kill that person with the nuclear bomb, but I won't do that. Yeah. So not needed. Relative velocity is a good concept. I will reserve it for good questions. Okay. So projectile motion. Tuck, tuck, tuck. Let's solve. Yeah. What are the different formulas, concepts involved over here? So you project something like this. So you project something like this. It goes up and down like that. During this entire motion, the acceleration is always downwards. Acceleration is always downwards and it is going to be constant. This is my velocity of projection. This is my theta. This is my maximum height. This is my range. This is my time which it takes to go up and finally come down, the total time of flight. And in this entire journey, the horizontal velocity, horizontal velocity, horizontal velocity, horizontal velocity, which is u cos theta, always remains a constant. It is the vertical component. First, it is very good, then it becomes less. Then, though, here the vertical component at the top becomes zero, then it becomes slowly negative, and then even more negative. So, it's the vertical component which is never a constant, it is variable. Yeah, these are the things. You can also see the different formulas involved over here. Let's see, quickly revise. Horizontal velocity is u cos theta. So displacement will be velocity into time. Horizontal speed into time will give me how much distance I have moved horizontally. Vertically, you cannot say displacement is velocity into time because vertical motion is not uniform velocity, it is uniform acceleration. So you will use S is ut plus half at square. Vertically, displacement is y and velocity is u sine theta. Acceleration is negative g, so that's why minus sign. The total time it takes to come down, the total time it takes to come down is nothing but 2u sine theta by g. It is nothing but 2u sine theta divided by g. Maximum height is u square sine square theta by 2g. Yes, this, where did it go? My God. Maximum height is u square sine square theta divided by 2g. That's the formula. Lastly, range is u square sine 2 theta by g. U square sine 2 theta divided by g. One last equation over here is the equation of trajectory. Equation of trajectory. That means how will the y coordinate and the x coordinate be related to each other? That equation is given by y is equal to x tan theta minus gx square by 2u square cos square theta. Is that fine? That is what it is. These topics look so nostalgic. Yes, it better not be nostalgia. Soon it should. Your ex, you have to befriend your ex. You cannot say Tata bye bye to 11th standard. Okay, then that ex will create lot of issues with your current girlfriend. So that is the reason why you have to handle both the girlfriends, 11th girlfriend and 12th girlfriend. So you have to become a pro. You have to become a sigma out here. Yeah. Let's go now to some questions coming up on your screen. Here it is. If a projectile is fired at theta and speed u has some range and time t1. Now it is fired with same speed with new angle for same range and time taken is t2. Find the ratio of t1 by t2. Very interesting question. Let's see how many of you can do it. Find the ratio of the time of flights. Let's see whether you can do it. Okay. Yes, invite your friends. peak advice. Thank you. Somebody please make a short. We already have some fan channels by some of our fans, students. But these days they message me, sir, I'm busy in JEE preparation. It's okay. Don't make any videos. If you're in 11th standard, you have time, or you are in 10th standard, maybe you have time. Yeah, don't believe me, 10th standard, you guys have time. Even if your board exams are there, it's a very laddu, guys. Don't take tension. Let's see. How do I do this? See, the first time of flight will be 2u sine theta divided by g. Now, it is clearly mentioned, it is fired with the same speed with the new angle, but range is same. This can only happen if the range will be same if the second angle is complementary angle. Complementary angles have same range. Like 30, 60, 37, 53, 10, 80. These are complementary angles. So my next time will be 2 speed is same sine 90 minus theta divided by g, which is as good as saying 2u cos theta by g. Question is find the ratio of the times t1 by t2. If you divide them, 2u by g, 2u by g will cancel. I'll be just left with sine theta by cos theta, which is tan of theta. That's it. So it is just tan of theta. Very good. Yeah, very nice. Yes, perfect. Let's go to the next question. This came in JEE 2025. A particle is projected with some velocity such that the horizontal range is 3 times the maximum height attained by it. The horizontal range of the projectile is given as blah blah blah, where the value of n is how much? Come on, everyone. Yeah. 12th standard kids, dropper kids, no time to relax. Diwali is for kids. Diwali is for engineering students. If you go in IIT, if you go in NIT, you go in BITS, you go in triple IT, then you will be enjoying Diwali. Yeah, the only students who are right now probably mentally are not in Diwali mode are in 12th standard or taking a drop, because JEE is just 2 months away. I mean, I'm pretty sure your entire mind will be somewhere else. Even if you're bursting crackers, you will be like, projectile equation, what is the trajectory? Oh, this chemical is bursting, what is the composition? Like that it is. That is how your brain should be right now. Okay, and it is justified because next year you are going to enjoy. So let's see. A particle is projected, horizontal range is 3 times the maximum height. What's the height formula? It's u square sine square theta by 2g. What is the range formula? U square sine 2 theta divided by g. U square gone. G also gone. So sine 2 theta is 3 by 2 sine square theta. Sine 2 theta is 2 sine theta cos theta. So this is 3 by 2 sine square theta. Sine theta cancels. So 2 cos theta is 3 by 2 sine theta. Okay, what do I need? What is the horizontal range of the projectile, they've asked. Okay, so from this sine theta by cos theta, what do I get? Sine theta by cos theta, 2 into 2 divided by 3. Is that right? So sine by cos is nothing but tan theta. So tan theta is 4 by 3. Therefore, theta is 53 degree. This is a standard angle. But that is not the question. The question is what is the range of the projectile? So the range of the projectile, use this formula. It is u square sine 2 theta. That means 2 sine 53 cos 53 whole thing divided by g. Whole thing divided by g. So 2 is there, u square is there, g is there. Sine 53, sine of 53 is 4 by 5. Cos of 53 is 3 by 5. So 2 4s are 8, 8 3s are 24, 5 5s are 25. U square is also there, g is also there. So 24 by 25 u square by g. So the value of n is nothing but 24. That's how you solve it. Yeah, the fourth option, very good, Shrika. Very nice, amazing. Yeah, very good. Great, great. Nilavalan, where were you sleeping, bro? 3 lakh subscribers got last month only, September. I think that song is there, no? Wake me up when September ends. Ta-na-na. That song is for you only. You have woken after September ends in, I think, probably glad that you woke up before October now. All right, next on to rotation, guys. Torques and rigid bodies. Torque is the equivalent of force or the moment of force. It is the cause of rotation. It causes the body to change its state, either accelerate or retard angular wise, isn't it? Oh, thank you so much, Ibu. Yeah, and thank you guys so much for the 3 lakh subscribers. 3001. Slowly, I think in the next 2-3 days, we should be 302. Yeah. Torque is position into force. R is not radius. Kids use radius. You guys are not noobs. You guys are not amateurs. You are pros. You are sigmas. You are 12th and dropper students. Don't call this radius. This is position vector. This is where the force is being applied. Wherever that force is being applied, that is the position vector of it, not the radius. R cross F, use your normal right hand rule and cross product rule. If you want the magnitude, take the magnitude of the position, magnitude of the force, and multiply it with the sine of the angle between the position and the force. That is how you can do it. Newton meter is the unit. Don't use joules. Joules is for work only. Next thing, if at all there are multiple forces, there will be multiple torques. One thing will try to rotate like this, another thing will try to rotate like this, another thing will try to rotate it like this. All these torques might add up and give a net torque. So it's quite possible that you can get my net torque to be torque 1 plus torque 2 plus torque 3 like that till torque n. If by chance the net torque is not 0, then it causes alpha. What is alpha? Angular acceleration. So torque will be I into alpha, which is also the rate of change of angular momentum. This is like the Newton's law, but in rotation. This is like but the Newton's law, but in rotation. Yes, cross means sine, dot means cos. Okay, so very easy way to remember, no? COS. What is this? Dot. Got it? What is this? Dot. Very easy way to remember. COO, you shade it. O looks like a dot. Cos theta is for dot. Cross is for sine. Cross product is for sine. SIN. So you commit a sin. You go to the cross like this. You rotate the cross. Yes, you go to the confession box. Okay, in the church, and you confess for your sins. So that is how it is. That's how you can remember. Awesome. Great. Sai Pranav, now only starting JEE preparation. Very good. What should I say now? You only tell me. What do you want me to do? What should I do? Do you want me to give you a suggestion? Do you want me to motivate you? Do you want me to give you a plan? Please tell me. Because when I was making all these videos, what were you guys doing? September plan, October, sorry, where is it? August plan. So many plans I gave. I think I should stop making videos only now. It is there. I think it is in the live section also. Guys, for Ultra Pro Max students, I think I'll have to make a separate video on it. Okay. Rigid body is in equilibrium, meaning the torques are cancelling out. There is no net torque. Then it is in equilibrium. So all the torques will cancel. If the body is balanced, it is not toppling yet. It is on the verge of toppling. It is stationary. It is happy. It is just staying there quietly. Then forces will also cancel. Torques will also cancel. That is equilibrium. Is that right? Okay. Plan. Don't worry, Sai Pranav. I'll give you a plan now. Like what to do. See, We have all kinds of students. We cannot say now, why did you not do this? Why did you do that? Like I just asked. But fine, it's okay. Let's accept it and let's see. I'll give you guys a plan, Ultra Pro Max plan only. Okay, right. Awesome. Oh, GOAT FC, why not? I'll be making a marathon. Guys, do you want a CBSE marathon also for NCRT, for boards, for your prelims? Do let me know because your prelims, pre-boards will also come very soon. Do you want me to take a marathon in November first week? Not now. Yeah, so do let me know. Let's do some questions based on that. Here it comes. A square lamina is there and the forces acting on it are given. The lamina stays at rest. The magnitude of the force is how much? The magnitude of the force is how much? All right, needed. Oh my God. Great. Fine. Managing school is a problem. I know. Very, very hard. So I'll be giving you two things, guys. See, first of all, this Tuesday, you're going to have the chemistry marathon. Wednesday, you're going to have the maths marathon by Namrata ma'am. So two marathons are lined up just like this. I think one of maths is 29 subtopics, high weightage, and chemistry, I think it's 35 or 36 subtopics. So those two marathons are lined up. Then after that, I'll make a new plan for all the Ultra Pro Max legendary students also. And also we'll conduct CBSE marathons. If you guys like this video and put it in the comments, I want to see those comments. How many students are studying literally for CBSE? Although I conducted a poll and it said around 55 to 60% of the students studying over here are for CBSE. I want to know specifically how many of you need which kind of marathon in the comments after this video ends. Okay. JEE 2027, already the lectures are on. So we will have backlog for you guys also. I know you guys are papa waiting, but your seniors are tensed, bro. Very, very full tension is there. I think they will lose hair. So I have to help them also. I'll come to rescue you guys also. 2027 backlog students, don't worry. All right, let's have a look. So question is to figure out the force. Let me take this particular point and try to balance the torque. So the net torque at point O should be 0 because it is at rest. It is at rest. It is clearly mentioned. So that is why this is 0. So which all forces will give torque? Let's see. And which forces will not give torque? If there is a force which passes through the axis, if there is a force which when extended passes through the axis where you are taking the torque, then they will not give any torque. They will not give any torque. Like you can see, this force when extended passes through O. Then this force when extended passes through O will not give torque. So let's see now which are the forces which actually give torque. Like this force is definitely going to give anti-clockwise torque. R is nothing but 10 multiplied by F, but that is anti-clockwise. So maybe I'll take it negative. This is not going to give. What about this 10, guys? This 10 will make it rotate again anti-clockwise. And this 10 is again at a distance of 10 centimeters. So therefore, minus 10 multiplied by 10 again anti-clockwise. So this is done. This is also done. How about this? This is again at a distance of 10 centimeters perpendicular, but it will give a clockwise torque. So positive then. So it should be positive. So plus 10 multiplied by 10 positive. Then let's take this guy over here. This is at a distance of 10 and it is going to give again a clockwise torque, I believe. So I'll just include this also. Plus 10 multiplied by 10 is equal to 0 because I think I have considered all the forces over here 1, 2, 3, 4, 5, 6, but out of the 2 did not give torque. So 1, 2, 3, 4, 1, 2, 3, 4, done. So this and this cancelled. So take that 10F on the other side. So 10 into 10 is equal to 10F. So therefore F is equal to 10. So 10 Newton is the answer. Okay. So this is the kind of question that you can get. All right. Awesome. Awesome. Perfect. Is PYQ solving enough? I'll tell you the answer in one of the strategy videos which I'm going to make very soon. But I'll tell you, It is mostly enough, but you will have to go beyond PYQs if you are already well prepared. And if you are under prepared, then you will have to go to application questions. So there are two kinds of students. Maybe you're not fully confident in a particular chapter, and you'll have to do some basic questions. Just don't jump to PYQs. But if you are fully confident, then do more PYQs, older PYQs. And if you want to push yourself more, then go to, beyond PYQs, like between mains and advanced level. That's what you need to do. Which books, which resources to be used? I'll make a video, guys. Like I said, I have to. All right. So having said that, let's go to the next question on your screen. A uniform rod of certain mass having length of 100 centimeters is balanced at 40, not at 50, middle part. The mass of 400 gram is at 10 centimeter. To maintain the balance, how much mass should be put at 90 centimeters? I think we need a diagram for it, which looks something like this. So this is balanced at 40 centimeters. You keep 400 grams at 10 mark, 250. Why is 250 here? That 250 grams is the mass of the rod. So that mass of the rod will be exactly at the middle. And the last one is basically at 90 centimeters. How much mass will you keep so that the rod stays balanced? So as you can see, this is nothing but the pivot point. Now from the pivot point, how far is this 400 grams? Let's figure this out. This is 40, this is 10, so this will be 30 centimeters. This is 50, this is 40. So naturally, this will be 10 centimeters. This is 90, this is 40. So from the pivot point, 90 minus 40 is 50. So this will be 50 centimeters. There are multiple forces. This force is there, which is the actual mass of 400 grams. The entire rod's mass will be at the center of mass. So that weight will be there. And extra weight, which we have to add, which is nothing but mg. That is what we have to find. So just say that the net torque will be 0 about the pivot point. This force is 30 centimeters, so R cross F. So R is 30, F is 400 G, but it is anti-clockwise, so negative. Why anti-clockwise? Because it will try to rotate it like this force alone about this pivot. This will rotate it clockwise, so it should be positive. R is 10, force is 250 G clockwise. Lastly, this force will also rotate it clockwise, so positive. R is 50, weight is mg, that is equal to 0. G cancels, 0, 0, 0 also cancels. So we will be left with minus 400 plus 250 plus 5m is equal to 0. What and all I have cancelled? G, G and G. This 0, and this 0. That's all I have cancelled. Okay. So therefore, 5m will be 400 minus 250, which is nothing but 150. Therefore, m is 150 by 5. Therefore, m will be nothing but 30 grams. So 30 grams will be the answer. So basically 30 grams will be the answer over here. 30 will be over here as it is. Is that clear, guys? Everybody, just let me know. Everybody? Yes. Awesome. Awesome. Very good. Very good. Very good. Excellent. Where does 3 go? Oh, we missed the 3, is it? My bad. I'm so sorry, guys. See, sometimes I also make some weird, silly mistakes. My bad. I forgot this 3. So this will be minus 1200. Just check this out. Does that make sense? 3 4s are 12. So 1200 plus 250 plus 5m is equal to 0. Is that fine now? Okay. Now take this on the other side. So 5m is 1200 minus 250. 1200 minus 250 is 950. So that is 5m. Therefore, m will be 950 divided by 5. Therefore, m will be how much? 95 by 5 is 19. So 19, so 190. So 190 grams should be the answer. 190, is it there? Yes, this is right over here. 190 grams. There you go. Yeah. Awesome. 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 Very good. Very good. Excellent. Let's go to the next concept, rolling motion, rolling concepts. Okay. Whenever you have a spherical body or a wheel which is rolling, then the velocity of the center and its angular velocity are related by v is r omega if it is rolling. But if it is slipping or skidding, then the velocity won't be r omega. Not just that, this might even have some acceleration and some angular acceleration. This, for pure rolling, a will be equal to alpha into r. So A is alpha, V is r omega is only for rolling concepts. If it is slipping, skidding, then A is not r alpha, nor is V r omega. Okay, keep this in mind. This will also have two kinds of energy. One is the energy of translation. Like you can see, this is the energy of translation, half mv square, velocity of the center of mass square. And it will also have rotational energy, which is half I omega square. Both these energies will be present in that particular body, translation and rotation. Lastly, whenever you draw the free body diagram, multiple forces could be there, like normal could be there, weight could be there, somebody else is pushing, somebody else is pulling, and friction should also be shown. But this friction is static in nature. So for rolling, F is static for rolling motion. For rolling motion, and nobody knows the value of F. You can just assume that F, it is not mu n. Mu n is maximum friction. Okay, it is not the actual friction, it's the limit of that friction. So static friction for rolling will be there in most of the cases, and you can just assume it, assume this particular F and solve it, and solve this particular free body diagram using net force is mass into acceleration, and net torque is I into alpha. So using this, you will definitely be able to get the answers for this. Okay. Lastly, whenever you have this particular spherical body which is coming down an inclined plane, meaning something like this, and this thing will now accelerate. This is theta. There will be obviously some friction and all of that. Normal will be there, mg will be there, components, everything, all of that. Mg will be there, normal will be there, and all of that. And it will also have angular acceleration. This acceleration usually with g sine theta, if it was not rolling, just sliding, but because it is rolling, it will have 1 plus I by mr square in the denominator. Okay, so this extra term will come if it is a rolling body down a rough inclined plane. Okay, very, very important. Rama, I will take it surely very soon. Will you take RBD for 12th graders one again? If you want me to, then I will take definitely. Okay, so first let's do this particular question coming up on your screen. Let's see. A solid cylinder of certain mass and radius rolls along an inclined rough plane of inclination of 45 degrees. If it starts to roll from rest from the top of the plane, what will the acceleration be? This exact same question, this one, they have just asked you how much will that acceleration be given this particular angle is 45 degree. What is our formula? G sine theta, theta means 45 degree, upon 1 plus moment of inertia by mr square. What is it? It is a solid cylinder. For a solid cylinder, it is just like a disc, which is nothing but mr square by 2. So just put mr square by 2. So sine 45 is 1 by root 2. Keep it as it is. Mr square cancels. So just 1 plus 1 by 2. So this will become g by root 2. And this 1 plus 1 by 2 is nothing but 3 by 2. 2 goes on the top. So this will become g multiplied by 2 by root 2 multiplied by 3. Root 2 cancels. So g root 2 whole thing divided by 3. G root 2 whole thing divided by 3 is right over here, the third option. Yeah, very good. Hi, hi Nikisha, welcome aboard. Pizza, the session is long enough to order another pizza now. Okay, so you better order a pizza and keep, because you are going to need that energy and that strength. Okay, cool. Shall we go ahead, my dear warriors? Yes, pakka. Done. Let's go, let's go to the next concept, which is angular momentum. Oh, before that, one more question I wanted you guys to see. Imagine there is a solid sphere of this sorts, and there is a force which is acting exactly at the center of, let's say, 5 or let's say 3 mg, and this is sufficiently rough, and this is, let's say, a solid sphere. Can you find its acceleration and angular acceleration? That is the question. If it is rolling, that is the question. Let's see how do we do it. It is clearly mentioned it is rolling and it's a solid sphere. So first start with the forces. Weight will be there, normal will be there, some friction will be there, whose direction value I do not know. Just assume it as F. This is mg, this is normal. It will have some acceleration, also some angular acceleration. Like I said, use Newton's law. F is ma, torque is IL. So let's use net force is mass into acceleration. 3 mg is against F and producing acceleration. So 3 mg is forward, F is backward. Together it gives me mass into acceleration. Similarly, net torque is I into alpha. About this point, normal force and mg is not giving any torque, only friction is giving a clockwise torque to help with alpha. So radius into F is I into alpha, and remember alpha is itself A by R. Because it is rolling, this A is alpha into R, or alpha is A by R. That is what I will write down over here. What is the moment of inertia of a solid sphere? It is 2 by 5 mr square. This is A by R, and this is R into F. This is R into F. R gets cancelled. So I am getting the value of F as 2 by 5 times of ma. 2 by 5 times of ma. Substitute this F over here. So I will get 3 mg minus 2 by 5 times of ma is equal to ma. Therefore, shift it over that side. So 3 mg is equal to ma plus 2 by 5 ma. So this will become 7 by 5 ma is equal to 3 mg. mm cancels. So A will be 5 3s are 15 by 7 times of g. So we got the value of acceleration. Now we can easily find alpha also. Alpha is A by R. So acceleration is 15 g by 7. So that R will come over here. So we figured out alpha, we figured out acceleration. Is that clear? Everybody with me? Okay, so these are the kind of questions which you might get on the concept of rolling motion alone, and this has come, although they say that rolling is not there in NCERT, but still in NTA people are giving rolling questions every time. That is why it is high weightage and must do question. Angular momentum also very commonly asked. Every single shift almost they are asking angular momentum. So highly predicted question. Angular momentum is like momentum but for rotation. In linear momentum, it is going in a straight line. In angular momentum, a rotating body possesses angle-wise momentum. And just like momentum was mass into velocity, angular momentum is I, which is moment of inertia into angular velocity. Mass in rotation, velocity in rotation, I into omega. So this is what you will use for rigid body. This formula, you will use it for a big body like a sphere, cube, triangle, rod, right? Cone, all these things when they are rotating, I into omega. But if it is a point mass which is rotating, then you will use R cross mv. You will use R cross mv for a particle. R is the position. I see that particle there. It is at that position vector R. Mass of that particle into velocity. So R cross product, use right hand rule. R cross momentum or R cross mv for a particle. Keep that in mind. Now, having said this, we also know that torque is dl by dt. Torque is dl by dt. So if torque is 0, this is net torque, it is 0, then dl by dt is 0. That means L is a constant because the derivative of a constant is 0. So in such scenarios where the net torque of the system is 0, then angular momentum is a constant. That means it is conserved. Final momentum and initial angular momentum will be the same. So you can equate the momentums as it is. Okay, great. So let's do this and then we'll have a short break after these two questions. Okay, after these two questions, let's solve. Okay, come on, guys. If L and P represent the angular momentum and linear momentum respectively of a particle of mass m having position vector, then the direction of the force is how much? Okay, let's see. How do we solve it? R is given. Question is, what is the L and P relationship? Okay, the direction of the force is in which direction? Is it in the direction of R? Is it in the direction of L? Opposite? Or L cross P, so many things. So from position vector, I think we will first figure out velocity vector. Velocity is the rate of change of position. So dr by dt. So if I differentiate this, A cos omega t is derivative will be omega into with a negative sign sine omega t. This will be I cap. Cos's derivative is negative sign and that omega comes outside plus A sine's derivative is cos and that omega will also come outside, cos omega t j cap, that is velocity. Let's figure out acceleration also. Acceleration will be derivative of velocity. So if you differentiate this, A is there, omega is there, one more omega will come, so it will become omega square. Sine's derivative is cos, so cos omega t into omega, so that's why it became omega square I cap plus A omega is there. Cos derivative is minus sign, so minus became, and that omega will come, and this will become sine omega t j cap. So acceleration also we have got. Okay, now what else is needed? The direction of the force. Okay, once we get acceleration, we can also find out the force on it. So force is m into a. So this will be minus m a omega square cos omega t I cap and minus m a omega square sine omega t j cap. So we found the force. So what about angular momentum and linear momentum? Okay, let's write that also. Linear momentum will be mass into just velocity. So just take velocity and just multiply it with mass. So minus m a omega sine omega t I cap plus m a omega cos omega t j cap. That is just the normal momentum. That is just the normal momentum. And finally, the angular momentum. Oh my God, crazy guys. Angular momentum M into R cross product with V. I think we don't even have to find angular momentum, or do we need it? Let's see. So M is there. You now do the cross product of R along with the velocity. R is right over here, whatever this is. Okay. A cos I cap and A sine j cap, and velocity, whatever that velocity came out to be, minus A omega sine I cap and A omega cos j cap and all of that. You have to do the cross product of all of them. After this, you will be able to figure out whether it is parallel, anti-parallel, opposite or not. So this type of question will take away a lot of your time in the examination. Yes, this type of question will definitely take away lot of your time in the examination. But by the look of it, the direction of the force, is it in the direction of R? Let's see. I think if you notice, you didn't have to do all these nonsense. Force, if you notice, ma omega square, forget that. Negative cos, negative sign. Positive cos, positive sign. Observe carefully, guys. Position vector has a cos something I cap and sin something j cap. Whereas the force quantity, if you notice carefully, it has minus ma omega square common, and it has again cos something I cap and sin something j cap. This gives me direction. This and this is the same, just that there is a negative sign. So technically, force is opposite to R. So it is opposite to the direction of R. That's it. I don't have to find anything else, but that was just by fluke, if you notice, because we don't know what exactly might come. So we had to find out literally everything till we get to the right answer. Yeah. Yes. Yeah, you can do integration also to find angular momentum, but I think cross product will be easy because I cross I will be 0, j cross j will be 0. Anyways, you will only get two terms. So don't go into integration, unnecessarily not needed. Okay, let's do this particular question, which had also come in JEE 2025. There is a ring rotating with some speed. You now add two masses gently on the opposite sides. What is the new angular velocity? So this is that ring which is right now rotating at 2 radian per second. What you do after this is you take the same ring, but you add two masses. The original mass of the ring was m. The two masses that you have added is small m and m. So the question is, what is the new velocity? In such questions, angular momentum is conserved. Yes, angular momentum is conserved. So initial angular momentum is I1 omega 1, final is I2 omega 2. What is inertia before? Moment of inertia of a ring is mr square. Angular velocity is 2. What is the final inertia? It is not just of the ring, but also two masses at the distance r. So it will be mr square. It will be mr square plus mr square, two masses, the whole thing into the new angular velocity. Okay, so let's see what do we get. R square cancels everywhere. So 2m is equal to m plus 2m into omega 2. So omega 2 will be 2 times of mass divided by m plus 2m. So 2m divided by m plus 2m, that is C option. That is absolutely correct. This was asked this year based on conservation. Okay, very good. So we will do this along with, I think we have fluids, motion of satellite, modulus, all of this, surface tension, thermodynamics, few more topics, so that we can complete the 11th standard after this. Okay, So we'll start with this after a small break. Just we'll take a 5-10 minutes break and come back. Okay. Ready, guys? We'll take a 5 to 10 minutes break and we'll return. Okay. Oops. Oh my God. Oh my God. So sorry, guys. Welcome back. Welcome back. Yeah, the break time is over and it's time to move on to gravitation. We are doing 31 sure shot subtopics. You can do the math. 31 subtopics, 25 questions. The frequency, the chances of these topics to come in those 25 questions is extremely, extremely high. Yeah, it's extremely, extremely high. So be there because there is a good chance that you're going to get 99 percentile just from these topics alone. Okay. So use this session also as a shield to protect yourself from cleaning the house. Yeah, already many kids would have got the instruction. Tomorrow is Diwali, day after tomorrow also festival is there, preparation is there, clean the house, do this, dust this, pour water here, clean that, yeah, mop this. How many of you are escaping from that hard work by sitting over here nicely and watching the session? Let me know quickly in the chat box. Using this session as a shield. Yes, oh my God. Many people. Wisdom is already here. Yes, Ibu. So you are getting scolding from parents. Oh my God. So many people will be scolding me today. So many parents. Yeah, nicely. Just before Diwali, all the kids escaping the hard work. Very good. Very good. So kids are like, sir, it's okay, sir. Don't do anything. Just stand over here and continue with the marathon. I'm just going to say, I'm studying. I'm studying. Shreyas sir is there. Okay. So let's begin. Gravitation and its variation with height, depth, etc. So if you are on the surface of the planet, the acceleration due to gravity, let's say it is G, it is capital G, gravitational universal constant 6.67 10 to the power minus 11, mass of the planet Earth divided by the radius square. Okay, that is on the surface of that particular planet. But the moment you go at some height, this is height, this is height, then the gravitation at that height becomes gm divided by r plus h whole square. R plus h means this plus this total distance. But if the height is very, very small, approximately it is g1 minus 2h by r. This is only valid if height is much, much smaller after you do some approximation. This is exact, this is approximate for small heights like 50 kilometers, 100 kilometers and all of that. And similarly, if you are inside and you go at some depth of d, then the gravity at that depth is given by g 1 minus d divided by r. Looks very similar to this formula, but remember this is exact formula. Number 2, this is having the number 2 here, this is not having that number 2. Okay, so that's a small difference which you should keep in mind. If you draw the graph of this variation, if you draw the graph of this particular variation, it looks something like this. Inside it is a straight line. You reach the maximum value of G at the surface, and then after that the gravity again begins to fall like this. So this is how the graph looks like of acceleration due to gravity from the center of the earth to surface to outside. Okay, this acceleration is assuming the earth is uniform sphere, which I know it is not in reality. Number 2, the rotational effects are neglected. If you consider the centrifugal force, the gravity will be less. Number 3, the bulging out of the earth near the equator also has been neglected. So there are some variations. So from place to place, G value will definitely change due to rotational effects, density effects, and the shape effects. But we do not consider that for J. Keep that in mind. Okay. All right. Let's go. All right, Nishika, Sidhu. Ayoyo, who are these man? Sidhu, what is this? Asking Insta ID on a educational platform in a chat. What 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 optimism is there in you? I mean, really, it's really amazing that the kind of optimism you guys have. If you have so much of optimism, you should go out in the park, somewhere, or go to a mall or something and go ask in the reality Same thing. Some random person is walking, give me your Insta ID. That guts you don't have. Here, hiding your face on the chats, you are asking Insta ID. What? Be a man, man. Yeah, go out and yeah, then do it. All right, let's do the questions coming up on your screen, and here it comes. Okay. Find the ratio of acceleration due to gravity at a height and depth of r by 100. At height and depth of r by 100. Let's see. Come on. Okay. If I start studying now, can I get a seat? PVA, I'll make a separate video, bro. Don't disturb the class now. Okay, focus. See, at a height, because this height is much, much smaller than r. Yeah. So I can say gravity at that height is g 1 minus 2h by r. So g is there, 1 is there, 2 is there, r is there, height is r by 100. So which makes it g 1 minus r cancels, 2 by 100 is 1 by 50, of course. So g into 50 minus 1 is 49 divided by 50. Now gravity at depth d is g 1 minus depth by the radius. So g is there, 1 is there, d is r by 100, and that r is also there. R cancels, 1 minus 1 by 100 is 99 by 100. Now the question is, find the ratio of gravity at height h upon gravity at depth d. So it is G49 by 50, and GD is sorry, why did I put R over here? My bad. This was G, right? Yeah. So this was G99 divided by 100. G cancels. 150 goes 2 times. So 49 multiplied by 2 divided by 99. 49 into 2 is 98. So 98 by 99. 98 by 99 is the answer. What a brilliant, fun looking question. Numbers are also very interesting. 98 by 99. Yeah, very good, Maheshwari. Amazing. Proud of all of you. Moving on to the next question coming up on your screen. If the weight of an object midway from center and surface is 800 Newton, find the weight at altitude which equals the thrice the radius of the earth. Thrice the radius of earth. That is the question. By the way, don't worry guys, you are going to get all the slides in the PDF form. So some of you are asking, sir, I'm not getting enough time to write. All the slides you are going to get, okay, as a PDF. Don't worry about it. Let's see. How do we do it? First of all, if the weight of the object midway between center and the surface is 800 Newton, remember that graph which I just told you? When you are inside the surface, the graph is a straight line till you reach the surface at that radius r. So if you are exactly at the middle, that means at r by 2, the acceleration due to gravity will also be g by 2. So if at midway the weight is 800 Newton, therefore on the surface that weight should be double, because this is half, this is 1, this is 1, this is 2, this is 4, this is 8, this is 7, this is 14. So this should be nothing but this should be nothing but 800 multiplied by 2, which is nothing but 1600 Newton. That is essentially the true weight of it. That is nothing but the true weight of it on the surface. Now what I will do, I will think of gravity at height h. The gravity at height h is given by gm by r plus h whole square. Now, what is h? It is given 3 times the radius, so put 3r and I will put square over here. What is gm? I know g is gm by r square. So gm will be gr square. Gm will be gr square. Everybody gets that? Okay. So what do I get next? G is there, r square is there. 1 plus 3 is 4, 4 square is 16, so 16r square. So it will become g by 16. So if on the surface the weight is 1600 Newton, so the weight at the altitude will be how much? Because gravity reduced 16 times. It will be the weight divided by 16. So the original weight was 1600 Newton divided by 16. That makes it 100 Newton. So the weight at that height of 3 times the radius of the earth will be 100 Newton. Yes, everyone? Okay. All right. Okay. And to prepare. All right, Harsha. Definitely you can prepare. How gr square? This equation over here. Check this out. G is gm by r square. Therefore, gm is gr square. I just got it from here. So instead of gm, I can put gr square. So instead of gm, I can just put gr square. Does that make sense? So this transformation is very useful in many questions. That's why I did this question, because many times you will need this substitution in the actual examination. Okay, absolutely clear, everybody? Very good, very good, amazing. So let's move to the next concept, which is of circular orbits of satellites. So if you have a planet of certain mass and you want to launch a satellite artificially, or there is a natural satellite, both ways it works. And this is our satellite of a mass m. It will get pulled by gravitational force and it will have some velocity as it orbits, which is the orbital velocity. Okay, and this gravitational force is the force which gives the necessary centripetal acceleration for this uniform circular motion. So all the planets revolve around the sun like this, moon revolves around the earth like this, artificial satellites revolve around the earth like this, the moons of Jupiter or the rings of Saturn also revolve by the same laws. Okay, so this is the basic working principle of a satellite. The centripetal force is the gravitational force and the velocity keeps changing the direction but maintains the speed. So it never really actually falls. So it also has kinetic energy, it also has gravitational energy. The satellite also has a total energy associated with it. It also has some time period of revolution. It also has some speed of orbit. All these things, standard formulas are there. Let's see one by one. Okay, centripetal force is gmm by r square, which is gravitational force. From that you get velocity as root gm by r. R is the radius of the orbit. So it starts right from the center, includes the radius of the planet also. This plus this is basically r. Next thing, once v is root gm bar, next is time period. So actually better to remember time period like this. T square is 4 pi square by gm into r cube. So T square is proportional to r cube. T square is proportional to r cube, which is also Kepler's third law of time periods. Square of the time period is a constant into r cube. That is one thing. Kinetic energy is half mv square. Potential energy is minus gmm by r, standard formula. G m1 m2 divided by the separation, but with a negative sign. Kinetic energy is half mv square. You can use this velocity and get the answer. total energy you get minus gmm by 2r. Now keep in mind that the total energy which you get, which is this one over here, the sum of kinetic and potential energy, is also related to the kinetic energy like this. The negative of u is kinetic energy, and sorry, the total energy negative is the kinetic energy, because you can see total energy is minus gmm by 2r, total kinetic energy is gmm by 2r with a positive sign, so they are just different by signs, magnitude wise they are same. And the potential energy, if you notice, it is nothing but 2 times of the total energy. This situation also comes in atomic structure of modern physics for electrons orbiting the nucleus. Yeah, the kinetic energy of the electron is negative of the total energy, and the potential energy is 2 times the total energy. This formula is even valid over here. Okay, so these are some basic things which you should definitely know about motion of satellites. If at all time period is 24 hours, then it is rotating as the earth rotates. It is called as a geosynchronous, because it is synced with the rotation of the earth, or geostationary satellite. If the altitude of the satellite is very less, that means the radius is very similar to the radius of the earth, then it is very close to the surface of the earth, so it is called as a surface satellite. And if the satellite goes from north pole to south pole and the earth revolves below it, it is called as a polar satellite. These are the 3 terms which generally come. So let's look at some of the questions coming up on your screen. First one: find the energy lost when the altitude of a satellite drops from 5R to 3R. That is the question. Find how much energy is lost when satellite goes from a higher orbit to lower orbit. This is like electrons getting de-excited in a way. So it's very, very similar, guys. You have a big orbit. From that big orbit, the electron has jumped to a smaller orbit. So clearly, the radius of the earth, let's assume it as r, and the very first time this altitude, next time this particular altitude, this particular altitude is also given. It drops to 3r from an altitude of 5r, as you can see. Originally, this satellite was here. This was initial. This was final. So the question is, how much energy does it lose? So let's solve it. The loss of energy is nothing but, initially it had more, finally it had less. So a bigger minus smaller value. The total energy of a satellite is minus gmm divided by 2 into the distance from the center. So initially, if you notice, the distance from the center is not 5r, rather it is 6r. Bear that in mind. So lot of people put 5r, that is wrong. It is actually 6r. Minus, again over here, minus gmm divided by 2 into, check this out. Finally, altitude is 3r, but the distance from the center is not 3r. It is actually 4r. That's a common mistake. So this is going to become plus. So gmm, 2 4s are 8. So 8r minus gmm divided by 2 6 are 12. So 12 times of r. So 1 by 8 minus 1 by 12. So gmm divided by r is common. 12 and 8. LCM is 48. 8 goes with 48 6 times. 12 goes 4 times. So gmm divided by r. 6 minus 4 is 2. So 2 by 48. So 2 by 48 is 24. 1 by 24. So gmm divided by 24 times of R is the energy which has been lost. That is the answer. GMM by 24R. Very good, Savri. Amazing. Ganola, I don't know whether you are seeing the time over here. If you are watching the class from before, obviously you know it's a live session. Okay, great, amazing, perfecto, perfecto, awesome. Sir, how the formula of energy came? The formula of energy comes by derivation, bro. It's basically adding kinetic and potential energies. Kinetic energy is half mv square. Velocity we found out. You put the velocity over here, you get kinetic energy term. Potential energy is just like electric energy, k q1 q2 by r. Same way, gravitational energy is negative g m1 m2 by r. You add both of them, you will get the answer. You add both of them, you will get minus gmm by 2r. R is the distance from the center, mind that. That's the only catch. And many kids make that mistake in a hurry. Now it looks simple. I'm telling you, in the exam, no, that is the mistake. Everybody forgets the radius of that planet. So be careful. Let's do the next question. This was asked in JEE 2025, I believe. Satellite is launched into a orbit of radius r. Another satellite is launched, but a small change in the radius, small change, 1.03. The time period of the revolution is changed by how much? How is distance and time period related? Radius is given, radius is different, okay? We all know the square of the time period by Kepler's law is proportional to the cube. So T square, if I, or rather T is proportional to R raised to 3 by 2. Therefore, T is some constant into R raised to 3 by 2. Here I have taken square root on both sides. So now we can take relative error concept, errors and measurement. Delta T by T, constant doesn't matter. Delta R by R, relative error in radius. That power mod will always come. And if I put percentage here, this will be also percentage, but I don't think it is needed as of now. Let's see. So this will be 3 by 2. There is a small change in the radius. How much is the change? 1.03 r minus r upon the original radius is r. So therefore it will become 0.03 r divided by r, which is 0.03, which is just 0.03. That is the error in time. But the percentage error in time will be 0.03 multiplied by 100, which is nothing but 3%. So the time period will be different by 3%, of course. That is the answer. Okay. No, it is not 4.5%. Yeah, be careful, guys. Yeah, it is. Did I miss number 2 somewhere? Oh, yes. Sorry, guys. It is not 3%. See, silly mistake. This is silly mistake. I just saw your answers and then it clicked that I have missed 1, 2 somewhere. Okay. Sorry, guys. So this is 0.03 and this 3 also I missed. Very good. So this was 3 and this was 2. Yeah. This was 0.03 and this was 3 by 2. That 3 by 2 I have missed. So this will become 3 by 2 multiplied by 0.03, which is 0.09 by 2, which is 0.045. So percentage in time will be 0.045 multiplied by 100. So that will give me 4.5 percentage. Yeah, shift the decimal places by 2 times. That will be 4.5%, which is absolutely option number 2. Yes, perfect. Yes, yes, I forgot that 3 by 2. Now it is fine. Okay. So these kind of questions again can be coupled with units, errors, and measurement also. Sometimes they can ask some dimensional formula, etc. All those things kind of questions can come. Okay. So satellite questions, very, very familiar and popular. Now, next one, Young's modulus. Stress strain modulus. Stress is always force intensity. How much is the force concentrated per unit area? So it is newtons per meter square. Stress is force by area. Strain is a dimensionless quantity. which tells me the relative changes which happen in that body. So it is the change in length upon that original length. Change in length upon that original length. The division of stress and strain is what is called as the modulus, which is the constant for a material, say aluminum, iron, all right, wood, stone. They will have peculiar values of modulus of elasticity. This is a constant. If y is big, means it's very difficult to change the shape or the size. If y is small, you can easily elongate or compress it. In fact, if you look at it graphically, it becomes very easy to understand this. If this is your stress, which is force per unit area, symbol of stress is sigma. For strain, it is epsilon, which is change in length. Let's say it is x divided by original length, or small l by capital L, whatever you want to use. Then that graph looks almost a straight line initially, and the slope of it is what is Young's modulus. If it is higher, steeper slope, it is very difficult to elongate it. If it is very mild slope, it is very easy to elongate it. And this is basically Hooke's law. This is basically your Hooke's law, where the stress is proportional to strain, and that constant Young's modulus gives me the proportionality right over here. Okay, very, very important. Now, having said that, if you further elongate it, you will see that the graph becomes non-linear after some time. And after that, you will see the graph goes into something called as the plastic zone. Till this point, it is elastic in nature. It is elastic in nature, meaning if you remove the stress, it will come back to its original shape and size. So if you pull it, leave it, it comes back. Pull it, leave it, it comes back. Compress it, comes back. Pull it, comes back. That is elastic. But plastic means if you pull and leave it, it will not come back that much. If you pull it this much, it will just come this much. Or if you pull it this much, it will just barely move. So it is called plastic behavior. It is one way only. If you pull it by giving more stress and you relieve it, it will permanently get deformed. Yeah, there will be a permanent strain. Strain is there means elongation or compression is there. So it has been permanently deformed. And if you keep on elongating it like that, after a point, it will just break. It will fracture. It will fracture. This is your stress versus strain graph. Also note that if somebody measures this particular area under the graph, okay, if somebody measures the area under this particular graph, area under stress versus strain graph, that gives me energy density, energy per unit volume, which is stored, which is half stress into strain. You can see this is nothing but a triangle at the end of the day. Area of a triangle is half base, which is strain, into height, which is stress. So half base into height is energy per unit volume. That means joules of energy stored per meter cube of that solid. That is the density of that energy, which has been stored in that elongated or compressed body. Okay, very, very important. Sir, 1:30, will you complete? I don't think, Jaya, I will be able to complete in one session, or not one session, sorry, 1:30 for sure, because there are many slides, guys. I think it is going to go till 200 or 190 slides are there. So I'm doubting if I'll be able to complete. Do you want me to take separate parts, or do you want me to do it today only? Let me know quickly in the chat box. 1 second. All right, one lecture. Okay, let's do it then. Yes, very good. I wanted to hear that only. Awesome, guys. So let's finish it no matter how much ever time it is. Okay, I'm guessing it will take around 5 hours. So maybe around till 3 o'clock. Yeah. Yes. Lunch break. Don't- So having said this, let's do some questions, guys, on your screen. Here it comes. Observe. A 3 meter long wire of some radius shows some extension when loaded. The value of Young's modulus is how much? Okay, direct question. Let's see if you can figure this. Ready for it? Yeah. Voice problem? Is it? Let's check now. Is the voice better? Yeah. Thank you, Rama, for pointing it out. Microphone. I hope it is now clear. Voice is audible. Mic audible. Visible. Yes. Okay. Perfect. So the question is figure out the Young's modulus. Yes. Let's see. Young's modulus is the ratio of stress by strain. Stress is force by area. Strain is extension by original length. So force by area. Radius is given. So area of the cross section is pi r square. Elongation is below. Original length is on the top. That is what Young's modulus is. So now it's just a matter of substituting all the values. This force is nothing but whatever is the weight uh, which is subtended by it. Yeah, mass 50 kg. So mg will be there over here instead of force. So this F by A, right? This is F, this is area of the cross section. So you have to think as if this wire is there and you have connected some mass over here. So that mass is giving mg force, because of which this particular wire is elongating downwards by x. Original length was L. That is how you have to visualize it. Okay, mass is nothing but 50, g is nothing but 10, whole thing divided by pi, which is 3.14, multiplied by r square. Radius is 3 millimeters. So this will be 3 into 10 to the power minus 3 meters, but square it, multiplied by length. Original length is how much? 3 meter. So 3 meter. And extension 0.1 millimeter. So it is 0.1 multiplied by 10 to the power minus 3 meters. So that's it. Now you just have to solve it and you will get the answer. Like for example, this will become 5 into 10 to the power 2, and this 3 will be there. This 3.14 is there. 3 square will become 9. This will become minus 6. This will become minus 4 and all of that. And you will see few of the things will get cancelled, like this 3 and this 9 will become 3 and all of that. Minus 6 and minus 4 will become minus 10. Minus 10 goes on the top, becomes plus 10. So it will become 5 into 10 to the power plus 10 plus 2 is 12. Whole thing divided by 3 into 3.14. 3 into 3.14. So approximately, can you guess how much will it come out to be? Because finally you have to give it in 10 to the power 11, is it? So it will be 50 divided by 3 multiplied by 3.14 into 10 to the power 11. So this number is basically P. This number is basically our P over here. So 3 threes are 9, 9 fives are 45. So it will be close to 5, I feel. So it will be close to 5. So I will just mark this as the answer. Is that right? Yeah, very close to 5. You have to use logic now. You cannot sit and say, ki, sir, what to do, this, that. Don't sit and calculate. All right. Let's go. Next question on your screen, and here it comes. If a rubber rod is stretched, is stretched by, is stretched by a stress of 2 into 10 to the power 8 Newton per meter square, having Young's modulus 5 into 10 to the power 9 Newton per meter square, length 0.1 meter square, sorry, length is 2 meters and area of section is 0.1 meter square. Find the energy stored. Find the energy stored in that particular rubber band. Very nice question. Let's see how do we approach this question. Area of cross section is mentioned, length is mentioned. Area of cross section is mentioned, length is mentioned. It is being pulled, so it elongates. So there is some energy stored in it because you have applied some kind of stress on it. So question is how much energy is stored. Let's see. Energy stored, there is a formula, I just gave it to you. Energy density rather. Half sigma epsilon is energy per unit volume. So if I use that relation, energy per unit volume is half stress multiplied by strain. My energy will be half into stress into strain into the volume. But the problem is I do not know the strain and volume, but volume at least I can find out because area and length is given. So it will be area multiplied by length is volume. Problem is for strain, what do I do? For that, I have an idea. Young's modulus is stress by strain. So therefore, how much is strain? Strain will be stress by Young's modulus. So why not substitute strain as stress by Young's modulus? My job is done now. So it is half into stress square into area multiplied by length. So it's just a matter of substituting all the values. So half is there. Stress 2 into 10 to the power 8, 2 into 10 to the power 8 whole square multiplied by, oh sorry, I forgot that Young's modulus. See what is happening. Young's modulus is also there over here, this y. Okay, multiplied by area into length. Area is 0.1, length is 2, whole thing divided by modulus of elasticity, which is 5 into 10 to the power 9, I believe. So that will give me the energy as, check this out, 2 square is 4, 2 square is 4, 4 2s are 8 multiplied by 10 to the power 8 raised to 2, 16 into 0.1 is 15. So 10 to the power 15, whole thing divided by, yeah, 2 5s are 10 into 10 to the power 9 will make it 10 to the power 10, I believe. Just see this, if this is fine. 16 and 0.1 is 15, 2 into 2 is 4, but this 2 square, so 8, 2 5s are 10, 10 into 10 to the power 9 is 10 to the power 10. So this will become 8 into 10 to the power 5 joules. That much energy is there. 8, 10 to the power 5. Just check this out. Yes, Ibu, that's absolutely correct. Neo, I think you made a mistake. Yes, the answer is 8 into 10 to the power 5. Okay. See if you have made some kind of calculation mistake, then you will get a wrong answer. Pavi, just check it out again. No, it is not 16. Yes, it is 8 into 10 to the power 5. Yes, awesome, awesome, awesome. Pakka, Sai, yes, Rama, got it. Yeah. So these kind of manipulations might be needed. Suddenly strain is not given, don't get scared. You can use this formula, substitute it here, you will get the answer. Okay, cool, awesome. Okay, so these kind of questions directly based on these formulas, whatever we have studied over here, this and this. Okay, let's go to the next concept, which is surface tension and surface energy, both of them. So you can use different symbols, up to you. Surface tension is that property of a liquid which makes the liquid surface minimal and contracts the surface. So if anything tries to condense and contracts itself, it feels as if somebody has stretched it and it is under tension. And because of that tension on that surface, it wants to minimize its surface. So the liquid surface always behaves as if it is under tension. That is why we call that phenomena as surface tension. You would have seen that when you pour some liquid on a glass surface, drops are formed because it does not want to spread. Rather, it contracts and makes into small drops because surface is minimal, or it tries to, because when it spreads, the area becomes huge, but when it becomes small drops, the area is less. So the force of surface tension depends on how much length you are taking on the surface. So if you have a surface like this of liquid, if you have a surface of a liquid like this, and somebody has chosen some random length over here, this is imaginary, this is that length L, then the force will act both ways. This side will pull this side like this side will pull this side like this. Newton's third law, action and reaction. That force per unit length is called surface tension. I can use gamma or S or T, whichever symbol you like, you can use. Okay, generally I use S because that T, you might confuse it with normal tension. So I generally use S for surface tension. You can also use gamma or T also, not an issue. So the force is S into L because S is F by L. So this is the force acting per unit length on the free surface of that liquid. Unit will be Newton per meter, Newton on the top, meter below, so Newton per meter. It's a property which depends on the liquid material. So water, mercury, alcohol, tar, okay, some other liquid might have different surface tension. Okay. Now, if you are taking a film, what happens is, imagine there is a rod here, there is a rod here, there is another rod here, and somebody keeps a sliding rod like this, and then you create a film over here. Then lot of times this question comes, what is the force on that rod? And I've seen many kids say it is S into L, and that is of course wrong. It is not S into L. There is one S into L below also. So actually the net force on the rod is 2SL. Why there is one below is because that film has one upper surface and a lower surface. So the upper surface, this length will experience SL force. The behind surface will also experience SL force. So these two SLs, one behind, one on the top. So both these SLs will give a total force of 2SL. That's a common mistake many kids do. Okay. All right. Yes. King Cobra, we are going to have a break after the 11th syllabus. Not many slides. Just see. We are on 88. I think around 100 slides or something. Thermo will be done. And then we will complete 11th. And then we will have a break before the 12th standard. Okay. Yeah. So, Sai Krishna, think of it like this. Think of it like this. If you see from the sideways, this is that rod. This is that rod. This is that film. This is that film. This is the first surface. This is the second surface. So there will be a force over here and over here. This rod is like this, isn't it? This rod is like this. The liquid is on the top over here and below also over here. So the top face experiences SL force, and the bottom also experiences SL force. So that is why the net force is 2 times of SL. Try to visualize, because the film also will have some kind of thickness on it. So that is the reason for it. Now you understood? Sai, everyone? Yeah? In between 1 and 2, there is no force because that is not a free surface. This part is not a free surface. It is attached to a solid. The force of surface tension only comes on that free surface of the liquid. Free means it is exposed to atmosphere or air, not which is attached to a solid or another liquid. So you can see this is the exposed surface, but this particular part which is inside, that will not have any kind of force. That will not have any kind of force. Okay, got it? All right. Now, also keep in mind, whenever you are creating a surface, or you imagine you take this rod and you pull it, more number of molecules will have to now be exposed to the air, and that is something which a liquid will not like. A liquid will always try to pull this rod and minimize the number of molecules on the surface. So this gives me the idea that the surface of a liquid has some ability to perform work, because it can pull that rod on by itself by pushing the molecules deep inside, removing it from the surface. So it has potential energy that is called surface potential energy or surface energy. That surface energy formula is USA. Very easy to remember. United States of America. What is it? United States of America. U is equal to S into A. That is the energy possessed by the surface of a liquid. So if area changes, energy changes. Area decreases, energy decreases. So always energies are always in the minimal side. So areas will also try to be as less as possible. Area will also be as less as possible. So one of the most common type of questions which you get is this. One of the most common type of questions that you can get force wise is they might tell you there is a needle of mass 50 grams and length 20 centimeters on the surface of a liquid. Find the surface tension needed to keep it floating. So think of it like this. This is that needle. This is that water surface. So the needle is submerged, like it's floating on the liquid surface like this. Okay. This is the inside part of that liquid. Question is, what is the minimum surface tension needed? So you have to think why will it be floating first of all. So what happens is the liquid will basically make some contact like this with the solid over here, and it will prevent it from sinking, not because of the buoyant force. Yes, the weight of the rod is there, the weight is there, which is mg. Weight is definitely there, which is mg. But do not forget the surface tension on all these points. This is the length. It will try to pull it up like this. It will try to pull it up like this. Same thing over here also behind, although you cannot see it. Ideally, I should draw a dotted line, but still it's okay. So you will see a force of surface tension over here. If the length of that cylinder is L, this will be SL over here. This will be also SL over here. See if you are able to visualize it. That entire length, surface tension force of surface tension will always act along the surface. It will pull that liquid surface. It will pull this liquid surface on the top and prevent it from going down. Always the free surface of a liquid is under tension. So even if you bend it like this, that force will try to pull that surface up, else that solid will sink and it will disengage the surface. So you have to pull the surface up, so the force will be upwards. Are you able to visualize it now? So that's it. So we can just say 2 times of SL is going to be equal to m into g. Mass is 50 grams. So 50 into 10 to the power minus 3. G is basically 10. 2 times surface tension, which I do not know. Length is 20 centimeters, so 20 into 10 to the power minus 2, I believe. So therefore, S will be 5 into 10 to the power minus 1, because 0, 0 cancels, negative 1 will be there. 2 2s are 4. 40 into 10 to the power minus 2, which is 4 into 10 to the power minus 1. 4 into 10 to the power minus 1. Minus 1 cancels. So 5 by 4 means 1.25 Newton per meter is the surface tension. 1.25. Not 25. Just check it out. Not 25, guys. It is 1.25. Why did you say 25? That is wrong. I think you guys forgot that number 2. So that's why you would have got 2.5. And maybe you would have forgotten to convert grams into kg, centimeters into meters, all those things. Be careful. Do not give the answer in CGS units. Usually give the answer in SI unless it is asked otherwise. Okay? Yeah, 1.25 it is. Let's do another question. This is based on surface energy. Okay, let's do this. It says that there is a big drop which is formed by coalescing. Coalescing means they meet, merge, become one. They coalesce, they become one. 1,000 drops, what is the surface energy going to become? Interesting. So, let's say we have one big drop is formed by coalescing small drops. So, the small, teeny, mini, chintu mintu drops are R. Like that, you have 1,000 such drops. All of them together give you one big drop whose radius is now something else. How many times will the surface energy become? Okay. Initially, if you ask me, the surface energy will be surface tension, which is S, multiplied by area, which is there initially. Surface tension is S only. Area of a sphere is 4 pi r square, but there are 1,000 such in number, so 1,000 into this. That is the initial surface energy. If you ask me what is it finally, well, I will say again it is S into final area. S is S. Final area is just one big area of 4 pi r square. Now the problem is how many times is this big R as compared to small r? For that, use volume conservation. Volume is conserved. Volume is definitely going to be conserved. So if you look initial volume, each sphere has a volume of 4 by 3 pi r cube, like that thousands are there. Finally, the volume becomes just for one big sphere, which is 4 by 3 pi r cube. 4 by 3 pi will cancel, so r cube will be there over here. And here we'll have just 1,000, which is 10 to the power 3 into r cube. So clearly from this, we can see that 10r is nothing but capital R. 10r is nothing but capital R. Awesome. So I think now we can do the math. So S multiplied by 4 pi multiplied by r square, which means 10r small whole square. So what I will get is nothing but 100 into S multiplied by 4 pi multiplied by r square. So now just divide both of them, you will get the answer. U final by U initial. Yes, U final by U initial will be S common, 4 pi common, r square common. Final has the number 100, initial has the number 1,000. So which means the final energy will be initial energy multiplied by how many times? Divided by 10. Sorry, divided by 10 times. Yeah. So final energy is initial energy by 10. 1/10, which is the fourth option. 1/10, which is the fourth option. Everybody with me? Yes, no. Pakka? Done? Sorted? Yes, sir. Done, sir. Very good. Excellent. Yeah, we have it 3 hours. Okay, looks like it's going to go more. So, guys, I have sacrificed my Sunday. I mean, obviously, family plans, everything were there. But I know tomorrow nobody will be watching the class because of Diwali, and it is justified. because you have to burst crackers, you have to light up your house, cleaning, everything will be there. So tomorrow, yes, no class, but there will be one strategy video which will come up by, I think, Diksha ma'am for chemistry. That is 5 minutes, I think. And today I wanted you guys to spend this time, plus I'm devoting this time just for all of you. Okay, so make sure you're liking this video, because I could have easily said we'll do marathons at the end, but I feel every time that is one mistake probably we shouldn't be doing. We should not push ourselves in the end. We should push ourselves right from the beginning. And we have 100 days. Every day of these last few months, we should be pushing ourselves for JEE Mains first attempt, because if we clear first attempt, then all other exams will fall in place, or else we will be only in trouble. Okay, JEE Advanced will go for a toss, BitSat will go for a toss, CUAT, KCET, COMEDK, EAP SAT, MSTCET, WBJE, IIT, NEST. So many exams are there. So we don't want to lose out on those marks. So let's push ourselves every single day. So marathon is there every day. That's how you have to prepare yourself mentally. Yeah. Yes. So let's move. We have already come to thermo, guys. Yeah. So after thermo, I think we will, it's done. I mean, I think, yeah. So after thermo, we are going to have a small break. Yes. And then we will go to 12th standard after the break. Okay. Right. So let's quickly revise different concepts, whatever are coming so frequently in our JEE Mains examination. Okay. First one, isothermal, isochoric, isobaric process. Isothermal means iso, same, thermal means same temperature. So temperature remains the same like boiling of water, where when you boil the water, unless all the water boils, the temperature remains 100 degrees Celsius. Isothermal process, temperature is constant. The internal energy will not change of that gas, because internal energy is dependent on the temperature alone, along with specific heat capacity. Work done is nRT log final volume by initial volume, and heat is W. This comes from the first law. So probably we'll have to revise all these things for you. For isobaric, volume is, sorry, pressure is going to be constant, and for isochoric, volume is going to be constant. So just to quickly give you a heads up of this, you should first know the law of thermodynamics, the first law of thermo, which says whatever heat you give, heat which is given to the system increases the internal energy and also used for doing work, meaning Q is delta U plus work. Formulas for everyone I'll give you. For work, the formula is integration of PdV, or area under pressure versus volume graph. If work is positive, it is expansion. If it is negative, it is compression. As simple as that. Next, delta U, standard formula, NCV delta T. Irrespective of the process, always CV, specific heat capacity, at constant volume will come. And if it is positive, that means it is increasing. And if it is negative, it means it is decreasing. That's one thing. Last one is for, what is it? Heat. Heat formula is NC for that particular process. It depends on it, into delta T. Here, irrespective of the process, it's always CV, but heat depends on the process, whether it is isothermal, adiabatic, isochoric, isobaric, polytropic, whatever. Accordingly, C value will change. And if Q value is positive, it has absorbed heat. If it is negative, it has released the heat. Absorb versus release. So these are the sign conventions which you should know for the first law's terms. Q is delta U plus work done. Now that you understand this, if you go back, it makes sense. For isothermal, there is no change in internal energy. So delta U is 0. So that's why heat is the work done. You don't have to by heart. It makes sense. It all falls in a place. Okay, it all falls in place. For isochoric, volume is constant. So it kind of makes sense that area will be nothing. Volume change will be 0. So work will be 0. So if work is 0, whatever is heat will be delta U. So delta U is NCV delta T. Even Q will be NCV delta T. That's what it is. So work will be 0. Q will be delta U, which is NCV delta T. For isobaric process, pressure is constant, heat will be there, delta U will be there, work will also be there. Because pressure is constant, P comes outside. So work will be P delta V simply. So work will be just P delta V. And heat will be delta U plus P delta V, which is NCP delta T. Why is Q NCP delta T? Let's go back over here. Q is NC for that process. What was that process? Isobaric. So it will become CP and then delta T. Okay. You don't have to actually by heart this slide, nor have to waste time. If you just revise it logically, it will make sense. Else you will be stuck. Okay. So let's do some questions on this. Usually the questions which come are matrix type or match the following type. So you will see that over here. Match the following. One of them is correct. Isothermal. Isothermal, guys, where will it match? Temperature is constant, so delta U will be 0, I believe. So 1 will go with 4. Makes sense. A will go with 4. Yeah. What about adiabatic? Adiabatic means you have not given it any heat. So Q will be 0. So heat supplied will be 0, of course. Isobaric and isochoric. Isochoric, it is very simple. The work done will be 0. And isobaric, yes, there will be some kind of change in the internal energy. So I think this will directly go over here. So this is the answer. A with 4, B with 2, A with 4, B with 2, and C with 3, and D with 1. So I can see this particular option, which is correct. The third option, option C. Yes, perfect. That's it. Similarly, you can see next next year also, again, they have asked the same type of question. Okay, isobaric, isochoric, very common. Match the following is their favorite model of question. Pressure varies inversely with volume of the ideal gas. So in this question, you know what? Don't look at list 1 and then list 2. Sometimes it is easier to look at this column first and then figure out where will it match. Like for example, isobaric process or isothermal process, let's say, or isochoric process. So if you look at isochoric process, work will not be done. So no work is done on or by the gas. Oh, I can already see isochoric process, no work is done. Already it is matching. For adiabatic, no heat will be absorbed or released. So there you go. And then let's say for isothermal process, temperature is constant. Temperature is constant. So therefore pressure PV is constant. So therefore P is inversely proportional to V. So therefore this is the option which will match for isothermal process. Can you see that? And for isobaric, whatever heat you give will be used to increase the internal energy and partially to do work. That is your first law, if you notice. Whatever heat is given changes the energy and also used for doing work. That is exactly your first law of thermodynamics. So 4 will go with B. So A goes with 3. A is going with 3. So 2 options are there. B is going with 4. So obviously the fourth option is the right answer. That's it. So this is how you can solve the questions. Very simple. Yeah. Sometimes you don't have to solve for everything. You can just, check few of the terms and that's it. You are done. Okay, very good. So similarly, let's look at some more questions. But before that, this particular concept of adiabatic versus polytropic, lot of times questions will come on this adiabatic process and polytropic process. First, let me focus on adiabatic. Adiabatic means it's insulated from the surroundings. So whatever heat exchange happens inside. No heat from outside, no heat taken out to the surroundings. So Q is 0. So whenever Q is 0, pressure into volume raised to gamma is constant, or even you can say TV raised to gamma minus 1 is a constant. Remember, gamma is our ratio of Cp by Cv, which is also 1 plus 2 by degrees of freedom. That's your standard formula. Gamma is Cp by Cv, which is 1 plus 2 by F. It's the ratio of specific heat capacities. The work done, how do you calculate, is as follows. Because Q is 0, so 0 is delta U plus work. Therefore, work done is negative delta U. So it is minus N CV delta T. So that is how you can calculate work, either by this formula, or you can use this formula also. P1 V1 minus P2 V2 upon gamma minus 1. P1 V1 minus P2 V2 upon gamma minus 1. This is also perfectly fine. In fact, CV formula is, R upon gamma minus 1. So if you put that, you will exactly get this. Okay, so this is one way of solving adiabatic questions. Now, what is this polytropic? Polytropic means any process which follows some curve of this equation, PV raised to some number is a constant, is a polytropic process. So, say for example, this is our graph. This is pressure. This is volume. Imagine I show a curve like this, where P into V raised to 1 is constant. This is nothing but a isothermal graph. This is nothing but an isothermal graph. If I make it adiabatic, maybe it will be like this. This is adiabatic graph. Here P into V raised to gamma is a constant. Maybe it could be some another number. So this is PV raised to some number is a constant. This graph can go up, down, anywhere. This is nothing but polytropic process. This is a polytropic process. So a smooth curve with a relationship PV raised to some number is a constant is called a polytropic process. Now, the speciality also is that if you draw a tangent, to the graph and you measure the slope of the tangent, the slope is always minus that power n into P by V. Slope is minus n, minus because it is down, negative. N is that power, pressure by volume at that particular point. At that particular point, whatever is the pressure and volume, that gives me the slope. This also tells me that if I measure the slope of isothermal process, for isothermal process, volume's power is 1, so it will be minus 1 multiplied by P by V. Whereas, if you check the slope of adiabatic, it will be minus gamma times of P by V, because the power of volume is gamma. So always adiabatic slope is more steeper than the isothermal slope. That is why the adiabatic graph has come below this particular isotherm starting from the same point. Okay, because it is gamma times steeper. Okay, this is another important relationship. So now, if you notice, polytropic process is just like adiabatic process, but with a different power. Instead of gamma, you are using the word N. That's it. Everything else is same. Yeah, heat absorbed and released is not zero. It will be there. But mathematically speaking, only that much difference is there. So you will see even the work done has the same formula. It is just P1 V1 minus P2 V2. Instead of gamma minus 1, there is N minus 1. That's it. That's the only difference. Yeah. All right. Yeah. Everyone? Yeah. Collisions not there. It's high weightage, it's important, but not in that 31% topic list. Maybe it is 35th or 34th. So maybe there might be a topic which is there coming many times, but not as important as the top 31 topics. Yeah, so there are certain topics like that as well. Okay. So let's do some questions. Here it comes on this particular topic. Okay, get ready for it. There is a gas kept in a container having walls which are thermally non-conducting. Thermally not conducting, that means they do not allow any heat to flow here and there. Volume is given, temperature is given, the change in the temperature when it is compressed, adiabatic. It kind of makes sense that it is adiabatic because these are non-conducting walls. So it is a adiabatic process. So volume is changed, temperature will change. Question is the change in the temperature. Okay. So we know for an adiabatic process, temperature into volume raised to gamma minus 1 is a constant. All right. Gamma is already given. Good for us. What about temperature? I think 27 degrees Celsius. Don't keep it like that. It will be 300 Kelvin. Yeah, always keep temperatures in Kelvin. That's a common mistake you will do. So first temperature is 300, volume is 800, and gamma is 1.5 minus 1. That's LHS. It is compressed to 200. So final volume is 200. Temperature I do not know. Temperature into 200 whole raised to 1.5 minus 1. Some of you will argue, sir, why did you not convert centimeter cube to meter cube? There is no point because here and here, centimeter cube, if it is there, it will anyways cancel the units. So no point. But then you will be like, sir, then why can't you keep Celsius and Celsius? Even Celsius will cancel. See, Celsius is not a unit which gets multiplied by Kelvin. Like 1 Kelvin is not some 273 times Celsius and all of that. It is plus something. So you cannot really cancel them on both sides. But centimeter cube and meter cube, they are really related by a factor of 10 to the power minus 6. So that factor can get cancelled. Here such a factor does not exist for temperature. It is a addition subtraction relation. So that is the reason why you cannot cancel. Okay. In simple terms, it's like this. If I have A multiplied by 20 and B multiplied by 20, obviously this 20 and 20 cancels. But if I have A multiplied by 20 and B multiplied by 20 plus 273, will they cancel? They will not cancel. So they will not cancel out each other. So that is the reason why we cannot keep temperature scales as Celsius. We will have to convert it into Kelvin, no other choice. Okay. So this will be 300 multiplied by 1.5 minus 1 is 0.5. So root of 800. So this is root of 800, of course, is T. This is root of 200. So T will be 300 multiplied by root of 800 by 200, which is 300 root of 4, which is 300 multiplied by 2, which is 600 Kelvin. 600 Kelvin is right over here. Got it, everyone? Yeah. So that's how you should solve questions. You should always think, why am I converting? Why am I not converting? Will it matter? Not? Because or else we can just keep on solving questions and you will make such a silly mistake in the actual examination. All right. Let's go to the next question, which is right over here on polytropic process. Let's see what does it say. There is a gas cycle which is given. This is also very commonly asked type of questions. Graphs are given and they will ask you work, energy, etc. A real gas is there. Okay. Gas obeys some PV cube is equal to RT, some weird equation from A to B. But other parts, it's fine. The net work done in the complete cycle is how much? Okay. So I'll tell you one thing over here. We have to find the total work done. Is it? Where is it, man? Okay, here. See, from this point to this point, that is here, this point to this point, it is isochoric process. So C to A is isochoric process. So work done from C to A is absolutely zero. Then if you look at B to C, if you look at B to C is isobaric process. So work done from B to C is P delta V, which will make it pressure is 10, final volume is 2, initial volume is 4, which is 2 minus 4 is minus 2, minus 2 into 10 is minus 20 joules. Yeah, minus 20 joules is the answer for that downward part because it is isobaric process. Everyone till this point absolutely clear? Okay. Now the problem is only for this part because some weird equation is there, PV cube is equal to RT. So what do we do? Only for this part, because once that is done, our job is done. Our job is done. Let's see. We'll go by the definition. So from A to B, it's some kind of weird process. So work done is integral of PdV. Pressure, if you observe, is RT divided by V cube. Pressure is RT divided by V cube, and this is dV. And I think it is mentioned somewhere that the chamber is maintained at 27 degrees Celsius. So temperature is constant somehow. So R and T will be outside. Volume's power will be -3 will the integral dV. Initial volume to final volume 2 to 4. Those are the limits of the integration. So 2 to number 4. So R is R, T is T. V raised to minus 3 is integration is V raised to minus 2 divided by 2. Okay. Limits 2 to 4. Now let's start substituting. So the work done will be R is 8 point, I think some value will be given. Oh, it is not 8 point, it is just 8. It's much easier than for calculations. 8 is there. Temperature is 27 Celsius, which is 300 Kelvin. And this whole thing divided by 2, of course. Put the value of 4 first. So 4 raised to minus 2 minus 2 raised to minus 2. So 8 by 2 is 4, 4 3s are 12, so 1200. 1 by 4 square means 1 by 16 minus 1 by 4. So LCM is 16, so 1 minus 4, which is minus 3 by 16. And this is 1200, of course. So 16 with 1200. Will it go or not? Think. 16 by 4 is 4. 1200 by 4 is 300. By 2 is 2. This will be 150. By 2, this will be 75. Okay, perfect. It goes 75 times multiplied by minus 3, which is minus 225 joules. That's it. So the total net work done will be minus 225 plus 0 plus 20, which is minus 205 joules. Minus 205 joules, which is right over here. Okay, or basically just 205 joules. Is that clear, everyone? Yeah. Perfect. Awesome. Awesome. I think it will not be minus, guys. I think it should be plus. Just 1 second. 1 second. Let me see whether it will be plus or minus. It will be. Oh, I have missed a minus sign. And I did not take it as minus 20. I'm so sorry. I made two mistakes. That's why I got a weird answer. Sorry, guys. There is -2 here. I missed that -2. There is that negative sign here always. So minus and minus will make it plus. So sorry. This will be plus 225 joules. So now the net work done will be 225 plus that work was 0. This work was not plus 20, it was minus 20. So sorry. And this will be positive 205 joules. Positive 205 joules. So there was no minus 205, there was plus 205. Yeah, that is perfect. I missed that minus sign here and minus sign here. So always they say, right, whenever you make a mistake, always make even number of mistakes. Yeah. So when you make even number of mistakes, usually they get cancelled and then you are almost on the right track. Yeah. So keep that in mind. And this, you will be like, sir, how do I know I will make even number of mistakes? That is by luck. That is by luck. Sometimes you can do it deliberately. You know you are solving a big problem. I don't know whether minus sign will come. So no issues. If I miss a minus sign here, I'll miss the minus sign again at some another critical step. So that's it. It will nullify it. So I have seen it in reality many times and it works. Yeah. Okay. Let's go to the next, which is degrees of freedom and all of that. So I will rather do it by a table and other things. So see guys, certain important relationships. CP minus CV is R. This is called Mayer relationship. CP by CV is specific heat capacity ratio, which is also 1 plus 2 by degrees of freedom. That is another specific heat capacity ratio. Specific heat capacity ratio, very important. From this only you will get CV as R upon gamma minus 1 and CP as gamma R upon gamma minus 1. This is what you get. Yeah. Now, this degrees of freedom depends on the type of the molecules that you have. So, starting off with monoatomic molecules like helium, neon, argon, then going to diatomic molecules like oxygen, nitrogen, hydrogen, etc. Then going to even triatomic but linear molecules like carbon dioxide. Then you go to polyatomic molecules, maybe say H2O or H2SO4, some weird things. Okay, so multiple polyatomic molecules are possible. So my dear warriors, in each case, how many degrees of freedom are there? Everything will figure it out. First, talking about translation, this has 3 translation and 0 rotation, making it 3 degrees of freedom. 3 degrees of freedom. This has 3 translation, even this, by the way, both of them are the same thing. This has 3 translation and 2 rotational degrees, making it 5 degrees of freedom. This has 3 translational and 3 rotational degrees, making it 6 degrees of freedom. So when you try to calculate CP and CV, here is how it looks. By the way, even CV and CP have another formulas also, specifically CV. It is nothing but R into degrees of freedom by 2 also you can write it. R into degrees of freedom by 2. So if you see the first case, degrees of freedom is 3. So CV will be 3R by 2. These are just CV values. This will be 5R by 2. This will be 6R by 2, which is basically 3R. From this, you can also find the value of CP. You can also find the value of CP. CP is always more than CV by a single R. CP minus CV is R. So CP is R plus CV. So if you add R to this, if you add one single R to this, you will get 5R by 2. 1 R to this, you will get 7R by 2. 1 R to this, you will get 4 times of R. And lastly, you can also get gamma, which is this divided by this. So RR22 cancels, you will get 5 by 3, 7 by 5, and here 4 divided by 3. 4 divided by 3. Wow. Great. Now, under special circumstances, when you increase the temperature to a very high value like 2000 Kelvin, 3000 Kelvin, like that, or 1000 Kelvin, then some additional degrees of freedom, those are free vibrations which come. So I can just say that here plus 2 vibrational degrees of freedom, and I will put a star mark. This star mark says for high temperature only, for high temperature only, vibrational comes. So in that case, the total degrees of freedom will not be 5, it will be 7. So then you will see it will have 7 degrees of freedom. So it will become 7R by 2. This will become 9R by 2. Okay, and this will become basically 9 by 7. Please keep in mind this is only at high temperature that additional degrees have come. Okay, which will make the total degrees of freedom 7 degrees of freedom. Again, I'll put a star mark. That star mark is over here. Okay, clear? So, yeah, 2 vibrational degrees of freedom come, which is at a very high temperature. Yeah. This is also from chemistry, I know. Yes. All right. So let's have a look at some question, maybe this one or maybe this one. Okay. I'll give one homework question now. Okay. Because too many questions will come now. Just try to do this as homework because this is statement based. So you can sit coolly and solve it. Okay. Just solve that. Let's do one question over here, maybe. According to the law of equipartition of energy, the molar specific heat capacity of a diatomic gas at a constant volume where a molecule has one additional vibrational mode. Wow, this is amazing question. According to the law of equipartition of energy, diatomic gas at constant volume where there is one additional mode. What is the molar specific heat capacity at constant volume? Basically, they are asking what is the value of CV. Now, CV is RF by 2, simple. So, what is F is the question because that will give me the answer. So, observe it is a diatomic gas. Diatomic gas means 3 translational freedom, 2 rotational freedom, vibrational mode. Now, lot of students, I know what they did, they added one vibrational mode. They thought one is given. But please keep in mind, it is not one, it is 2 vibrational degrees of freedom because one mode of vibration is 2 degrees of freedom of vibration. Very, very important. So a mode means how it is oscillating back and forth. This is a mode, but a mode creates 2 degrees of freedom. It creates 2 degrees of freedom of vibration. So this is very, very critical. So lot of people made a mistake here. Instead of putting 2, they put 1. 3 plus 2, 5, 5 plus 2 is 7. So 7 degrees of freedom. So put 7. So hence the answer will be 7R by 2. Answer will be 7R by 2. Is that absolutely clear? Oh, JEE Mains date out. My goodness, guys, what nonsense. This is breaking news. Let me open JEE Mains website. Please call in everyone. Namrata ma'am, if you can go live and make that announcement, that will be great. Or is that so? My God, where is it? Where is it? Where is it? Advisory is there. Advisory is there. Is it real? Namrata ma'am, NTA official notification. I'm just checking, ma'am. You are scaring me. Where is JEE Mains date? Let me check. JEE Mains 2020, was it 2020? Which year are we in? 2025, no? We are in. My God, guys, I'm very confused now because suddenly nervous. Dates are out. Tentative dates, tentative dates, tentative dates. Bro, where is the date? Let's check tools anytime past 24 hours. Not there, not there. 38 minutes ago. Advisory. Is this the one? Okay. The NTA will be conducting the JEE examination in CBT mode in 2 sessions, Jan and 20 April. Okay, online will be live in October. Okay, online application form 25 October. Hopefully, it is not before Diwali. Oh, the dates are out. Yes, the date of the examination 21st to 31st. Guys, how many of you remember I made that prediction just couple of days back only? In fact, when I made that announcement on the channel, I don't know whether you have seen it live. Yes, I told this, I think, couple of weeks back during this particular announcement that the exam dates will be most likely between 21st of January and 25th of January. That's the starting date, and it is exactly 21st. And I told the ending date will be most likely the last day of Jan, maximum first week, first Feb. But that is also very less probable, and it is exactly the same. Final April dates, this is scary. Between 1st and 10th April, that means you will have very little time after your board examination. Wow. So, rest all things I don't think are important. They are just asked to keep the documents ready. NTA will be obtaining name, etc. from Aadhaar. So, however, since etc. is not recorded, the will have to fill such details in case of mismatch. To overcome this issue, you may also refer to NTA notice. So if your name is different in Aadhaar card and your 10th board certificate, then you will have to give the actual one, and it will be taken care of as per this particular advisory which was given last time. So that is one thing. May your efforts light up the way to success and bring a bright future in your. My God, guys, my God. NTA is wishing us. Is it mocking us or what? Guys, what's this statement? May your efforts light up the way to success and bring a bright future in your academic journey. How can mock extends warm wishes to JS students for a joyful, prosperous, and happy Diwali. Are they like secretly meaning something over here or what? Like the paper is going to be tough, bro. Enjoy your Diwali, bro. Now you wait and watch, bro, what I'm going to do. Your efforts will light up the way to success. Crazy. Okay, wait. 1 second, guys. Namrata ma'am is calling. Okay. So, guys, anyways, our this topic is done, and I will also make an announcement because for other students also this is necessary. So we'll meet after a break. Okay, so till that time, stay tuned on the channel. We'll have a short break. Bye bye, take care. my dear J Warriors, the official notification is out on the NTA website. Yes, just go to JEE Mains nta.nic.in and the advisory is up on the official website. So let's have a look at it. What does it say? And it's a very shocking update. And by the way, please smash the like button and subscribe to the #1 J English channel, which is Vedantu J English, so that you get timely updates and without any rumors. So let's get straight to the point. Thank you for liking. As you can see, NT will be conducting examination in CVT mode, 2 sessions, Jan and April expected. But what is shocking is over here, the second session dates, not the first session dates. The first session is still as expected, 21st January to 30th of January. Yes, 21st of January to 30th of January. Yeah. And the registration form will be out in October. Now, since they have released the advisory, I think NTA is going to drop a bomb on us just during Diwali. Everybody was celebrating Diwali nicely, enjoying with sweets, spending family time. And NTA decided, let's ruin the party. Yay. And there we go, October 2025. At least they could have waited after Diwali. Students would have calmed down, but yeah, why we want to spoil Diwali now? Anyways, now session 2 dates, look at it. It is crazy. 1st April to 10th of April. That means you will have very little time after your board exams if you are unlucky and getting the exam date on 1st of April. And there are many state board students whose exams are going till 28th of March, 27th of March, which means very little time for the second attempt. It's as good as you are just having a single attempt. Okay, #1. Now, they have also told that the forms will be released soon, the registration forms. And if your names are different, one in the 10th certificate and one in the is my screen upside down or what? 1 second, guys. No, it is fine. Guys, my screen is not. Oh, the screen is reverse. Oh, that I can't help. I'm so sorry because this is a phone and I can't. Uh, I can't do that. Okay. Anyways, I'll just tell you what it is over here. So they have asked to update the ID cards and all of it. #1, and in the end, they have wished us happy Diwali. This message NT has been like a pookie now. It's wishing all the JEE aspirants a joyful, prosperous, and happy Diwali. May your efforts light up the way to success and bring bright future. So maybe they are advising us in advance that listen, bro, the exam is going to be hard. So enjoy your Diwali. After that, you are going to have real fun. So Pookie NTA is warning us in advance and wishing us to enjoy the Diwali. And NTA is really, really cooking IBU. Yes, for sure. For a very tough paper, it looks like. So you better prepare for hard paper. Don't prepare for an easy paper. Okay. So that was the official notification. Thank you so much. Have a great time. Bye bye. Take care. And yes, join the marathon. The marathon is going live on the Vedantu J English channel. If you are seeing, it's a big marathon already. 4 hours are done. Yes, this is a sure shot 31 topics marathon. I have just given the break. So join in. Okay. Bye bye. Take care. Hello. Welcome back, guys. And how was your break? Did you tell your parents or someone, your call, your friend, J dates are out, what to do, bro? Yeah, good afternoon, everyone. Hi, Rama. Welcome, Shri Hari, Shivani, Mist, Ajay, Aibu. Welcome, Rama. Welcome, everyone. Yeah, the atmosphere has changed, no? Suddenly, we are all so chill. Even though it was a marathon, even though we were tired, we are like, okay, still we'll push ourselves, push ourselves. We knew that the dates are coming, registration is coming, NTA will drop a bomb sometime, but we didn't know NTA burst the frackers before us. Yeah, they have burst a big bomb before us, before we could light up our Diwali crackers. So let's see how it goes. And it's time to gear up. It's a word of caution that we have to be better prepared. You cannot say just like COVID paper will be simple. It will not be. 2025 was tougher than 24, 24 was tougher than 23, 26 might be even tougher than 2025. So let's go all in, guys, with all the energy, with all the knowledge, with all the hard work, with all our motivation. Yeah, let's push ourselves. Yeah, let's go. Yes, Shriyari. I published a video also. You guys saw it or not? I don't know. It was the same thing. Where did it go, man? Okay, go on the channel. Come on, call your friends, guys. Shreyas Sir is back. Lunchtime is over. Yeah. So, oh, that is me. I am scared. And the the notification. I just made a video. You can have a look at it. Okay, regarding the JEE Mains dates. Ouch. Cool. So let's go with electrostatics. In that, the most common question is finding the field or fields due to one or multiple point charges. Now, field by definition is the force per unit charge, electric field. Same thing, gravitational field also, force per unit mass. So, if field is given, you can find force, or force and charge is given, you can find the electric field. Due to a singular point positive charge, the field is always radially outwards, whereas due to a singular point negative charge, it is always radially inwards. That's how the electric fields look like due to positive and negative charges, right? Yeah. Having said that, the formula for field is just the formula for force, but one charge is not there. So Coulomb's constant 1 by 4 pi epsilon naught is Coulomb's constant, which is having a value of 9 into 10 to the power 9. Remember this particular value that you see over here. That is your Coulomb constant, 9 into 10 to the power 9 SI units. Charge divided by R square. So whatever this charge is there, divided by the square of the distance, gives me the intensity of the field at that particular point. All right. And if there are multiple charges, then each charge will give out a field. So you can do vector addition. Remember, this is our vectors. Yeah, these are all vectors. So if you have one charge here, one charge here, one charge here, this charge might give field like this. This charge might give field like this. Maybe it is negative. This charge, maybe it is positive. So might give the field like this. So like that, due to every single charge, you can find out the field. Due to every single charge, you can find out the field and do the vector sum to find the net electric field. Very simple, straightforward. So based on that, a very common question which comes is exactly this one. There are two charges separated by some distance and find where the field will vanish. See, same thing. In fact, I have put it as homework also. Okay, if you want, we can do the homework question and I can give you this question as homework, anything. Yeah. So two charges are there. Where will the electric field vanish between them? So all you have to do is just take the vector addition of both of them, okay, and see where the field will become zero. So let's do this problem. I think this problem, no, I think I've done it in the marathon, if I'm not wrong. 9Q and Q, I think we have done it. Just check it out. It's done. So instead of doing that, we'll do this then. So the two charges are Q, this is R, and the second charge is 3Q. at a distance x from charge q, at a distance of x from charge q. Okay, so this is basically x. So naturally this will be r minus x. The electric field is 0. So this is the point where the net electric field is 0. So if the net electric field is 0, the fields due to charge q, which will be this side, and the field due to 3q, which will be this side, will cancel out each other. They will balance out each other, isn't it? So what is the field due to point q? Coulomb constant k into q divided by this distance from the charge is x, so x square. Due to 3q, k into 3q divided by this distance, I think it is r minus x now. So from this point charge at this point, how much is the field? K, K, Q, Q cancels. So 1 by x square is 3 divided by r minus x whole square. Taking square roots, 1 by x will be root 3 by r minus x. Cross multiplying, r minus x will be root 3 times of x. Therefore, taking x on one side, so r will be root 3x plus x. Taking x common, so you will get r divided by 1 plus root 3. R divided by 1 plus root 3. That is my third option. Is that right, everyone? Yeah. Very good. Excellent day. Awesome. Nitesh, 99 percentile strategy. Basically, the top topics video is coming tomorrow. So, ma'am, not tomorrow, day after tomorrow. I think on Tuesday. So ma'am will give you those topics and then we'll make separate videos on rebounding, rebouncing back. Okay, we'll make proper plan for all of the kids who missed out on the opportunities. Don't worry. Okay, so stay calm. We'll make the videos because I already got such requests. Many students have made it. So whatever we can do in the last 2 months, we cannot say nothing is possible. That is wrong. Something is possible. In fact, a lot of things are possible. So we'll try to do as much as we can to make sure you get a very good percentile and a good college. Okay. So stay tuned on the channel. So subscribe to the channel first of all. Now, next important is electric field due to extended objects, meaning big bodies, starting off with a line charge. Starting off with a line charge. So if you have a long charged body like this, okay, maybe this is positive charge, negative charge, doesn't matter. And the charge per unit length is lambda. So this is coulomb per meter is given to me. And I am standing at a distance, maybe over here, like this. This is the distance. Then what you should do is draw a line here, and mark these angles. Like this particular angle, you can say it is alpha. This particular angle, okay, over here, you can say it is beta. This is that distance between these two things over here. Okay. Then the electric field will have two components. One will be the x component, one will be the y component. How much is the component which is basically perpendicular to the line charge? That component is given by k, which is Coulomb constant, lambda divided by k lambda divided by r, and then you will have sine of sine of alpha plus sine of beta. That's it. K lambda divided by r, sine alpha plus sine beta. That is the formula, guys. It is inversely proportional to r, and you will have sine alpha plus sine beta, where alpha and beta are the angles subtended by the ends of the wire. Similarly, the component which is parallel will have the formula k lambda divided by r. Here you will have cos of alpha minus cos of beta. That's it. Cos of alpha minus cos of beta. That is the component which is perpendicular to it. The net electric field will be the vector addition of both of them. That's it. So just to show you one particular example on this, say my dear warriors, the question goes like this. There is a wire which has been bent like this. and the wire extends till infinity. Okay. Question is, can you figure out what is the electric field at this particular point, which is having the coordinates A, comma A? Okay. How much is the electric field at that point A, comma A? That is the question. Okay. This is the origin. This is the x-axis. This is the y-axis. Wire has lambda coulombs per meter as the linear charge density. Very nice question. It's a very, very good question, let me tell you. See, I'll tell you how to solve this. Consider any one of the wires. Okay, consider any one of the wires. Let's say I just consider for now this particular wire, and let us see where we are standing. We are standing over here. Okay, and at this particular point, this distance is A. This is also A. So if I join this line, obviously this will be 45 degrees. Can you see that? A and A will make it 45 degrees. And the second end of the wire is at infinity. So if you visualize, that other end will be very, very far away. So the other angle in a way will be 90 degrees. Now there will be two components of the electric field. One will be like this, one will be like this. We just saw it. So the electric field which is parallel will be K lambda divided by distance, which is A, cos alpha minus cos beta. So that means cos of 90 minus cos of 45. So which gives me K lambda divided by A, and cos 90 is 0. So 0 minus 1 by root 2, meaning it is minus K lambda by A root 2. This minus tells me that the electric field is not this way, rather it is the opposite way. Same thing you can do for the perpendicular one. It will be K lambda divided by A. It will be sine of 90 plus sine of 45, which makes it K lambda divided by A, 1 plus 1 by root 2. Now, once I got it, I will superimpose both these things and see what should I get. By the way, if my uh, if my wire was flat like this, if my wire was flat like this, by the same logic, this is like this is over here, the other is at 90 degree. The electric fields would come out like this. One component will be here, E perpendicular, and E parallel, which will be which direction I have taken, E parallel this way. It will be like this, but it will come out to be negative. That means actually the electric field is over here. That means actual electric field is over here. So here also, whatever direction I've assumed is wrong. So what I will do immediately, I will have to change it. So I will make it reverse. I will say that it is not actually that side. It is actually this side. It is actually this side. Is that clear? So this is E perpendicular. This is E parallel. Once this is done, once I understand how the components are and how much the magnitudes are, the geometry is symmetric, guys. So let's superimpose both of them and see what do we really get. So first of all, over here, there will be one parallel component here and there will be one perpendicular component over here. Okay. Similarly, from here, there will be one parallel and perpendicular component like this, one parallel here and one perpendicular over here. So let me start marking them. This is E perpendicular, this is E parallel, this is E parallel, and this is E perpendicular. Got it? Till this point, everybody clear? Till this point, everybody clear? Now think how much will be the total X component and total Y component. That is, superimpose means you take two things, find out two things separately and then combine them. Like I find the contribution of this wire separate, find the contribution of this wire separate, and then I combine both the effects over here. That is the meaning of superimpose. I merge them together. Okay. So what have we done in this particular problem? As you can see over here, whenever a finite wire is given, there are two components of electric field given by this formula. Alpha, beta are the angles obtained by the ends of the wire with the perpendicular drawn. So I took one part of the wire, this part at this same point, other end of the wire is at infinity. So one of the angles is 90 degree, the other angle is 45 because this is A, this is also A. The coordinates were A comma A. So I used these formulas and I found out the values of the electric fields. Because this answer came out negative, I'm sure that the electric field will not be this way, it will be exactly opposite way. So that's why I changed the direction. If you take the same diagram and if you put it here for this wire, this is 45 degrees, this is 90 degrees. So E parallel will be in the direction of where the 45 degrees angle is. Perpendicular means it will be away. For the horizontal wire, I found the components. For the vertical wire, I have found the components. Now I will superimpose both of them. See if now you understood this. Knowing tiger. Neo tiger, is it okay? So what will now the x component of the net field be? Perpendicular and parallel, these two we have to subtract. So it will be nothing but k lambda a 1 plus 1 by root 2, which is the perpendicular component, minus the parallel component. Parallel component means k lambda a by root 2, which will give me how much? Check this out. This k lambda a by root 2 and here will cancel and you will just get k lambda divided by a. Same way, Ey also you will get the answer. This minus this, E component, Y component, sorry, will be E perpendicular. E perpendicular means this. So it will be K lambda by A 1 plus 1 by root 2 minus E parallel. E parallel means this one, which is K lambda A by root 2, which will again give me the same answer. These two will cancel. Only K lambda by A will be remaining. So we got the X and Y components. Combining both of them together, I will get the net electric field, which is nothing but Ex square plus Ey square. So it will be nothing but root 2 times K lambda by A, because both components were K lambda by A. So the total will be root 2 times K lambda by A. That's how you can find it out. Now, I hope this is clear. This is a very good question. And this is definitely one of those questions which will probably trick many kids and make many mistakes. Many students are going to make many mistakes. So be careful. Just based on this formula. Okay. Just based on this particular formula. Linear charge density. If it is a infinite wire, so for infinite wire, what happens is the value of alpha and beta both become 90 degree. So you will see that in such scenarios, the parallel component will just become 0 because both of them will cancel. Only the perpendicular component will remain. Sine 90 plus sine 90, that is 1 plus 1, that is 2. So it will become 2k lambda divided by r. That is the formula for a infinitely long wire. That means endless, very, very long wire. Yeah. So that's how you do it. Anyways, let's go to the next few geometries coming up on your screen. The next one is nothing but this charge sheet. So if you have a charged sheet, something like this, sigma, which is coulomb, how many coulombs is there per unit area? That means meter square. Then the electric field is present both sides, and not just that, it is also uniform in nature, and that uniform electric field is just sigma by 2 epsilon naught. That's it, sigma by 2 epsilon naught. A special case of this is when you are considering the surface of a conductor. Imagine this is a conductor, a slice of a conductor like this, and this is inside part. This is that inside part of the conductor. So you will see that the electric field will always not just be perpendicular, but only come outside. The electric field is only outside, and not just that, it is perpendicular everywhere on the surface. And that is sigma by epsilon. You will see electric field in the interior part, will be zero. So very, very important. The electric field is only there on the surface of the conductor. It is not there on the inside part. The charges will also be there only on the surface. Yes, the charges will only be there on the surface. So sigma is exactly how much charge is there per unit area on that surface. Are you able to visualize this now? Yeah. Okay. So keep these two formulas also in mind. Moving on to the next geometry is this one, where you might have a ring of sorts. You might have a ring like this, and you are asked what is the electric field on the axis of a ring at a distance of x over here, and this radius is r, this is q. So the electric field is given by Coulomb constant q into x divided by r square plus x square whole thing raised to 3 by 2. Yeah, this is the formula, and the graph of it comes out to be somewhat like this. This is your electric field versus x. Yes, it becomes zero at the center. This is very, very important. Obviously, at this point, all the electric fields will cancel. And not just that, it reaches a maximum value. It reaches a maximum value at r by root 2. At r divided by root 2, it becomes maximum or basically minimum. But it's not actually minimum, maximum only, because magnitude wise it will be maximum. Direction wise it is opposite. So don't call it minimum, it is still maximum only. Yeah. So these important points you should know for a ring-like structure. Then the next structure which you should be aware of, is a shell that is also very commonly used. So if you have a shell, what you should do. By the way, here you should be aware that we can even find the electric potential. Electric potential is just given by kq divided by root of r square plus x square. Yeah, that's it. Kq divided by root of r square plus x square. That is the value of the potential, electric potential. Anyways, coming back over here. For a shell, if you are outside, it is very easy. Just take it as a point charge. So kq divided by r square. This is r. Even the potential becomes very, very easy. Treat it like a point charge. It is just kq divided by r. The only problem happens when you are inside of it. So you are somewhere here. Then the electric field inside is always zero, and the electric potential is the same as that of the surface of the shell. So it will just become kq divided by capital R. Remember, this is the radius of the shell. Radius of the shell. Very, very important. Okay. So these things you should know. If you ask me to draw the graph of it, electric field versus potential, electric field versus distance, and potential versus distance. So let's see how it looks like. This is field, this is potential. So for the field, inside, we just saw it is 0. Field inside is 0. Potential inside is constant. But once you go outside, what exactly happens? Once you go outside, electric field is inversely proportional to R square. So you will see it will go like this, 1 by R square proportional. And over here, it will go like this. It will be inversely proportional to R. Okay, keep this in mind. So this transition always happens at R. Okay, this transitions will happen at R. This is inside, this is outside. So you should know these basic things. Okay, next and the last one is, if you have a sphere which is solid, uniformly charged. In the previous example, the charges are only there on the surface. Even if it is conducting, doesn't matter, because the charges will only be there on the surface. Here, the charges are there literally everywhere. So uniformly charged. Uniformly charged. Okay. So this is nothing but uniformly charged. Okay. So what to do in such case? Again, let's go outside and inside. So if you are outside, it is very simple. It's the same thing as before. It is just KQ divided by R square. Even the electric potential outside, just like a point. So KQ divided by R. So when we draw the graphs, how does it look? This is field. This is potential. Let's take this point as R. So when you're outside, it is just inversely proportional to R square for field. So it is just going to go like this. Yeah, it's just going to go like this. Inversely proportional to 1 by R square. So inversely proportional to R square. And here, inversely proportional to R. So just like this. Inversely proportional to R. Okay. So all the transitions are happening after you go outside. When you are inside, how does it look? Okay. When you are basically inside, then what is the difference? Here is the difference. Here it is not 0. See, for a shell, where did it go? Yeah, for a shell, it was 0, and potential is also constant everywhere. But that is not the case for solid sphere, which is uniformly charged. The answer over here is K Q small r divided by R cube. So it is proportional to R. So it's actually a straight line. So it's proportional to R. Very, very interesting. And the electric potential inside is a very crazy formula. You have KQ and then 2 over here and then 3R square minus small r square, whole thing divided by 2R cube. So actually it becomes a parabola. It becomes basically a parabola because of the square term over here. So that is the formula for potential inside a solid uniformly charged sphere. Okay. Semiconductors and nucleus, yes, some topics are very, very important because they come every single time. In fact, it is one of those 31 topics we are going to do today. All right. Let's see some of the questions, guys. Here comes on your screen. Here it is. A metallic ring is uniformly charged. AC and BD are mutually perpendicular diameters. Electric field due to AB at O is E in magnitude. Okay. So, due to that AB wire, what will happen at point O, every point on that wire will apply some electric field. So, the net electric field will be like this, isn't it? Are you able to visualize it, guys? Because this point will apply electric field, this point will apply electric field, this point will apply electric field, even this point will apply electric field, this point will apply electric field. So all their fields combined, you will get a net electric field over here. Now the question says that we want to find due to A, B, C. So A, B and C together. So what will happen? Just because of AB, just because of that AB alone, just because of this particular AB alone, the electric field will be like this. Because of BC, the electric field will be like this. Check this out. E over here, E over here. So I'm talking about just this much part separate and then this much part separate. You will see each one of them will give E field because of symmetry. So what will happen to the net electric field? What will happen to the net electric field, because both of them are obviously perpendicular to each other? So the net electric field will be E square plus E square by Pythagoras theorem. So it will be root 2 times of E. So E root 2 or root 2 times of E, that is the right answer. Got it? So very simple question. Even if you don't know many formulas, you can get it by simple vectors. Next question which has come in JEE, it's on sheets. Two sheets are there. This has a density of sigma. This has -2 sigma. There is a point charge in between. Question is, what is the force on it? So to find the force, we'll need the field. After that, we'll do everything. Yeah. So think about it. What will be the field on that particular charge? What will be the field on that particular charge? Yeah. Due to plus sigma, due to this plus sigma, the field will be like this, and it will be sigma by 2 epsilon naught. Similarly, due to this minus 2 sigma, negative charge will also create a field in the same direction. It will be attractive in nature. It will be 2 sigma by 2 epsilon naught. So if you ask me what is the net field, well, it is in this direction, and it is sigma by 2 epsilon plus 2 sigma by 2 epsilon, which is 3 sigma by 2 epsilon. So the force on that charge will be whatever is that net field multiplied by the charge q in the same direction. So the field is 3 sigma by 2 epsilon. The charge which you have kept is a small charge q. So that is the answer. So 3 sigma q by 2 epsilon. 3 sigma q by 2 epsilon. Yes, option number 2. Option B is the right answer. Yeah, very good. Excellent. Garunla session will definitely go until 4 o'clock, 4:30 maybe also. Let's go to the next one coming up on your screen. Okay, this is not needed. Combination of resistors, standard questions come. In fact, they come as a combination questions also. You should know standard formulas. Resistors in series, resistors will add, voltages will add, current will be same. Resistors in parallel, reciprocals will add, currents will also add, but voltages will be same. Yeah, voltages will be same, but current will get distributed. So total current is I1 plus I2 plus I3 in parallel. In series, the same current will go, but V1 plus V2 plus V3, the total voltage will be the sum of the voltages. That's the basic thing. Usually the questions are in disguised form. Like this one. Where is it? This is the most commonly asked question. You open up most of the papers. This is very, 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 very common. You connect this with this and this with this. Remember, whenever you see this question, just jump and say, sir, I know the answer. These are nothing but 3 resistors in parallel. Always this question has come. Okay, so they are just in parallel. So 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. That's all. This is what you are going to do. Very straightforward. Okay. Another type of question which comes is they give you that you have taken a wire, you have cut it into some pieces and you have joined it and all of that. So what is the new resistance? Like a wire of, oops, so sorry guys. A wire of resistance, R is cut into n pieces and connected in parallel. Question is, what is the new equivalent resistance. What is the new equivalent resistance? So what do we do in such a case? See, I'll tell you, you have taken a wire and you have cut it into n pieces, right? So just imagine this is your wire and you have cut it into n number of pieces like this till here. So the original wire had a resistance of R. These wires, small ones, are like small resistors in series. So I'll call it small r like that. This is the nth piece. This is the first piece, second piece, and all of that like this. So they are in basically in series to make this as the equivalent. So R plus like that n number of times will give me the original resistance. So small r is capital R divided by n. Now what you have done is you have taken those small resistors and kept them in parallel like this. Okay. Now the question is, what is the equivalent resistance? So 1 by R equivalent is 1 by each of these resistors, 1 by R plus 1 by R like that, n number of times. So that will be n by small r. But what is small r? Small r is capital R by n. That means it will be n square by capital R. But that is 1 by R equivalent. So what will be R equivalent? It will be capital R divided by n square. So this is what the answer will be. This is also a very famous model. If you open up the papers, you will see this model. Yeah. So final answer will be R by n square. Got it? Very good. Next, let's go to the concept of Kirchhoff's law, where there are two laws, one on the basis of conservation of charge, second one on the basis of conservation of energy. So if you are at a node, junction or a node means where wires are meeting, multiple wires are meeting, some currents will be going inside, some currents will be exiting out. So if you add all the currents going in, it will be the same as addition of all the currents going out. Makes sense. So if 2 amperes is going in, 7 amperes is going in, 2 plus 7 is 9. So if this is 3, think about it, this current, so 3 plus, this should be also 6, so that 3 plus 6 is 9. Yeah, whatever total sum of the currents going in is the total sum of the currents going out. This is because charges are going to be conserved. Okay, very important. Second one is when you take a loop and go around that circuit. So you might have a circuit which is having multiple devices and you start from a point and you travel like this, like this, like this, like this, like this, like this, and you come back here, you will keep getting voltages across one device. Voltage 1, voltage 2, voltage 3, nth voltage. If you add them after you come back to the same point, you will see that their sum will be 0. You will see that their voltage sum will be 0. That is Kirchhoff's voltage law or a loop law, because you have to go around in a loop. As simple as that. Now, when you use KVL, you need to be careful about the sign conventions. See, you have one battery of EMF. Then let's say you have resistance through which, uh, current is going like this. Let's say you have a capacitor. This is positive, this is negative, and this is plus Q, this is minus Q. See, in all the scenarios over here, this is higher voltage because current is going from high to low. This is positive, negative. This is positive terminal, negative terminal. This is high potential. This is low potential in all these examples. So, when you are traveling in that circuit and you encounter a device, if you happen to travel from a lower side to the higher side, it is an increase in the potential. So the voltage will be plus in that case, like this value of V1, V2, V3 will be positive. Okay. Same thing over here. If I'm traveling through the resistor like this, it will be plus I into R. If I'm going like this, voltage across the capacitor will be plus Q by C. The exact opposite will happen if I go from positive to negative terminal. This will be minus E. In the direction of the current, always the voltage will drop for a resistor. And here also, it will be minus Q by C. This is the sign convention that you must follow for Kirchhoff's voltage law. Yeah, very, very important. I'm just revising. I have taught this in detail. In case you have missed those classes, just go over here. Yeah, you can go to any marathon or anything over here. Like for example, if you want, you can go to this roar series or even current series, which we just did over here. This one. You can go to this particular playlist. We have done detailed classes on this, as you can see. So you can go to combination of resistors, yeah, all these things over here, cells and over here also we have done it. So just do that. I'm pretty sure you will be able to find it. Okay, cool. Chalo. Let's go ahead. Let's go ahead with some examples so that you will understand it really. So question is, what is the reading in the voltmeter as shown in this particular diagram? Okay. Now voltmeter is an ideal voltmeter. So no current will flow through it. So ignore that current. All the current will have to flow through these batteries. And there is only one such loop which is going. So if I, let's say, start from here and go around once, I think I can find the current. So let's say I start from here, I get a battery of 5 volts, and then I get some internal resistance of 0.2 ohms. So there is a drop of current multiplied by resistance. Then next battery will come, 5 volts. That also has internal resistance. So I into R again. So I multiplied by 0.2. Like that, as many batteries are there, that many number of times I'll get these terms. And finally, I'll be back. So that will be 0. If you notice, doesn't matter how many times this is happening, this will just become n multiplied by 5 minus 0.2i is 0. So n can't be 0. So 5 minus 0.2i will be 0. Number does not matter. So 5 will be 0.2 into I. So I will be 5 by 0.2, which is 50 by 2. So current will be 25 amperes. Once I get that, I can figure out how much is the voltage here. That voltmeter reading will be whatever is the EMF minus IR. So 5 volts is there and I'm dropping it by 25 into resistance over here. So 5 minus, what is this? 25 is a 125. Yeah, 125 means 12.5. Oh, sorry, it is not 0.5, guys, it is 0.2. It's 0.2. So sorry. So this will be 5. 25 twos are 50. So it will become 5. So the answer will be 0 volts. It's very interesting. You will not get only any reading across any of the batteries. Doesn't matter whether you take this battery, this. All the batteries are anyways identical. The voltmeter reading will be 0 volts. Yeah. Very nice answer based on Kirchhoff's law at the end of the day. If you wonder what we have done here, from this point to this point, I've just gone like this. How much voltage drop will be there here? As I travel, I'll get a battery. So plus E, from negative to positive, I'm jumping to a higher voltage. And because there is internal resistance, so there will be a drop. So negative IR. So that's why E minus IR has come. Okay. Just using Kirchhoff's sign convention. Okay. Let's do another question. This was asked in JEE 2024, I believe, and see what is asked. Find the current in the resistance number 3. Such type of questions are very boring questions, but they give you marks and they are lengthy. Boring because they are lengthy, and they give you marks because they are lengthy, guys. They will be very systematic. Just follow the flow, you will get the answer. How do I find the current in this resistance? Okay, let's think. One option is you can use Kirchhoff's laws, but that will be very lengthy. Rather, find the equivalent resistance and find the total current. So, if you notice, this circuit, 2 ohms and 1 ohms together is 3 ohms. and these two resistances are in parallel, so that will become 2 ohms. Just check this out. These two together will make it 2 ohms. And if you don't like this, it's okay. I'll just keep them separate only 2 ohms. And this 1 ohm is separate over here. This battery is there. How much? 10 volts. So now we know what is the equivalent resistance. 2 plus 2 plus 1, which is 5 ohms. So what is the current in the total circuit? It is the voltage divided by resistance. That means 2 amperes. So a current of 2 amperes is going in that circuit. But the problem is when it enters. The problem is when it enters this branches over here. So let's imagine what will happen. Once it enters over here, 2 amperes will obviously get divided. Some current here and some current here. Now question is, how much is the current in R3? That means we have to find I2. We have to find I2. Yeah, you can use Kirchhoff's laws, but I will say one thing. The voltage is the same, guys. They are in parallel, right? So use that concept. Voltage is going to be the same. So why not write that voltage as I1 R2, I1 R2, yeah, IR is the voltage. Same, it is there over here also, I2 R3. Interesting. So we'll do one more thing. I1 by I2 will be R3 by R2. Let me use componendo. I1 plus I2 by I2 will be R3 plus R2 by R2. Why did I use componendo over here? I realized that if I add these currents, I1 and I2, I should get the original current by Kirchhoff's current law. So I1 plus I2 technically is nothing but just 2 amperes. I2 is there below as it is, which is what we want to find. R3 and R2, they are nothing but 4 and 4 respectively, and this is also 4. So this is 4 plus 4 is 8, 8 by 4 is again 2. So 2 divided by I2. So 1 by I2 is 1. So I2 is 1 ampere. So hence the answer will be 1 ampere. So indirectly we have used Kirchhoff's current law. We didn't use voltage law because not needed. Yeah, it is 1 amperes. Very nice. This is how questions can be solved when you get them. Okay, let's go to the next concept, ammeter and voltmeter. I'll tell you what, don't by heart these formulas, whatever I have put here. Okay, don't by heart them. Whenever these questions come, just solve them like a resistor problem. Just like series parallel resistors, if you solve them like that, you will get the answer. Number one. Number two, understand why they are connected in series, why you need that resistance. If you understand that, it makes solving or drawing the diagram easier. For example, ammeter. What is ammeter? It's a device to measure current. But what is the problem of measuring current directly? Now, usually you have a device called galvanometer. It is very sensitive. Very small currents also, zook, it will deflect. So if I want to measure 1-2 amperes of current, it will obviously burn. It's a very sensitive instrument for smaller currents. So if 2-3 amperes of current is coming, what I will do? I will bypass the current. It's like heavy traffic is coming, but a village can only handle very few cars. So you take a detour, you take a bypass. That bypass is called as a shunt resistance. So the shunt resistance is so small that most of the current will go through that bypass and very little current will go through the galvanometer, and that little current is enough to measure the actual current. So once you understand it, it becomes very easy. And okay, oops, you have your galvanometer coil resistance. You will have huge amount of current here which is coming in, okay, and that will be bypassed through the shunt before joining back over here, isn't it? And this will be current through the galvanometer. This will be your shunt resistance. and this shunt resistance will have a current of I minus Ig by Kirchhoff's current law. Now these are two resistors in parallel, so their voltages will be same. So you can find equivalent resistance, you can use any theory of parallel resistors and solve the question whatever is needed. Point is, they are just parallel resistors. Okay, most of the current will go here, very small current which can be allowed will go here, and this device will act like a ammeter. Ideal ammeter should have negligible resistance because this is also small, this is also small. Parallel resistance will be even smaller. So it's a very small resistance. Ideally, it should be 0 amperes. And this device is always connected in series with the circuit, meaning it should be put in that part or segment of the circuit where you actually want to measure the current. But voltmeter is slightly different. You take two probes and you measure the voltage across something. So it is always connected in parallel. So you might have some device somewhere and you want to measure the voltage across these 2 points. So you connect the voltmeter across it. Now you cannot just have that galvanometer as it is, because then all the current will flow through the galvanometer. So what you do is to stop the current from entering this branch as much as possible. You keep one more resistor. So you have galvanometer, you have one more resistor in series, so that very little current will flow here and most of the current will flow across this. And whatever voltage you get across the combination is the voltmeter reading. This is your device. The voltmeter is a combination of galvanometer and a series resistor which measures the total voltage across the device. Okay, so that's it. So if you understand it, it's enough to solve the question. Let's take examples so that you get it. One second, my board has hung. Sorry, yes, yeah. Let's do this question. Yeah. Look at it. A galvanometer has a coil of 200 ohms. Maximum deflection 20 microamperes. That's a small current which can flow through it. What shunt will you need to increase the range to 20 milliamperes? From micro, you have to go to milliamperes. So let's visualize it. My galvanometer is there of 200 ohms, I believe. Yeah. The maximum current it can allow is 20 microampere. So what we do now, we connect a shunt resistance, which we do not know how much it is. And we are able to now allow 20 milliamperes of current to enter in. If 20 milliamperes comes over here, how much current will go through the shunt? Think logically. It will be 20 minus 20 milliampere minus 20 microampere. This, why did we get it? Because current law. Current entering in is current exiting out. So out of this much went here. So how much went here? This minus this. But this is micro, guys. This is micro is very negligible. So we can approximately say it is still 20 milliamperes. Once I get that, here is what I will do. I will say the voltage is same because they are in parallel, isn't it? So voltage is same in parallel. So in parallel circuits. So what is the voltage across the galvanometer? What is the voltage across the shunt resistance? Let's write it down. Across the galvanometer, it is I into R. So 20 micro multiplied by resistance. Across the shunt, IR again, so 20 milliamperes multiplied by RS. Okay, micro means 10 to the power minus 6, and this is 200. Milli means 10 to the power minus 3. This is RS. Minus 3 will cancel. 20 will cancel. 10 to the power minus 3 into 200 will be RS. Therefore, RS will be 0.2 ohms. So 0.2 ohms is right over here. Where did I use any formula for ammeter? Tell me. I didn't use even one single formula. I've just used my basic principles. Ohm's law, V is IR. Resistors in parallel, voltages are same. That's it. And Kirchhoff's current law. So if you use the basics, it is very laddu. else you will get confused. Yeah, perfecto. Very good, Sabri, Srihari, Neo, amazing, Rama, Pavi. Yes, perfect. Let's go, guys. Let's go. Full Josh, full energy. Yeah, we are already how many hours into the marathon? I think we are 5 hours into the marathon. More than 5.5 hours, I think. Yeah, this is going to go for 6 hours. Wow, crazy. When I didn't expect it. So same thing for voltmeter. Imagine the galvanometer which is there. It has a maximum current of maybe 50 milliamperes, and resistance of that coil of that galvanometer. So I'm taking something. Let's say it is 100 ohms. How do you make a voltmeter whose range is, let's say, 20 volts? Okay, so what will you do for this? What will you do for this? Yeah, okay. Hi, JEE aspirant, welcome aboard. Yeah, thank you for the fires, guys. Thank you, Sabri. Thank you, Rama. I mean, I needed to see something very interesting in the chats. Looks colorful and motivating. Thank you so much, guys. Okay, so what do we do? Voltmeter, right? So we have the galvanometer. This is my galvanometer. I will connect a series resistance that will make my voltmeter, and this is the total voltage across it, and some small current will flow through it. Now, these values are already given to me. Rg is 100, Rs I don't know, this is 50 milliampere. This total voltage is 20 volts. All these values are given to me. I can see that these two are in series. So in series, R equivalent is R1 plus R2. Using Ohm's law, I can say that total voltage is current into R equivalent. In this case, total voltage is 20. Current is Ig basically, so which is 50 milliamperes, multiplied by R equivalent, all right, which is Rg, which is 100 plus Rs, which is 100 plus Rs. Okay, 0, 0 cancels. So 2 is equal to 5 milli is 10 to the power minus 3. 100 plus Rs. 5 goes here. So 2 by 5 into 10 to the power 3 is 100 plus Rs. Okay. 2 by 5 is 0.4. 0.4 into 1000 is 400. So 400 is equal to 100 plus Rs. So Rs is 400 minus 100. So Rs is 300 ohms. We got it. So this should be 300 ohms so that it is going to protect the galvanometer and bypass minimal current so that the device will still be flowing with good amount of current, and you will be able to measure voltages till 20 volts. That's all. Where did we use any formula? We didn't use anything. We just stuck to series and parallel. That's the beauty of it. So that's what I wanted you to see. These are very, very common. Next concept, which is very commonly asked, is a charge moving in a magnetic field in a circular path. Yes. So if you take a charge and you throw it in a magnetic field, the force acting on it is QV cross B, charge into velocity cross magnetic field, and the path taken by it is a circular path. It's uniform circular motion. Yes, uniform circular motion, assuming the magnetic field is perpendicular to the direction of the velocity. So the velocity will be like this. Charge is here, mass is here. The force will act perpendicular to it. This will act like the centripetal force to make it move in a circular path. Yeah, this is your magnetic field. So it will perform a uniform circular motion. Radius is mv by qb, time period is 2 pi m by qb, and speed is constant, velocity is changing direction. These are the basic things which you should definitely be aware of. Okay, for a charged particle thrown perpendicular to the magnetic field. If it is thrown at an angle, if it is thrown at an angle to the magnetic field, then it will not be circular. Rather, it will look something like this. If it is thrown at an angle to the magnetic field, it looks helical in nature. It is a circular motion which is moving forward. The circle itself is shifting forward. So this is called as a helical motion when the velocity is making some angle with the magnetic field. With the magnetic field. Yeah. The radius is still the same, mv by qb, but the velocity will be the perpendicular component. And reason is, when you look at it, the velocity is here, magnetic field is here. This velocity will have two components, one in parallel direction, one in perpendicular direction. This perpendicular velocity is exactly like this scenario, which will make it go in a circular path. So when you throw it like that, magnetic field is here, it is doing a circular motion here, and at the same time this component of the velocity will make that circle go in the front. So the radius depends on the perpendicular component, and the forward velocity depends on the parallel component to the magnetic field, which will never change because this velocity will always remain constant. Keep that in mind. So v cos theta will be constant. It's only this component which will perform circular motion, which will be v sine theta, will perform uniform circular motion. It will keep rotating, but the cos component will keep moving with a constant speed. Yeah. All right. Yeah. I hope this is clear. Now, everyone, let me know in the chat box. Like this, basically, it will be. The velocity was like that. There will be one component here. This component will make it go in a circular path like this. So it will go in a circular path like this. Visualize this in this particular plane. This will be your y. Let's say this is x. Technically, this will be minus z because z will be coming towards you. This will be z direction. And this particular component, which is parallel component, this will remain constant. This will not change. V cos theta will never change. V cos theta will never change. This will perform circular motion. So now you can think, how will the radius look like? How will the radius look like? It will be like this. And this radius will be mv sine theta by qb. Yeah, mv sine theta, because this is v sine theta component. That's how the circle's radius will look like. This circle will keep shifting forward. That is why it looks helical motion. Like this, it will keep moving forward. After one rotation, you will see this same circle would have shifted exactly one pitch unit. So after one complete rotation, so let's say you started over here or going like this and you come back over here. So you would have moved a distance called as a pitch. This is a pitch. This is exactly after one rotation, one complete rotation. Yeah, you have essentially gone like this. Yeah, in a helical path. That pitch is basically this velocity into the time of rotation, which is v cos theta into the time period of rotation. V cos theta into time of rotation. See if you are able to visualize this now. Rava? Yeah. So essentially, you should understand that this is something like this. So you started from here, you are going like this and coming over here. Okay, the plane is shifting. Yeah, the plane is basically shifting. You are going like this. So that is that helical path. Okay, everyone? Perfect. This direction, if you are asking, it is just cross product. Velocity was here, magnetic field is inside. So if you align the four fingers of your right hand like this, move it inside, the thumb will come up. So that is why force is here. And always the force will be perpendicular to the velocity. And this will only be able to change the direction, but never be able to change the speed of the particle. Okay. So let's do a good question directly, because simple question, though it will be direct substitution based. There is no fun in it. Let's do a good question. So I'll tell you what is there. There are two regions, B1 and B2 of magnetic field, and you are taking a charged particle of some mass and charge, and it is moves into region 2 with some velocity and then returns to the interface. It continues to move into region 1 and finally reaches the interface. What is the what is it? Displacement of the particle during the movement. Okay, I'll tell you what. This particular question, right? I don't have space. Okay, fine, no issues. Imagine there is a separation of magnetic field. Here the magnetic field B2 is stronger than B1. The magnetic field here is B1. You are taking a charged particle and throwing it in this direction like this with some speed V from the interface where the magnetic field is changing. This charged particle moves in B2 and after some time moves in B1. So once it again reaches the interface, what is the displacement? That is exactly the question which is asked. I have drawn a better diagram there. What is the displacement of the particle for this movement along the interface? I'll tell you what, without understanding how it moves, there is no point reading the question. So let's see. Once you throw it like this, it will go in a circular path. So maybe it will go like this, maybe. Okay, it will go in a circular path of some kind of radius. Once it reaches here, obviously the velocity will still be the same because speed can't change. So it has entered a new magnetic field. So it will go in a different circle, but that circle's radius will be slightly different because this is weaker. So radius might be big. Okay, radius might be big. Okay. Again, it has reached the interface. Again, it will do the same thing like this, but that's enough. That is the end of the question. They have asked how much is the displacement. They have asked how much is this particular displacement. Now tell me, isn't it easier to solve once you visualize what is exactly happening? From this part to this part, how much is the displacement? That's all. So if you observe carefully, this whole thing is the diameter of that big circle or semicircle, you can say. This will be 2 times of R1 because this is the diameter. That circle will have some radius. 2 times of R1 will be the diameter. And same thing we can say over here also. This much part is the diameter of this circle. It will have some radius. So it will be 2 times of R2. Agree or disagree? This is R2. And of course, somewhere here, maybe this is R1. See if you have understood it. So my value of S will be nothing but 2 times R1 minus 2 times of R2. This thing minus this thing is this thing, which is what is asked. So what is R2? It is mass into velocity by Q into B. Same thing over here. This is 2 times mass into velocity by Q into B1. Now it is straightforward. It is just simplifying it. So 2mv is common, divided by q is also common. 1 by b1 minus 1 by b2. That's your displacement. That's it. 2 times mv by qb. Okay. 2 times mv by qb, but they have taken b1 by b2 ratio. Okay, not an issue. We can do one thing. We can take b1 outside. So 2mv divided by q b1. So 1 minus b1 will go on the top and b2 will stay. That's it. So that is the answer. 2mv qb1, 2mv qb1, 2mv qb1, and this is fourth option. Yeah, there you go. Fourth option is the right answer. Yes, Rama, D is the answer. Perfect. Amazing. Very good. Very good. Very good. Very good. Very good. Excellent. Let's go. Let's go. Let's go. Let's go to the next one coming up on your screen. This one. An electron is moving along the positive x-axis. Uniform magnetic field is along negative z. Then where will the electron move? Electron is moving along the positive x. Positive x is the velocity, but do not forget it is a negative charge. It's an electron. Magnetic field is applied along negative z. Negative z means it is inside. This is the magnetic field. So if you just do V cross B, which direction will it be in? Velocity cross B, it will be upwards. It will be upwards. But do not forget, there is also the negative sign of the charge. So making it negative, so with a negative sign of the charge, velocity cross B, that will come downwards. That will come downwards. So that is also the direction of the force. That is also the direction of the force. So force will be downwards. And which direction is that? X-axis, y-axis, minus y. So force will be along. This will be minus y because that will be positive y-axis. So minus y-axis is the force, magnetic force. Electron will not experience any force. Electron will continue to move along positive x. Electron will move along a circular path. Circular path also because velocity is perpendicular to the magnetic field. So that is why it will go in a circular path. So B and E. B and E means option number 1 is the right answer. Yeah. Option number 1. Check this out. So such type of questions have also come statement based with multiple options are correct and complete theoretical. Right? Very good. Very good. Let's go to the next one, which is Biot-Savart's law. Just 1 second. Let's take 2 minutes break. 2 minutes break. Okay, so we are back. Welcome aboard. So sorry for that small interruption. 1 second, where is my pen? And here it is. Yeah. Okay. So Bio-Savart's law, guys. Yep. Let's have a look at it. Yeah. Ready, guys? Okay. Thank you so much, guys. Wow. Motivation is on the chats. Thank you. Right. Let's go. Bio-Savart's law. If you have a small current carrying element, the magnetic field due to that will be given by mu naught by 4 pi, whose value is whose value mu naught by 4 pi in SI system, whose value is 10 to the power minus 7. Current into the length of the element multiplied by the position vector where you are trying to find the field divided by the distance square. That is the contribution of the magnetic field due to a small length carrying some current. Okay, due to a small length carrying some current. Let's take an example which came in 2024. Look at this. There is a small element whose width is given as such and current is 10 amperes. And you have to find what is the magnetic field on the y-axis at 0.5 meters. And given that the element length is very small, 1 centimeters. Okay, let's use our formula. The magnetic field is given by mu naught by 4 pi current into the length of the element. So delta L or DL you can say, cross position vector divided by R square. Now I'll tell you what. Here my position vector is this. Yeah. This is my position vector. So R cap will also be in the same direction. Current is being carried where? Let's see, where is it given? Current is being carried, large current maybe in the I cap direction, maybe like this. So this is how my length vector will be. The angle between them obviously 90 degrees. So if you ask me what is the magnitude part, this value is 10 to the power minus 7. Current value, leave it for now. This is dl into r hat, means it is 1 only, into sine of 90, the whole thing divided by r square. A cross B is AB sine theta. A is dl, B is 1 because it's a unit vector, and this is sine 90 because angle between them is 90 degree. So this is going to be 10 raised to minus 7. Current is 10 amperes. Element length is 1 centimeter, meaning 10 raised to minus 2 meters. Sine 90 means 1. Distance is how much? 0.5 meters. Okay, just put it over here. 0.5 is 1 by 2, so 2 goes on the top. 10 raised to minus 7 and this is nothing but 10 raised to minus 1. So this will become 2 into 10 to the power minus 8, but Tesla. 2 into 10 to the power minus 8. Have you missed anything anywhere? Oh, sorry, that was not 0.5. It was 0.5 square, my bad. This was 0.5 and this was r square, right? Okay, so therefore, what will we get? 0.5 square means 1 by 2 whole square. So 2 square multiplied by 10 raised to minus 7. And this is 10 raised to minus 1. So this will become 4 into 10 to the power minus 8 Tesla. 4 into 10 to the power minus 8 Tesla is right over here. Okay. So that's how you can use directly your Bio-Savart's law. Okay. Very simple type of questions do come. Next is basically your Young's double slit experiment, where you have a light which falls on two narrow slits. That light, after it falls on those slits, it spreads in multiple directions, and these two slits acts like two new sources, which then cause interference on the screen or in the region ahead of it. So you have a source which emits waves or wavefronts in all the directions. Then you encounter a thing like this, an obstruction, and then you say that there are two openings over here. They are then called slit number 1 and slit number 2. These slits then produce interference of their own after generating new waves like this. Wave generated by this guy, and then new waves generated by this thing over here. And on the screen over here, you will get some places of constructive, meaning bright regions, some places of destructive, meaning dark regions. So this is your screen on which interference pattern is observed. Okay, interference pattern is observed. So couple of things over here. If this is the distance between the two sources, which is D, this is our screen. Wherever these rays meet, let's say this ray is meeting here from this source, this ray is meeting here from this source, there will be some associated path difference with them. They will not arrive at the same time. They will arrive with a path difference. That path difference is distance between the slits into sine theta, where theta is whatever angle is made by that particular point on the screen with the perpendicular bisector, over here. So that is basically your theta. Okay, whatever you see over here, this is your theta, the angular position of the point on the screen where the waves are going to meet. So there is a path difference. If this path difference happens to be n times of lambda, that means integral terms of lambda, 1 lambda, 2 lambda, 3 lambda, it will be constructive. So bright region will be obtained. This will look very bright. If it is odd times lambda by 2, n plus 1 by 2 is odd by 2 because it will become 2n plus 1. So 2n plus 1 by 2 into lambda, like 0.5 lambda, 2.5 lambda, 1.5 lambda, 3.5 lambda, you will get a dark region or less intensity light, which is also called as a dark fringe. Between every bright and the next bright fringe, if you measure the distance, that is called as the fringe width, which is lambda d by d, where that d, capital 1, is nothing but the distance between the slits and the screen. This is capital D, which is usually much larger than these slit distances. Okay, so these are the formulas which you should be aware of. Right? Let's see some questions based on this. Okay, here is the question. If the distance between the slits and the screen is made, or let's say, if okay, there are if there are, let's say, light of certain wavelength, some distance between slit and the screen, and this is also given to me, and there are 20 fringes in a length of 5 millimeters. Find how many fringes will be there if light of 4 lambda is used in the same part. So you have a Young's double slit experiment. Wavelength is lambda, distance is d. Between the slits, it is small d. And there are 20 fringes in a length of 5 millimeters. Now you use a new light. How many fringes will be there in that particular part? So Imagine this is our screen. Imagine this is our screen, and you are considering a small part of it. Let's say from here to here. And this much part is exactly what is 5 millimeters. There are fringes on it, meaning 1, 2, 3, 4, like that. How many fringes are there? 1 to 20 fringes are there. So can I say that 20 times the fringe width is nothing but that 5 millimeters? Is nothing but that 5 millimeters, everyone? Okay. If you change the wavelength, what will happen? The fringe width will get affected. Maybe now the fringe width has changed and now you have n number of fringes instead of 20 fringes. This will be a new fringe width. So I will call it beta prime and number of fringes is n. This is how my equation will look like. For the same length, n into beta will be constant. So I want to figure out what is that n. Well, I know what is beta prime. It is that new wavelength 4 lambda into capital D by small d. I also know what is the old fringe width. Beta will be just lambda d by d. Yeah, that is the formula for beta, right? I just told you over here. Where did it go? Yeah, beta is lambda times d by small d. So therefore, lambda d will cancel. So 20 is equal to, you will have 4 n. Therefore, n will be 5. 20 by 4, which is 5. So you will just have 5 fringes instead of 20 fringes out there. That's it. This is a very popular model of question. Yeah. Yes. It's there in the description box, Sabri. It should be there. Yeah. Polymath, no, this video will not help you right from the scratch. I mean, if you're thinking right from 0000 level, you know nothing about physics and you are watching this video, obviously it will not help. Why should I lie? And if there is some teacher who is telling in this universe, not even this world or India or this state or anything, in this universe who is telling that sit for 7 hours and I will teach you 31 topics right from 0 level to JEE PYQ level, I will stop teaching from that day. Okay? Right. Next question on your screen, here it is. Young's double slit experiment, it is immersed in some liquid, it has some separation, light is falling, fringe width is asked when distance is 0.72 meters. Lot of things are there. Let's understand one by one. The distance between the slits and the screen is this much. So this is capital D. This is capital D. The slit separation is this much. So this is small d. Next, refractive index is given, wavelength is also given. So why is the refractive index given with the wavelength? Because it is immersed in a medium. So the new wavelength will be the old wavelength divided by mu. That is the catch. So when you try to find the fringe width, this lambda should be the new wavelength, capital D by small d. Is that understood, everyone? That is the many people will forget that there was a mu over there. Cool. Shall we go ahead, everyone? Yes. Awesome. Awesome. So what do we get? New wavelength is lambda by mu. Lambda. What is it? 690 nanometers. So 690 nano means minus 9, whole thing divided by refractive index, which is 1.44. Okay. Now the rest of the things, which is into capital D, which is 0.72, whole thing divided by small d, which is 1.5 milli, which is 10 to the power minus 3. Okay, just do the math and you will get the answer. Okay, try to do this as homework. I don't have that patience now because I'm standing here for almost 6 hours teaching continuously with my vocal cords using my brain, multiple organs getting damaged now. Yeah, so please do this as homework. Right? But you understood the concept behind it. Wavelength will change because once you change the medium, frequency remains same, speed will change and wavelength will change. That's one. That's the only difference. Okay, cool. Let's go. Next, we are on to electromagnetic waves. Guys, we are reaching slowly towards the end. Not many slides are there. Maybe 30 slides, 20 slides more, and we are done. Yeah, 30 slides most likely, and we are done. Ready, guys? Ready for the next concept? Electromagnetic waves. Let's have a look. Electromagnetic waves. So, light is an electromagnetic wave means when light moves, the wave nature of it has electric field and magnetic fields which are oscillating in nature in perpendicular direction, something like this. So you have the electric field and simultaneously you have the magnetic field. You have the magnetic field like this. Yeah. So light will be moving like this, maybe in this direction. This is the speed of light direction. And you will see that the electric field will be oscillating in one plane like this over here, and the magnetic field will be oscillating in a plane which is perpendicular to it, in a plane which is perpendicular to it. Yes. That is how that electromagnetic wave will go. So if you ask me what is the wave equation of electric field, I will say it is E is equal to maximum electric field, whatever it is, into sine or cos, anything you can use. Kx you can put first or minus you can put depending on the direction. Same way, magnetic field will have maximum magnetic field, sine or cos anything, kx or omega t, plus minus like this. Here, you should know the standard thing. C is nothing but frequency into wavelength, which is also omega by k, where omega is angular frequency, so 2 pi f, and k is nothing but angular wave number, which is 2 pi by lambda. Standard things. Next, if you ask me what is the wave speed, this will be either one of these terms. One is you either put E over here or you put E max over here and divide it with B or B max, one and the same thing. This is also 1 by root of permeability and permittivity. This is permeability of magnetic medium, permittivity of electric medium. That's it. So all these ratios give me the speed of light. Very, very important, all these equations. Lastly, if you take electric field, cross it with magnetic field, electric field, and cross product it with magnetic field, E cross B, then the direction will always be the direction of speed of light. So all these three are mutually perpendicular to each other. So speed of light is always parallel to the electric field cross producted with magnetic field, wherever it is. Okay. Here it has not come out like that, has it? No, it is exactly opposite. So ideally I should not keep this diagram like this. The right diagram will be the light is going this way. Here also you can see electric field is up, magnetic field is this side, E cross B will go like this. Electric field, the yellow one, green one, the magnetic field. So E cross B is going, making my thumb go this way. So light is going this direction. So this is also very, very important. Yeah. Now, Red Eye, I have seen the latest update and I have made a video also on it. Okay. Apart from this, I don't think much is there in electromagnetic waves formula wise. Other theory, small things here and there are there, not an issue. So say for example, they say that electric field is given by 20 into 10 to the power 7. Okay, cos, let's say 50 pi into 10 to the power 5 x minus omega t. Okay, question is find omega, magnetic field, and direction of light. And the direction of light. All the three things. Very interesting question. Let's see how do we figure it out. As you can see in this equation, this one is k, omega is not known, but we know that omega divided by k is the speed of light. So omega will be ck, c is speed of light, standard, which is 3 multiplied by 10 to the power 8, and this particular thing over here is nothing but k. So I should put, sorry, this was minus 5, my bad. So sorry. This was nothing but 50 pi into 10 to the power minus 5 over here. So this will make it how much? 53 is a 150. Pi is also there. Minus 5 and 3, 8 will make it plus 3. So this will become 15 pi into 10 to the power 4 radians per second. That is your omega value. 15 pi into 10 to the power 4. First part done, omega is done. Next thing, this particular equation is in x. So the wave must be going either in positive or negative direction of x. If this was y, it will go in y direction. If it was z, wave should be going in the z direction. Next thing, if this is minus, then it is sure that the wave should be going in the positive direction of the x. So the light wave is moving positive x direction. So the motion of light is in the positive x direction. If this was plus, it will be in the negative x direction. Understood? That's how it works. Wave motion. Lastly, we have to find the magnetic field. So for that, magnetic field maximum value and electric field maximum value will give me speed of light. Yeah. So how much will B max equal to? It will be E max divided by C. It will be E max divided by C. E max is 20 into 10 to the power 7. Speed of light is 3 into 10 to the power 8. So this is 10 to the power 8 only. So 2 divided by 3 Tesla. That is B max. So we can find magnetic field now, which is B max. Same equation should be there. Cos should be there. Kx should be there. Minus should be there. Omega t should be there. So B will be nothing but 2 by 3 cos k is nothing but 50 pi into 10 to the power minus 5x minus omega. Omega is 15 pi into 10 to the power 4 and t. That's it. That is the answer. So we can find literally every single thing. Yeah, literally every single thing. Okay, goal. One last question over here on this. If speed of light is in the direction of, or speed of light is in the direction of negative y, electric field is in positive z, then which direction is the magnetic field for a electromagnetic wave? Let's see if we can figure this out. Which direction is the magnetic field at that moment in that electromagnetic wave? Okay, we just saw E cross B should always be parallel to C. Speed of light, negative y means minus j cap, should be parallel to magnetic field. I do not know. Electric field plus z means k cap. So k cap cross which one will give you negative j? For sure, it should be I cap, but whether it is plus or minus, that I don't know. Okay. because k into I only will give me j. Now try to think kij. So if you are not recollecting vectors, let me draw it for you. I, j and k. I cross j is k, j cross k is I. Like this is positive, like this it is negative, if you remember. So I want a negative j. So if I want negative j, I have to go anti-clockwise. I cross k is negative j. So k cross I will be positive j. If k cross I is positive j, the only way this can be possible is this is negative I cap. So k into I, look at it, k into I is positive j. So k into negative I will be negative j. So therefore magnetic field is in which direction? Negative x. Magnetic field is in the negative x direction. That's it. There you go. Very simple. Okay. So I have kept a homework question for you. Try this out. Try this particular question out, my dear warriors. It's very simple. I'm pretty sure you will be able to do it. Yeah, it's exactly similar. Magnetic field direction, this direction is given, find out the other one. All right, let's go to lens formulas, combination of lenses. We are on to ray optics now. Wave optics is done, electromagnetic waves is done, electromagnetism is done. Yeah, few more concepts on modern physics and yeah, optics here and there, and we are done. Yeah, most of the theory is are done, guys. We are almost nearing the end. Most likely this lecture will go for 7 hours. It will be a record, but it will be a one full-fledged session which will have all the important concepts, formulas and their related questions which have come. Let's see. Lens formula. If you have a lens of focal length f, if it's a convex it will be positive, if it is a concave it will be negative focal length. Formula is 1 by v minus 1 by u. V is image distance, u is object distance, following the sign convention. Always look at how the rays are coming from the object to decide who is positive, who is negative. If the rays are going this side, that side will be positive, and from wherever they are coming, that side will be negative. That's how it works, sign convention. Okay. Magnification wise, image might get elongated or compressed. It is height of the image upon height of the object, which is v by u. And if at all this magnification is negative, it means it is inverted. And if this magnification is positive, it means it is erect. It is as it is. Also keep in mind, if this magnification value is more than 1, it is enlarged like +2, +7, like that. If the magnification is less than 1, it is diminished like 0.7, point minus 2, negative 0.2, all these things. The mod value is less than 1. And if it is exactly equal to 1, it just happens to be of the same size, like +1 and -1. Okay, keep these things in mind. There is also one more kind of magnification which might be needed at times. So that is longitudinal magnification, which is length of the image upon length of the object. This is along the principal axis. Along principal axis, meaning one object might be there, one image might be there. So these lengths along the principal axis, that is v square by u square, which is also image velocity. How fast is the image moving upon how fast is the object moving, object velocity. This is also a very important equation. At times, very rarely you might need it. Okay, so maybe we can do some questions on this, but before that, lens combination also we'll do. The power of a lens is 1 by f, but if multiple lenses are there, in contact, then their powers will get added, P1 plus P2. So the effective focal length will also be 1 by f1 plus 1 by f2, like that. But there is also one small tricky formula which you can use at times. What if they are not in contact and they are separated by some distance d? And let's say I'm interested in what that focal length will be of that particular combination. 1 by F effective is 1 by F1 minus 1 by F, sorry, plus 1 by F2 minus D divided by F1, F2. So this also you can use, as a formula if the rays are parallel and the lengths are separated by some distance to find the effective focal length. 1 by F1 plus 1 by F2, normally it would be, but because there is separation, minus D by F1 by F2. That's a formula. Don't worry about the derivation. Yeah. Okay. Shall we do some questions coming up on your screen then? Yeah. Let's go. Say for example, what is it? A lens. Which lens? Concave lens or convex lens we need to mention. So let's say a concave lens of mu is equal to 1.5, R1 magnitude equals R2 magnitude equals 40 centimeter, produces magnification, produces an image, I will say, of half size of object and it's erect. Question is, find distance between image and object. Find the distance between the image and the object. Very nice question. A lot of things are involved. First thing which we'll have to figure out is actually the focal length. Without that, we cannot do anything. And for that, use lens maker formula, which looks like this. Mu minus 1, 1 by R1, 1 by R2. Subtract. Mu is 1.5. Concave means this will be negative 40. This will be positive 40. So this will become 0.5 and we'll have 2 times 1 by 40. We'll have 2 times 1 by 40. 2 into 0.5 is 1. So this will be minus 1 by 40. So the focal length will technically be negative 40 centimeters. Once we are done with this, we'll draw that lens like this maybe. Our object will be here. Image is probably here. Object, image. And it is given the magnification is half and it is erect. That means it's obvious the magnification is 1 by 2. 1 by 2. So let's assume that this distance is x and I do not know how much is this. Okay, I do not know how much is that. So if I start writing this distance as x and let's say this is y, magnification, like we know, is nothing but v divided by u. So v by u is 1 by 2. What is image distance? It is y. What is object distance? It is x. But sign convention will make this side negative, this side as positive. So this is 1 by 2. So from this, we will get x is equal to minus 2y. Okay, we will keep it as it is on the sidelines. We will not do anything with it. Now, if I use lens formula, which is 1 by v minus 1 by u is 1 by f. Image distance is y. Object distance is negative x. Focal length is minus 40. So instead of x, we can put 2y also. So 1 by y minus minus is plus. X value is negative 2y is 1 by minus 40. 1 minus half is half. So it will be 1 by 2y is 1 by minus 40. So 2y is minus 40. So y will be minus 20. Y will be minus 20. Which means the value of x, which we just got over here, what is the value of x going to be? Minus of 2 multiplied by minus 20, which means it will be 40 centimeters. Oh, so x is 40 centimeters, y is minus 20. So what you should interpret this as is you have that lens. The object distance is 40 centimeters. So x is positive, meaning you have assumed it correctly. So the object is actually 40 centimeters away. But the image you have assumed it to be on this side, that is wrong. Actually, the image happens to be over on the left hand side only at 20 centimeters. So the image is just 20 centimeters over here. So the distance between the object and the image is not 40, not 20, it is 40 minus 20, which is 20 centimeters. I've seen many students put the image this side, so they add 20 and 40 and they give the answer as 60 centimeters, which is obviously wrong. Okay, so this is very nice question because the image just came out to be on this same side. Yeah, so answer is that. Let's go to the next question on your screen. Two lenses placed 10 centimeters apart. What is the power of the combination? It's just like two lenses are there, separated by some distance. They will have some effective focal length, and that effective focal length is 1 by f1 plus 1 by f2 minus the d times f1 f2. From that we can find the power. The power is 1 by f. So therefore it is 1 by first focal length, which is 30, next focal length, which is 10, minus distance between them is 10, and f1 f2, that means 30 into 10. So this will become 1 by 30 plus 1 by 10, 10 10 cancels, minus 1 by 30, 30 30 cancels, so 1 by 10, which is 0.1 diopters. Oh no, wait a minute, this is 10 centimeters, 10 centimeters. So if I convert it into meters, it is 0.1 meters. So this will be plus 10 diopters. So 10 diopters means it is fourth option. Is that okay? So this formula you have to use minus d by f1 f2. Only then you will get it. Okay, right? Amazing, amazing, guys. Let's go. Next question. Next concept, Faraday's law. Wow, we are on to Faraday's law. And after Faraday's law, oh, we are coming to nucleus, guys. We are nearing the end. Barely any slides are there. Oh, nice. Let's go, let's go, let's go. Barely some few slides are there here and there. Wow, kudos to all of you. Let me just drink some water and come. Just go through this slide. I'll just come. Let's go. Faraday's law talks about how electricity is created when you change the flux through a coil. And that flux I'm talking about is magnetic flux, not electric. Magnetic flux, just like electric flux, is magnetic field which passes through an area into angle between the area vector, which is perpendicular to the plane, and the magnetic field piercing through it. B A cos theta, unit is Weber. So if more flux passes, less flux passes, flux changes. So that rate of change of flux is the induced electric EMF in that coil, in that circuit. If it has n number of turns, you will just multiply it n times, because each coil or each turn will produce same flux. So you will multiply it n times, because total EMF will be n times then. All right, great. Now the direction, this minus sign is just relevant in direction. Otherwise, magnitude wise, just ignore it. It is dependent on, it is just dependent on, yeah, the energy conservation law, which is used in Lenz's law. So basically, what happens is, if the flux is increasing, the EMF will be such that it will create its own magnetic field to oppose that change. And if the flux is decreasing, it will create its own magnetic field to support that change. What do I mean by that? Let me give you example. Imagine we have a coil like this and like this. Imagine in this particular coil, the magnetic field is inside and it is increasing. Same thing over here, but let's say it is decreasing. So what direction will that EMF be produced? Because it is increasing, the induced EMF will be such that it will oppose that change. So it will produce a magnetic field in this direction. This is B induced. Here it is decreasing, so it will help it in the same direction. So induced magnetic field will be in the same direction. So how will the current be produced? Take your thumb and put it in the direction of that pink vector, which is induced field. So your fingers will curl like this. So the induced current will be in this direction. In this case, your thumb is coming outwards. The fingers are curling like this. So this is the direction of the induced field. That's it. Similar logic we can also use for magnets. Imagine there is a magnet over here, or let's say there is a magnet over here, and let's say this is North Pole, this is South Pole, this is North Pole, this is South Pole. This magnet is coming like this magnet is going like this. When this magnet comes close, it will not like it. This coil will not allow, not allow, it will resist it rather. So what it will do, it will create its own polarity. So it will try to repel it by creating a North Pole on this side and South Pole here. Whereas when the magnet goes away, it will not like it. So it will try to pull it back by creating its own South Pole here and North Pole here. Once this happens, you can easily figure out how the current should move. So magnetic dipole moment is always from south to north. So place your thumb from south to north. The fingers will curl like this. So the induced current will be in this direction. So current will be created like this. In this case, place your thumb from south to north towards the left. The fingers will curl like this. So the current direction will be in this way. So this is how Lenz's law can be used to figure out which direction is the current. Always oppose the change. Always oppose the change. Yeah. Great. So let's do some questions. You will get an idea of it perfectly. What do we have? The magnetic flux through a coil is given by phi is equal to phi t cube plus 4t plus 2t minus 5 Weber. If the resistance is 5 ohm, then the current at 2 seconds will be. To find the current, we need voltage. To find voltage, we need Faraday. So Faraday says that the EMF is d phi by dt. So take the derivative of this big thing, 5t cube plus 4t plus 2t minus 5. So what will this be? 5 t cube means 3t square plus 4, t's derivative is 1 plus 2. Did I miss something or what? Why is it 4t plus 2t? I think it should be square, because why will they give 4t and 2t together? No, I think it should be square. Okay, I think this was square. So most likely this is what it should be. It doesn't make sense otherwise. Okay, so if I assume it as square, then what do we get? 4 into 2t plus 2, derivative of t is 1, minus Constant's derivative is 0. So this will be 15t square plus 8t plus 2, that is EMF. But we want it at 2 seconds. So this will be 15 multiplied by 2 seconds, right? 2 square plus 8 multiplied by 2 plus 2. So 15 into 4 is 60. 8 2s are 16 plus 2. 60 plus 16 is 76. 76 plus 2 is 78 volts. But that is not what is asked. Asked is current. Current is EMF by resistance. So 78 divided by resistance, which is basically 5. Is that right, everyone? So how much will it be? 15 5s are 75. So 15 point, 0.3 means 0.6. Yes. So 15.6, which is option number A. That is correct. Yeah. No, not C option. A option 15.6, not 16.6. 15 5s are 75. Yeah. So 78 is slightly more than 75. So that's how it is. Yeah. Very good. Excellent. Let's go to the next question on your screen. A coil is placed in a magnetic field as shown below. Induced current, the direction is already given. So where do you think the magnetic field should be there in the region? If the current is already given, induced like this, so the induced field, curl your fingers like this, it is coming towards you. So the induced field is towards you. So one of these two can happen. Either there is a magnetic field towards you, which is decreasing. This is one possibility. Or there is a magnetic field inside and it is increasing. In both the cases, the induced field will be towards you, because if it is towards you, meaning it is helping something who is becoming smaller, or it is opposing something which is becoming stronger. So either it is this option or it is this option. Now check it out. Outward and decreasing, possible. Parallel to the plane, not possible. Outward and increasing, not possible. Parallel, not possible. So this not possible. Only this is possible, which is this option. Perfect. Why can't it be parallel? Because if it is parallel, then there will be no flux in the coil. Just think, no, logically. If this is a coil and if the magnetic field is passing parallel, then the flux will be 0. So there is no point only. There will be no EMF, no current only, because flux will only come when it pierces the coil. It can't be parallel to the coil. Okay. In this case, it is perpendicular to the area vector, if you notice. Yeah. Right. Next one. Let's go to the nucleus part. Great, guys. Come on. Nucleus, modern physics, photoelectric effect, semiconductor, logic gates. Last few things. Sir, I have 2000 to 2025 PYQs. Very good. Please solve them then. Sir, how chapter would you cover? Sir, is whole syllabus? No, not chapters. We are just doing specific topics, man. Yeah. You're just doing specific topics. Nucleus is that small, dense part of the atom, which is relatively empty. So it's that small, dense part which has that positive charge, and those positive charges repel each other. Those are protons, but they are held together. It's like people are fighting with each other. So, I have given this example when I have taught it also. Like two Pandus are fighting with each other. So they both love the same champa, and because of that champa, they stay together. So two protons are fighting. That N is that champa, neutron, who binds those protons together and makes that nucleus stable, or else that protons would have long time back only gone away from each other because of electric repulsion. So that strong bonding which is there between proton neutron, that is Pandu Champa over there in the nucleus, is called the nuclear force. Now the mass of the proton and neutrons are roughly the same, but slightly the mass is more for a neutron. And totally, if you count the number of protons inside a nucleus and the neutrons, that gives me the mass number of that atom. What does it give me? It gives me the mass number of that particular atom. Yes, perfect. So number of neutrons plus number of protons, N is neutrons, Z is protons, is the atomic mass number. Together they are called nucleons. Like if I say I stay in Bangalore, I am a Bangalorean. If I stay, I'm a resident in Delhi, I'm a Delhiite. So if I say that I am staying in nucleus, I'll be called a nucleon. Got it? Okay. Next thing, the radius of a nucleus roughly is given by a constant which is 1.2 10 to the power minus 15. This is femtometer. Atomic mass number, whole thing raised to 1 by 3. Atomic mass number, whole thing raised to 1 by 3. If you can see, femtometer is very, very small. Size of an atom is in angstrom. So it shows that nucleus is really small and dense. That also brings me to the point, the density of the nucleus, if you try to find it out, it is constant for all the materials. It is constant for all the materials, all the elements. Okay, these are some basic things which you should know. Let's do some question coming up on your screen. Yeah, for a nucleus of mass A, radius R, the mass density of the nucleus can be represented as, come on, this though, everybody spam the answer. I'll wait for 1 minute. Everybody spam the answer right now in the chat box. Harish, I'm pretty sure if you practice so many PYQs, 2002 to 2025 is a huge, huge number, man. If you do that much also, no, I'm telling you 150 on your own and do it multiple times, 100% you will get 150 marks. Guys, density is constant. It does not depend on A. So actually it is independent of A. It's constant into A raised to 0. So A does not matter. Whatever is A, any number raised to 0 is 1. So really doesn't matter. Independent. Very good. It is not B. Yes, Rakesh. Very good, Ajay. Perfect, Suchitra. Very good. Amazing. Amazing. Yes, no problem, Sabri. Happens. Okay. Let's go. Next one. Statement-based assertion reason question. The density of copper is greater than that of carbon. Is that? I don't think so. Densities are same. This is definitely a wrong word, greater. It should be actually same word should have been used. Nucleus of mass number A has a radius proportional to A raised to 1 by 3. This is correct. R is proportional to A raised to 1 by 3. This is fine. Reasoning is correct. Assertion is wrong. Yes, assertion is wrong. A is not correct, but R is correct. So that means option number 2 is the right answer. Option number 2 is the right answer. Very good. Excellent. Let's go. Next one. Photoelectric effect. Let's have a look. What is it asked? Photoelectric effect, guys. When light falls on a metal surface, light's photons carry energy. This energy is like, imagine I have laddus. I am going to somebody's house. My friend is there. So I will convince, like that Pandu will convince that parents, please, auntie, uncle, I want to go out with my friend. We are planning something. We are going for cycling. We are playing cricket, something. We are playing video games, whatever. So I had 100 laddus with me. I'll be like, auntie, I got 2 laddus for you. Auntie like, what? You got 2 laddus for me. For 2 laddus, you think I will send my kid with you? You waste fellow. Okay, auntie, I have got 10 laddus. Oh, 10 laddus you got? Okay. Go, play, enjoy, and come back soon. So the auntie will send her kid. That means the friends will go out together. Same way that light has some energy. It will convince the atom, the metal plate, that please, boss, send that electron out. That is his friend. So for the electron to be ejected, it has to give some commission, some maska he has to, some buttering he has to do. So it will waste some energy there. And that remaining energy will be there with the electron which is ejected. Because remember, you gave 10 laddus to auntie, you had 100 laddus. So the remaining 90 laddus, your friend will eat off. Yeah, that is the electron which is ejected out. Got it? So same logic is used here, my dear warriors. And if you ask me, this is at the end of the day energy equation only, nothing else. So Einstein won a Nobel Prize for which equation? For writing this simple energy equation. Energy of the photon incident is that commission to the auntie 10 laddus, which is called work function, plus kinetic energy of the electron. So energy of the photon is hf, or you can use hc by lambda. Work function you can use hf naught or hc by lambda naught. What is f naught or lambda naught? They are the minimum or maximum wavelength or frequency for which you will get photoelectric effect. Remember, auntie will not be agreeing for 2 laddus or 5 laddus. She needs 10 laddus. So minimum energy needed to chuck out that electron, to eject that electron, is the work function. So minimum frequency will be needed, after which photoelectric effect will occur. Yes? Yeah. Huh. Or heat and thermo. Yes, in fact, if you notice, I've just done heat and thermodynamics, those most repeated topics. Just now I did it. If you see before the break, now I have done it. Okay, VK gamer. Yeah. Oh, you are an Iranian living in India and you are watching English lectures to help me a lot. I'm so glad. Thank you, man, so much. And great. Love to see all the international crowd. We do have African crowd and many kids from Africa. I'm not even kidding. Message me. Nepal, though, yes. Sri Lanka also, we have a lot of kids. UAE, of course, a lot of Indian expats and people. And this is the first time for me, Iranian student. I'm so glad. Kinetic energy of the electron is half mv square. This electron which comes out, imagine you convinced the auntie 10 laddus, please send my friend. The friend came out. Happily, he is having 90 laddus with him. Then one don comes, one bully comes. Hey, you, where are you going? Come here. And if the electron is very energetic, it will bypass that bully. That friend of yours will bypass the bully and that friend will be able to come with you for the party, gaming, whatever you have planned. But if the bully is very strong, bully will be like, hey, do one thing, give me all 90 laddus. Give me 100 laddus. You will be like, Ayo, where do I give 100 laddus, bro? I have only 90 laddus. Here, take this 90 laddus and take my slipper also on the face, and you will come back to the home. You will come, your friend will come back crying. One bully came on the way. He asked for 100 laddus. I had only 90 laddus. I wanted to go for party. One big story you will get. So that is basically for an electron, somebody to bully that electron. That means to stop that electron. So that is also given by E into stopping potential. This is either this or this. Any one of this you can use. Okay. So you can now make a combination of multiple equations. This is equal to this plus this. This is equal to this plus this. This is equal to this plus this. Any combination is a photoelectric equation at the end of the day. Yeah, isn't right? Okay. So having said that, we can also draw the graphs which are very, very important. We have the current versus, what is this? Frequency. No, current versus voltage, my bad. Current versus voltage graph. And you will see for no voltage given to that metallic plate, there will be a very small decent current. And when you apply some more voltage, you will see current will increase, but it will saturate because how many electrons can you give? You can't give beyond a point because if 20 photons were falling on the metal, 20 electrons will come out. Those electrons will make up that current. So you cannot increase the current beyond a limit. But if you give reverse voltage, it will stop. And this is nothing but your stopping voltage. Negative because you are stopping it. That's all. But you can also increase the intensity of the light and you will see more current over here. This is for more intense light. More intense light. What you will have? More intense light means more photons are there. So more photons means more electrons will be ejected. So more current will come out. But their stopping voltage will be the same. This is very, very important. And by the way, intensity is directly proportional to the current. Intensity is directly proportional to current, or current is proportional to intensity, whatever way you want to see. Last thing over here is this very important graph where you have frequency, yes, frequency, and I think voltage over here. Yeah, frequency versus voltage over here. And this comes, I'll tell you how. Use this equation. Okay, use this equation. See this. We have HF is equal to HF naught plus E times of Vs. HF plus HF naught is EVS. Rearrange this. EVS is HF minus HF naught. So Vs is H by E times of F minus H F naught divided by E. Okay. This is y-axis, this is x-axis. So we have Vs on the y-axis. This is the y-axis. This is my x-axis on the frequency. Naturally, this thing will become M and this whole thing will become C. Y is mx plus C. So the graph of this will obviously be a straight line. But yeah, you cannot have voltages, stopping voltage as negative. So I'll just extend it for mathematical reasons only, not otherwise. You cannot really have negative stopping voltage. Okay. So stopping voltage itself is negative. Okay. So, or I would say it is already in the reverse direction. That is a better way of putting it. So this is how the graph will look like. The slope will be h by e, and this intercept C will be minus hf naught divided by e, which is nothing but minus work function by e. Hf naught is work function, so minus work function by e. If you take any other metal doesn't matter. The answer will be that the slope will be same. Yes, the value of f naught will change. The threshold frequency will change. This is the threshold frequency. You will get different thresholds, but slopes will be same. And the intercepts will be also different, of course. Okay, great. Awesome. Jeffin, Krishna, I literally only study physics because of you. Thank you so much for the content. I'm so glad. Thank you so much. Thank you so much, guys. Sasi Kumar, just pray that the registration starts after your vacation, because at least then your vacation will be peaceful. Already one party spoiler happened because NTA just released, hey bro, I'm going to tell you the exam date, and I'm not going to give you a time for the second attempt. They already messed up with the exam dates and releasing that. Now you better have that registration after some time. That is after the vacation, after 4 or 5 days at least. Okay, let us see some questions. But before that, one last thing, guys. See, when you use this equation for energy, which is hf or hc by lambda, H value we know 6.6 into 10 to the power minus 34. C is 3 into 10 to the power 8. There is also this electron volt unit. 1 electron volt is 1.6. E value is 1.6, 10 to the power minus 19 joule and all of that. Another simpler way of writing this is you put 1240 and put lambda, but this lambda is in nanometers. The answer that you get for energy is in electron volt, or you use 124, one more zero. This lambda is in Armstrong. Answer will still be in electron volt. So this formula is much better and useful for simplifying calculations. Well, means you don't have to substitute H, C. It's already done for you. Okay, I've done that derivation long time back. So if you do this, it becomes much easier. Much easier. Let's do some questions coming up on your screen. Here it is. In a photoelectric effect, EM wave is incident on a metallic surface and electrons are ejected. If the work function is this much and stopping potential is this much, what is the wavelength of the EM wave? Okay, let's do this. Neo, Tiger, what do you mean by I'm back? I'm always here. Where had you gone? First, you tell me that. You are to sitting. No, I am standing and I am teaching and I'm using my voice. You just have to watch, read. That also you should not go out now. Yeah, standard result. Let's go. Good to go, Savri. All right. Thank you, Ajay. Thank you, Rama. Let's go, let's go, let's go, guys. What do we do? What is given? What is asked? We have been asked what is the wavelength of the light which is falling on it. So wavelength of that light will give me some energy, will be work function, okay, plus E into Vs standard. Work function is 2.14 E. This is just E. Stopping voltage is how much? 2. So this will become, isn't it? 4.14 electron volt, and energy of light is given by 1240. You have to give it in nanometers, okay, electron volt divided by lambda. E cancels, so how much will be lambda? 1240 by 4.14. How much will it be? Approximately 12 by 4 is 3, so around 300, I think. So 300 nanometer will be the answer. Yeah, perfecto. That's it. Option D, yes, Sabri. Yeah, perfect. Okay, cool. Very good. Let's go. Next question coming up on your screen, and here it is. What does it say? The work function of a metal is 3 electron volt. Which color in the visible spectrum is required for emitting the electron? So if work function is given, which is 3 electron volt, out of them, who will cause color to be emitted? Work function is h c by lambda naught, but I don't like this formula, so I will put 1240 electron volt. Lambda naught is in nanometer now, is 3 electron volt. E will cancel, so lambda naught will become 1240 divided by 3. Yeah, so this will become 4. Approximately, this will become close enough to 400 nanometer. Now, 400 nanometer means who, guys? Yeah, 400 nanometers means who? Yes, which color is it we are talking about? Remember, visible spectrum, that white color spectrum is made up of multiple colors. This is violet. In between, you have yellow, and over here you have red. Red is around 700 nanometers. Violet is around 400 nanometers. So we are talking about almost some bluish color over here. So bluish color will be needed. So answer is 2. So close enough to 400 nanometers, which is blue color. Yeah, not red. We need blue color. No, not red. Red will have less energy. Red has bigger wavelength, no? So less energy will be there. Less energy will be there. When you go this side, more frequency, less wavelength. So more energy will be there. So if you go to red, less energy will not be able to remove that electron out. You will have lesser laddus than required. So you need more laddus. So you will go to more energetic light, which will be violet, blue, indigo type of color. Okay, understood? Yeah. So it is around this range. 400 is not exact number. 700 is also not exact number. That's a range just to keep in mind. So exact values you can refer to the charts. If you remember this much, it's more than enough to solve the questions. Okay. Let's go to Bohr's radius and all of that. Yep. Very, very important concepts, energy, everything. Ready, guys? Yeah. Very good. Very good. Let's go to Bohr's model. Now, key formulas. In an atom, by Bohr's model. The central nucleus obviously has a positive atomic number into electron charge, and the electrons will go in circular orbits with fixed energies and all of that. Those are standard. So if you take any electron with a negative charge, that will experience electric force towards the center, which causes that centripetal acceleration, which makes it go round and round. So that is one thing. So electric force is mass into centripetal acceleration. Not just that, you can also say angular momentum is principal quantum number Planck constant divided by 2 times pi. This is another important part of the Bohr's model of atom. Angular momentum is multiple of h by 2 pi, meaning it is quantized. You cannot have any random values. They are in specific quantas. From this, you get radius, speed, etc. Like the radius is always proportional to n square by z, principal quantum number square by atomic number. The speed is proportional to atomic number by principal quantum number of that electron. And lastly, the energy is proportional to z square by n square. But the formula, you better remember it, negative 113.6 z square by n square. Very, very important, guys. And needless to say, kinetic energy is negative of total energy, and potential energy is 2 times of the total energy. These are also valid. Okay, all these answers of electron volt only. Energy of an electron in an orbit is minus 13.6 z square by n square electron volt. Okay, standard value which you should remember. Okay, Bohr's model is only valid for singular electron models like hydrogen, helium plus, lithium double plus, because the moment 2 or 3 electrons come, they will have their own repulsions, which we have ignored in solving this particular problem. Okay, so let's see some questions coming up on your screen. The frequency of electrons orbit in Bohr model is proportional to principal quantum number raised to which power? That is the question. Which power of the principal quantum number? Let's solve. We have been asked the frequency, and we all know frequency is 1 by time period. Time period, there is no direct formula in Bohr. So time taken to revolve once is nothing but the circumference. Time is distance by speed. So circumference divided by the speed of the electron. Now speed we just saw is proportional to z by n, and circumference has radius. Radius is proportional to n square by z. So why not say velocity is some constant divided by n, and here radius is some another constant multiplied by n square. Yeah, because it is proportional, I can just use some constant of proportionality. So speed is v, circumference is 2 pi r. So v is some constant divided by n, radius is some constant into n square. So we'll get c by 2 pi k, n and n square will make it n cube. As you can see, this is a constant. So frequency is inversely proportional to cube of n. So it is directly proportional to n raised to negative 3. So the question mark will be negative 3. There you go. N raised to minus 3. Very good, Sabri. Awesome. Yes, I'm not only pushing myself, but I'm also pushing you guys. Pushing, pulling, everything. We need everything now. It's like if I just push, maybe you'll slip here. So I have to also pull you now so that you cannot escape anywhere now. Right? Great. Let's go, guys. By the way, I think this is one of the first marathons conducted by any channel. Forget English. I don't think any other channel is even done that right now, even Hindi channels, because everybody waits for last moment. We will push last moment. How much will you push? Now is the time to push. The only channel, guys, for you, if you think of JEE, this is the channel that you should think for, right? Okay, let's go. Next question on your screen. What does it say? Hydrogen like iron, the energy difference between second excited and ground is 108. Atomic number Z is asked. Yes. Yes, Tarak. Tarak Mehta, is it? What is your doubt? We are gifted by the great teachers. Definitely. Let's see. Hydrogen like iron, the energy difference between second excitation. A lot of students are going to think N is 2, right? That is wrong. N is 3. I know you guys are worked up, tired, but be alert, guys. N is not 2. Second excited state. Ground means N is 1. Ground means N is 1. First excited means N is 2. Second means N is 3. Third excited means N is 4. That's how the numbering works. Oh, and their difference is this much. So energy difference between the third and first is 108.8 electron volt. 108.8 electron volt. What is E3? Minus 13.6 Z square electron volt by N square. N is 3 minus 13.6 Z square divided by 1 square. Again, electron volt is equal to 108.8 E. E will get cancelled everywhere. So 108.8, of course. 13.6 is common along with the Z square, and minus minus is plus, and this will be 1 by 9, of course. Is that right? Great. So Z square, 1 minus 1 by 9 is 8 by 9, I believe. This will be 108 by 8 divided by 13.6. Okay, what next? How will it cancel? 13. Approximately it will go how many times? 8 times, I feel. Almost 8 times. Because 13 8s are 104. So 13.6 into 8 will be close to 108 or more than 104 for sure. So it will be almost 8 times. So now this 8 and this 8 cancels. Wow, what a nice calculation. So Z square by 9 is 1. So Z square is 9. So Z is 3. So Z is 3, which is option number 4. There you go. So many times you don't have to sit and actually divide. You have to just find it approximately, guys, because you don't have so much time in the examination hall, isn't it? Yeah. Very good. Very good. Great. This question, take it as homework. Yeah. It's very simple. You have to compare the energy levels using the energy formula. I'm pretty sure you'll be able to do it. Okay. Let's go. Logic gates. Wow, the last topic, guys. Wow, what's the time? What's the time? What's the time? It's 5 o'clock. 5 o'clock means how many hours, bro? 7 hours, huh? 7 hours straight? Done? Yeah, cool. Logic gates, and or not, NAND nor. Okay, we'll just go through all the operations first. Any mathematical operation at the base level can be converted as true, false, yes, no, 0, 1, low, high, 0 volt, 5 volt, like that. So they are called binary systems, and binary always has true, false, 0, yes, no, like that. And to perform any kind of complex operation, the base building blocks of those operations are called as the logic gates, like AND operation, OR operation, NOR operation, NOT operation, like that. So they are the base functions which can make up any kind of complex. Your artificial intelligence is also based on this only at the end of the day. Yeah. Let's go. So when you talk about AND, it means both outputs only when they are yes or true, only then the output is true. If one is false, one is true, or both are false, it will not give true as an output. That is the simplified version of AND. Okay. So Champa says, I will marry a Pandu who is rich and intelligent. Meaning the Pandu should be both rich and intelligent. Only then the Champa will marry Pandu. If Pandu is not rich or not intelligent, then Champa will not get married. Or operation means I'm okay, I'm little bit liberal out there. So I'm okay with one of the things should be true, but at least one should be true. Like Champa says, I will get married to a Pandu who is rich or intelligent. So if she checks the Pandu is either rich or intelligent or both, that's it. She will get married. If he is neither of them, she will not get married. That is the meaning of it. Not, I will not marry a Pandu. I will not marry a Pandu who is rich. She will check, Pandu, are you rich? Yes, I will not get married to you. Pandu, are you rich? He'll say, no. Oh, you're not rich. I'll get married to you. That is the meaning of not operation. You are inverting whatever is coming inside. If it is false, it will become true. If it is true, it will become false. If it is yes, it becomes a no. If it is no, it becomes a yes. That is not. NAND and NOR are nothing but AND gate with a NOT gate or OR gate with a NOR gate. That's it. You put in front of it a NOT gate, either AND or OR, you will get the NAND or a NOR gate. Now, if you see the operation symbol for AND it is dot, for OR it is plus, for negating it is bar. So, for a NAND gate, it will be this AND operation which is a dot, but you will put a bar over it. And for a NOR gate, NOR means OR will be there, which is plus, and you will put a bar over it, as simple as that. You can also expand this. You can also expand this. This is called De Morgan's principle. A dot B whole bar. You can separate the bars, A bar and B bar, and then this will become plus. That is one way. If A plus B whole bar is there, separate the bars, A bar and B bar, and put a dot over here. So plus becomes a dot. So this is also a simplified version which can be used in many questions, of course. Okay, keep these things in mind. Now, a NOT gate can also be made using a NAND gate or a NOR gate. Let me tell you that. Actually, these are universal gates and all of it. So, if you want to make a NOT gate, the symbol, by the way, I think the symbols were not given here. For AND, it is this. For OR, it is this. For NOT, it is this. For NAND, it is that AND symbol but with a dot over here, and for a NOR it is basically this with a dot over here. Okay, keep this in mind. You can also make a NOT gate with a NAND gate, but you have to short them. Or you can also take a NOR gate and connect the terminals. If you connect the terminals, no, it becomes a NOT gate. This is also a NOT gate. This is also a NOT gate. Yeah, this can be useful for solving some questions. Okay. Yeah. Yes, I made the symbol. Yes, De Morgan. Perfect. Very good. Hi, Krishika. Welcome aboard. Sir, any offer given after top rank in MVCT for batches? Yes. For the top ranks, you are getting scholarship prizes and also you are getting mentorship sessions anyways if you are participating and getting good ranks. So mentorship sessions are there. Yeah, and scholarships for all our pro batches and offline batches. Yeah, that's how it is. Okay, let's do some questions coming up on your screen. And here it is. The first question. Consider the following circuit. The output is 0 when, oh my God, there is no other option, but to sit and try everything. Yeah, the question is the output is 0 when, which of the following? Everything will have to sit and try. No other option. Let's say 1 and 1. 1 and 1. If our luck is good, first option will be only correct. If our luck is bad, then the fourth option, bro, will be correct. Let's see whether we are lucky or unlucky today. A is 1, so this is 1. B is 1, this is 1. A, this is 1, this will become 0. B is 1, okay. 1 and 1, and this is 1. 1 or 0, or means anyone should be okay. And this is 1, this is 1. So, This is NAND, right? So 1 and 1 is 1, but NAND of it will be 0. Oh, luckily for us, directly we got the answer. We are so lucky, guys, today. This itself is the right answer. A is 1 and B is also 1. Okay. Anything else? I think it will most likely not be 0. It will be either 1 only. Okay. Lucky day for us. Or else our marathon would have been extended by 3-4 more minutes. Okay. I think some truth table is there also on the next slide. Oh, see, 1 and 1 is giving 0. Everything else is giving something like 1. Okay. So lucky for us. It was just by fluke. Okay. Let's go to the next one. The following circuit is which gate exactly? Oh my God, the same diagram has come again, but they have asked, what is it exactly? Yeah, what exactly gate is it? That is what they have asked. Wow, what do we do? What do we do, guys? Come on, think about it. One of the gates, is it AND or NAND? What do you think it is? There is only one difference between this question and no, actually no difference only. Where is it? And yes, there is a small difference. There was no dot symbol here. Now, in this particular question, there is a actual dot symbol. Okay. So think either you draw truth table or if you can simplify, that is also fine. Either one of them. Either one of them. Okay. Either you can simplify or you can make a truth table out of it. What will you do in such a question? And some people are saying NAND. Some people are still confused and waiting for it. I'll tell you what, for deciding these kind of things, no, just try two things. Keep, let's say this is A, this is B, this is Y. Try out these things, like make this as 1, this as 0. Okay. That will immediately tell you many things and it will eliminate many options. Okay. Let's see. For a not to can't be an option. How is not an option? It's not needs only one input terminal. Doesn't make sense. Okay. So forget that. A is 1, B is 0. So 1 goes here, 0 goes here. A's 1 is going here, B 0 is going here. 1 and 0 is 0, but not will make it 1. 0 or 1 is 1, not will make it 0. 1 and 0 is 0, not will make it 1. So this is coming out to be 1. So it is very obvious that even 0 and 1 will be 1. Yeah, that is also clear because of symmetry in the diagram. Okay. Next, what you do, check whether for both are 0 or both are 1, what is happening. That's it. Most likely, you can check it for both are 1, say for example. Let's see what happens. This is also 1, this is 1, this is 1, this is 1. 1 and 1, 1, not of it 0. 1 or 1, 1, not of it 0. 0 and 0 is 0, not of it is 1. So 0 and 0 is getting 1 over here. Crazy. Now the last thing. What is it? Let's try out. Both are, what did I try now? Sorry guys, I gave a wrong thing over here. This is 1, this is 1, this is 1, this is also 1. Now we will try both are 0. Okay, now we'll try both are 0 and see what do we get. Okay, this is 0, this is 0, 0, 0, 0, 0, 0 and 0, 0, 1, 0 and or 0, 0, negative is 1, 1, 1 will come here, 1 and 1 is 1, negative is 0. So this is 0, guys. 0, 0 is 0. Which gate is this? Which gate is it looking like? Is it not looking like a OR gate? Is it not looking like a OR gate, guys? That's it, done. There you go. Perfect. That's it. That is the answer. Okay. Many of you said AND gate. No, it is not AND gate because see, if it was an AND gate, then 0 or and 1 should be 0, but 0 and 1 is 1. So from this, automatically your AND option gets eliminated. Getting my point? and operation itself gets eliminated. Yeah, let's go. Last question of today's session, and here it is. Last question. The output of the circuit is low. Output is low for which of the following inputs? This diagram I can simplify like this. This is a OR gate, okay? NOR gate, which is shorted, is actually a NOT gate. This is a NOT gate. So if I want my output to be 0, so before the NOT, it should be 1. That means the inputs should be either both 1 or one of them is 1, one of them is 0. Yeah. So when will you get output for a OR gate? This is an OR gate. At least one high should be there. At least one high should be there. So this is not possible. This is possible. This is possible, and this is possible. So B, C, and D. B, C, and D means third option. That is right. The third option. So logically speaking, we got the answer. Yeah, very good. Excellent. And that's it. That's it from today's session. What a session, guys. What a session. What a session. It has been phenomenal. Oh my God, where is our session going on? Wow, we have quite a few number of kids watching it. So see, today's session is also proof that initially you would have thought, who will watch for 7 hours? I didn't even tell, no, 7 hours I'm going to take. I just told 4 hours and you just went with the flow. That is what you should always do. You should keep smaller targets and slowly increase. Oh, I have done this much. Oh, I can do more. First, only if I tell, I'm going to take for 8 hours, half the audience would not have come. And that too just before Diwali. Sir, leave it now. So 3 hours I told. And I fooled you into thinking I will do it for 4 or 5 hours. Then 4, 5 became 6. You thought, okay, I've sat for 5, 6 hours. Let me sit for 1 more hour. What is there? Already 60, 70% done. I will sit for more 1, 2 hours. That is how you have to exactly sit and study. You cannot make very big plans. Make small, small plans. Push yourself. Push. Oh, I've done this much. I think I can do it. And before you realize, you would have done so much. And you will definitely overcome your laziness. You will definitely overcome your mental blockages. And I hope today's session was exactly that. More than learning anything, whether you learned Young's modulus or whether you learned lenses, doesn't matter. What matters is today you sat, you broke that chain of laziness and you got that momentum. That is what you have achieved today. Okay. So God bless you all. Kudos to all the kids who are watching it live or recorded. And I want these likes here. Come on. What you guys are doing. 260 and all. Shame. Shame on you guys. Spread this to all the kids in your batch, your friend circle, put it on WhatsApp, put it on status, whatever. Yeah. Your Capto Shreyas was live on a Sunday just before Diwali. More sessions to come. Tuesday and Wednesday, chemistry and maths. Okay. Stay tuned. And after that, even more dhamakas, even more blasts are coming. Bye bye. Take care. Have a great day.